Hello everybody and welcome to emintolucanedu.com. Today we are going to have our first math course. This course is created for students in order to allow them to achieve good scores on the SAT math section. Along the way we are going to cover many tips and tricks and strategies on how to achieve good scores on the SAT exam by being able to solve questions easily. The topic of today's discussion is linear equations and inequalities, graphs and word problems. This topic is extremely important, especially because the SAT is built on linear equations, and this topic will cover at least 10% of the SAT exam's mathematics questions. In order to introduce ourselves to the basic algebra of the SAT, we need to understand the analysis of graphs, construction of linear equations and inequalities, analysis of linear equations and inequalities, analysis of higher order equations like polynomials or quadratic equations, and we need to be able to solve equations and inequalities. We need to understand that basic understanding of graphs is extremely important on the SAT exam. Today we are going to start with basic terms that you need to know related to Cartesian coordinate system. In mathematics, we usually use the Cartesian coordinates as opposed to cylindrical or spherical coordinates. And the SAT exam includes questions related to this coordinate system. The first term that we need to know is the x-axis. X-axis is the horizontal line here. Now, y-axis is the vertical line of an xy graph, so this is the vertical line. Now let's talk about the origin. Origin is the center here. Point 0, 0 will be our origin. Some people do not know this, but origin is actually the center of the Cartesian coordinate system. Y-intercept is the point at which a line crosses the y-axis. For example, this purple point. Some graphs may have two y-intercepts, right? But we are not dealing with such graphs. Today we are going to deal with linear equations, and linear equations have one y-intercept. They can only pass that y-axis once. And finally, x-intercept. Well, obviously from y-intercept, where that is the point at which the graph crosses the y-axis, we can determine that x-intercept is the point at which a graph crosses the x-axis. For example, this line crosses the x-axis at approximately -1.9. Parabolic shapes like this may have one or more x-intercepts, and graphs of equations of higher order like a polynomial may have even more x-intercepts, right? So that is just for you to keep in mind. Now, let's talk about the equation of a line. Obviously, we know that whatever we can plot on a graph may have an equation. And of course, lines have their own equations as well. The equation is of a form y is equal to m times x plus b. Here, y is our vertical coordinate. M is the slope, and we are going to talk about this in detail in a few seconds. X is the variable, or the horizontal location of a point, and of course b is the y-intercept. We just talked about the y-intercept. That is the point at which the line crosses the y-axis. So we are going to talk about all of this in detail, but here we have 3 stars, and whenever you see 3 stars in these classes, please know that you need to memorize this equation by heart, because it is not provided on the SAT exam, and it is going to be of great use for you on the SAT exam itself. You are going to use this equation, and you're going to stumble upon equations of this form a lot. But for now, let's talk about this m, slope. Slope m is a constant number for linear graphs that describes how fast the line goes up or down. Basically, what I'm trying to say here is that how steep a line is will depend on its slope, right? So this angle right here, angle of inclination of a line, will depend directly on that letter m that will be described further. Sometimes on the SAT, slope is called rate, rate of change, rate of increase or decrease, or increase per unit time. For example, increase in cost of renting a boat per an hour, or increase in cost of living in America per year. This increase, whenever you see this word, this should be your clue that we're talking about the slope or the rate of change. And slope has an equation as well, and it goes like this: y2 minus y1 over x2 minus x1. Sometimes we also say rise over run. Now, what does that mean? This means that if you have a point of coordinates x2, y2, and if you have some other point of coordinates x1, y1, then you can create a line between those 2 points. And that line is going to have a slope m is equal to y2 minus y1, so the difference in the vertical coordinates, divided by x2 minus x1, the difference in the horizontal coordinates. To be precise, here we have coordinates 3, 4, that is, the x coordinate is 3 and the y coordinate is 4. And for that point we have coordinates 1, 1. So if you want to find the slope of this exact line, slope will be y2 minus y1, and we pick the upper point as the second point because that makes it easier for us to calculate the slope. So 4 minus 1 divided by 3 minus 1. Well, that gives us 3 over 2, and that is just 1.5. So this is the way we can calculate a slope for a line. Now there are different terms for slope. So slope can be positive. That is, if m is larger than 0, for example 1, 2, 3, 4, and so on and so forth, the line has to go up. So it looks something like this. We may also have a negative slope. If m is less than 0, then we have a negative slope. That is, m can be negative 1, negative 2, negative 3, and so on and so forth. Here, the line is going down. That is, if we go from left to right, so like this, the line is going downward. It's facing downwards. So any line with a negative slope will be going down like this. And it doesn't matter. Maybe the slope is negative, but it's small. So still, the shape of a line will be something like this, right? Or maybe something like this. This indicates that the slope is negative. Now, what happens when we have a zero slope? That is, there is no slope at all. Well, then we have a constant line that is horizontal. So m is equal to 0, the line is horizontal. And here we are going to discuss constant graphs. So when y is equal to constant, for example, y is equal to 3, we may have a horizontal line. This is what we just discussed. Here, the slope is 0. Now, when x is equal to a constant number, for example, x is equal to 1, that means we will have a vertical line that passes through x is equal to 1. So please keep this in mind. Now, recall that we said that slope can be also named as the rate of change. So sometimes on the SAT, when you stumble upon the word rate of change, this expression indicates that the question is about the slope. And slope can be characterized as steep or almost horizontal, right? So here, the steepness of the slope decreases from pink to purple to orange, right? So the slope is decreasing like that. And finally, the line may become perfectly horizontal. Now let's look at an example. According to the graph above, between which two consecutive years, well, consecutive means one after the other, for example, 12, 13, 15, 16, right? So here we have 2003 and 2004. Well, anyway, between which two consecutive years was there the greatest change in the number of 3D movies released? Well, we see here change, so greatest change. Well, this indicates that the question is asking for the greatest slope. Remember, we said slope is a rate of change, greatest change, smallest change. Smallest change is here. There is no change, right? It's absolutely horizontal. Between years 2003 and 2004, number of 3D movies released didn't change, so it was 1. But when we look at years 2010 and 2011, there is a rapid growth, right? So there's a growth, and that indicates that when the line is almost vertical or close to vertical, right? Close to vertical like this, we have the greatest change. That means between years 2010 and 2011, there was a rapid improvement in the release of 3D movies. Well, the answer to this question then is D. Now let's talk about y-intercept. Remember we said y-intercept is the point at which the graph of a line crosses the y-axis. Well, in the equation of a line y is equal to mx plus b, y-intercept is characterized as b, so it's a constant and it's added to slope times x. For example, for the equation y is equal to 2 times x plus 3, we would have y-intercept at point 3, and since slope is 1, for each unit to the right, so for each unit to the right we would go 2 units upward, right? So this would be our second point. Now in a few seconds I will tell you how to draw lines given the slope, but for now you have to know that connecting those lines will just be enough. Connecting those points would just be enough to get our line. So this is our purple line that is characterized by this exact equation. Here you can see that y-intercept is 3. Now let's give another example. Y-intercept can also be negative. For example, y is equal to negative 2x minus 3, right? So here we have a y-intercept of minus 3. That means line passes through this point and it has a slope of negative 2. So for each unit to the right we go 2 units downward and we put another point. Then we connect those 2 points like that and we get our line. So this is our line. The red line is characterized by this exact equation. Now let's look at a question. Sometimes on the SAT exam you're asked to construct an equation from a given data and solve that equation. As an example, we may get a question like this. So we're given a table of x values like 1, 3 and 5 and f of x, so y values, that is function of x, 5, 13 and 21, and we are asked some values of linear function f are shown in the table above. Which of the following defines that f, that function? So which one of those is the equation that would allow us to create a table like this? Well, the best way to solve such questions is to first find the slope from the data here. Now, we know how to find the slope. The equation of slope goes like m is equal to y2 minus y1 divided by x2 minus x1. Now pick any point. Here we have points 1, 5, and here 3, 13, and here 5, 21. Now let's pick this point as the second point, and let's pick this one as the first point. Then we are going to get a slope of m is equal to y2, which is 21, so 21 minus y1, which is here 5, right? Divided by x2 minus x1, so 5, this is x2, minus 1, this is x1, so 5 minus 1. And that gives us 16 over 4. We know that 16 over 4 is equal to 4. And the only linear equation in the answers with the slope of m is equal to 4 here is choice C, right? So C is the correct answer. But we may get a different case here. What if they had two choices that contained slope 4? So for example, what if the answers were not this type, but one of the answers would be f of x is equal to 4x minus 1. And we have now two answers with a slope of 4. Well, what do we do then? Then we must look at the y-intercept, right? Which one of these is the correct y-intercept? So let's take a look here. We have already found that in the equation y is equal to m times x plus b, m is going to be 4. So let's rewrite y is equal to 4 multiplied by x plus b. Now we're trying to find b. In order to find b, we can plug any of these values, for example, any of these points into this equation, y is equal to 4 times x plus b. Let's plug f of x is equal to 21 and x is equal to 5. So 21 is equal to 4 multiplied by 5 plus b. From here, we can simplify 21 is equal to 20 plus b. Well, therefore b has to be 1. b is equal to 1. And we can replace this b here by 1, right? So our equation is y is equal to 4 times x plus 1. C is the correct answer. So this is what you do when you stumble upon answers where two slopes are the same. But my advice to my students, and it's actually very important, that you start from the slope. Find the slope using the equation m is equal to y2 minus y1 divided by x2 minus x1, and from here you will be able to determine the correct answer. Now let's talk about perpendicular graphs. Well, sometimes on the SAT you are asked to find the equation of a line that is perpendicular to some other line. And when we say perpendicular, we mean two lines have an angle of 90 degrees between them. In order to do that, let's give an example. Let's say you have a line y is equal to 2 times x plus 1, right? And it looks something like this. So we put a point at 1, then we jump 1 unit to the right, and since slope is 2 units upward. Here we have our second point. So we need to connect these 2 points. So the line should look something like this. Now we are asked to find the line that is perpendicular. So some black line that is perpendicular, that has a 90-degree angle with the red line. Now, how do we find the equation of this line? How can we do that? Well, the first thing that we need to find is the slope of that black perpendicular line. To find that slope, we need to take the negative reciprocal of the slope of the line that you already have. So we have the equation of the pink line, and that slope is m is equal to 2. So m is equal to 2. In order to find the slope of this black line, y is equal to mx plus b, we take the negative reciprocal. That is, we divide 1 by that slope m, so that is 2, and we change the sign, so minus 1 over 2. Now the slope of that black perpendicular line will be negative 1 over 2. Again, I will repeat myself again. In order to find the slope of a line that is perpendicular to y is equal to 2 times x plus 1, you need to take the slope of this pink line, and that is 2, and you take the negative reciprocal. So you divide 1 by that slope, which is 2, and change the sign to negative, right? So your new slope, the slope of the black line, is going to be y is equal to negative 1 over 2x plus some y-intercept b. Well, in this case, right, the y-intercept is 1 because the line is passing through point 0, 1. So this line's equation is y is equal to negative 1 over 2 times x plus 1, right? So that's the black line. Now, what if a line has already got a negative slope? So, for example, this line right here, y is equal to negative 1 over 2x plus 1. And we need to find a line that is perpendicular to this pink line, so something like this. How can we do that? Again, we look at the slope of that purple line, the line that we already have and the equation that we already have. The slope here is negative 1 over 2, so we flip that. We take the negative reciprocal of that, right? And when we flip it, the slope is going to be just 2 over 1, right? We flipped it. So we flipped it. And we changed the sign, so negative reciprocal. We flip and change the sign. It was negative, now it's positive. So it's basically going to be 2. So y is equal to 2 multiplied by x plus that y-intercept. What is the y-intercept here? It's 1. So y is equal to 2x plus 1 is our equation of the black line. Now, what if the equation is not in its original form? So we see here there is something different. The equation of a line that we have covered has a form y is equal to m times x plus b. Well, what is this then? Don't be afraid in such cases. What we need to do in order to find the perpendicular line to some line of this equation, we first need to convert this to the original form y is equal to mx plus b. So let's do it. Let's rearrange the terms here. So send y to the right side, we get 3y is equal to 2x, well, negative becomes a positive when we throw it to the other side, plus 6. Now let's leave y alone. This is our purpose. Y has to be alone. It has to have a multiple of 1. And therefore, let's divide every term here by 3, right? This way we will be able to leave y alone. So y is equal to 2 over 3x plus 2. This is our equation of a line in the original form. So that's this line. Y is equal to 2 over 3x plus 2. Now our purpose is to find an equation of a line that would be perpendicular to this. So what do? We take the negative reciprocal of the slope. So that line would have a slope. Well, we flip the numbers here. Denominator becomes numerator. Numerator becomes the denominator. So we flip. We get 3 over 2, and since it's a negative reciprocal, we also add a negative here, right, times x plus some y-intercept b. Well, in order for a line to be perpendicular to some other line, it does not necessarily have to have the same y-intercept. It can be perpendicular anywhere, right, anywhere. Therefore, that y-intercept is not always important. Now, you may notice that answers have a form like this. So they do not have a form y is equal to mx plus b. They have some other form. That's why we need to convert our answer to that form now. So let's add negative 3 over 2x to both sides. What we get is 3 over 2x plus y is equal to b. Now, in order to get some sensible answer, what we need to do is we need to get rid of this denominator. So what do? We multiply every term in this equation by that denominator in order for that to cancel out. So what we get is 2 cancels out with 2. So we get 3x. Then 2 is multiplied by y. So we get plus 2y is equal to 2 is multiplied by b. So 2b. Now again, do we care about this? We don't care. It's just a constant number. The answer that contains 3 times x plus 2 times y is the correct answer. Well, in our case, it's a, right? So this is the way we find the equation of a line that is perpendicular to some other line. Now, let's talk about another concept, a zero of a function. Sometimes on the SAT, they say, what is the zero of some function, for example, some line. When they say zero of a function, please keep this in mind. You have to think about the x-intercept of that function. So the zero of a function is, or are, if there are many zeros, the x-intercept of a function. Let's give some examples. So for this function, this line here, the 0 or the x-intercept is x is equal to 0. For this function, it is x is equal to 3. And in the 4th class, we're going to be talking about parabolas. So for parabolas, you sometimes may have 2 zeros. So here we have 0, and here we almost have 3, right? So it may cross the x-axis on more than one point. Now let's practice. Please pause this video in order to be able to solve each question by yourself, and then unpause it to see my solution. Question number 1. Which of the following is the graph of the equation y is equal to 2 times x minus 5? Well, first thing we do is we look at the y-intercept in such cases. Y-intercept is negative 5, so line must cross the y-axis at negative 5. Here, line is crossing the y-axis at 2.5, so this goes away. This cannot be the answer. And here, it's crossing the y-axis at 5, so this is also not the answer. Now, we are left with two answers, B and D, two choices, right, that contain a line that crosses y-axis at negative 5. The second thing that we must look at is the slope. Since here the slope is positive, right, the line has to go, so to say, upwards from left to right, and therefore choice D is the correct choice. Second question. Try to solve this by yourself. Now, the graph above shows the distance traveled d in feet by a product on a conveyor belt m minutes after the product is placed on the belt. So on x-axis we have m, that is time in minutes, and on the y-axis we have the distance in feet, right, and that's d. Which of the following equations correctly relates d and m? Well, here we need to understand that instead of y is equal to m times x plus b, we have d is equal to m times m, which is slope times the variable plus b. Now be careful, this m here, it's a constant number. This m here is a variable, so they're different. Multiplication doesn't give you m squared. Please be careful. Now let's find the slope here. For 1 unit to the right we go 1, 2, 2 units upward. So rise over run, right? How many units you go up divided by how many units you go to the right? Well, that's just 2 over 1. That is 2. Slope is 2. So d is equal to 2 times m plus b. Now, what is b? What is your y-intercept here? We can clearly see that the line passes through point 0, 0, right? So here your b is going to be 0. d is equal to 2 multiplied by m, and that is your answer. Your answer is A, and that is the equation that describes this line. Now, let's try to solve the third question here. In the xy plane, the graph of which of the following equations is a line with a slope of 3? Well, we know that slope in the equation y is equal to m times x plus b is m. And if slope is 3, then y is equal to 3 times x plus any b will be the correct answer. Here we have C, right? So y is equal to 3 times x plus 2. Let's go with another question. The table above shows some values of the linear function f. Which of the following defines f? Now, here you may notice that we have already solved this type of question, and in here my advice was for you to first determine the slope. In order to determine the slope, we use the equation m is equal to y2 minus y1 divided by x2 minus x1. And here we can pick any point as the second point, for example this one here, function of n and variable of n, so x comma y or n comma f of n, right, would be our second point. Now let's pick the first point. This one looks okay. So this is also the first point. Alright, now let's find the slope. M is equal to, well, here we got y, but we can convert it to f of n2 minus f of n1 divided by n2 minus n1. So f of n2 is 7, and f of n1, function of n1, is 1. Now n2 is 4, and n1 is 2. So the slope is the division of those subtractions, differences, right? So that's 6 over 2. Therefore, the slope here is 3. Now, which of the choices has m is equal to 3, slope is equal to 3? The only choice that contains slope is equal to 3 is C. So C is your correct answer. Now, let's think about a concept of slope as a fraction. For example, sometimes on the SAT exam, you may stumble upon functions like this. Y is equal to negative 3 over 2x plus 1. How do we draw those lines? Well, the idea here is that denominator of the slope fraction will be your run, so movement to the right, okay? So that's your movement to the right. And the numerator here is going to be rise. So that's how much you go up or how much you go down. The rise, right, so how much you go up or maybe how much you go down depends on this sign. If this is negative, that means you will go down. If it's positive, that means you will go up. So we put a point at the y-intercept. So this is your y-intercept, and we put our first point here. After that, we are going to run. So we run 2 times, right? So 1 and 2. And we are going to rise. Now, since it's negative here, we are going to fold 3 units. So 1, 2, and 3. And this will be our second point. By connecting these 2 points, we will get the line that would describe this equation. So the orange line here is the curve described by this equation, y is equal to negative 3 over 2 times x plus 1. Now let's repeat it. We started at the y-intercept. We went running, so 2 units to the right, right? So run is the denominator, 2 units to the right, and rise or fall. So if it's negative, then we fall. So 1, 2, 3 units falling, and this is our second point. Now let's have another example. Let's say we are interested in the graph y is equal to 4 over 3x plus 2. What we do here is, again, we start at the y-intercept and we go running, so we go 3 units to the right, denominator units to the right, and, well, 4 units upward, because now we rise, it's positive, so we go up 1, 2, 3, and invisible 4, somewhere here. And we connect the dots now, so the line will look something like this, right? Please keep this in mind. So now we have covered linear equations. And this was basically everything you needed to know to solve easy, medium, and hard problems related to basic linear equations. And right now we have another very important thing to cover, and that is systems of linear equations. You may have heard of a concept of systems of linear equations before. And right now we're going to discuss why this topic is very important for the SAT exam and how do we use it. Now let's introduce ourselves to the concept of systems of linear equations. A system of linear equations, right, is when you have two or more lines on the same plot described by linear equations. So basically saying, when there are two or more linear equations somehow related to each other, that is, maybe they're on the same plot, right? So we call this a system of linear equations. Here we have a system of linear equations. We have two equations that describe lines plotted on the same plot. Now you may see that they are related to each other. That is, they have an intersection, so they cross each other at this point. Now, when two lines cross each other at some point, we call this an intersection, and you will see that it's a solution of a system of linear equations. A solution of systems of linear equations is the point x comma y where the two linear equations cross each other. Well, maybe you have more than two lines, maybe you have 1,000,000 lines and they cross each other at that point. That would be the solution of 1,000,000 equations, right, that cross each other. But here, and on the SAT exam, we're only dealing with systems of two equations, and therefore you don't need to worry about anything. The point here is that point, so it's 1 comma negative 1, may satisfy, that is, make these two equations equal to each other in such a way, right, when you plug the x coordinate here. So for example, plug x coordinate 1 into this equation, y becomes negative 1, right? So 2 minus 3 is negative 1. And again, plug this x coordinate into this equation, and what you will get is, again, negative 3 times 1 plus 2, that's y is equal to negative 1. So you get y is equal to negative 1, y is equal to negative 1, x is equal to 1, x is equal to 1. This is the point where two lines cross each other. Now we may ask ourselves, how many solutions may such a system have? Of course, we need to introduce ourselves to as many case scenarios as possible for the SAT exam. And it turns out that there are 3 cases. A system may have one solution, no solutions, or infinite solutions, that is infinitely many, like millions, billions of solutions. Let's take a look at each one of those one by one. When a system has one solution, that means there is one point where two lines intersect, that means cross each other. And usually we can determine where this point is, so we can determine its x, y coordinates. You may notice that for a system to have one solution, that is for two lines to cross each other at some point, you must have different slopes, alright? So the slopes of those two lines are different. One of those slopes is positive and one of them is negative, and it's always like this. One slope has to be positive and one slope has to be negative for two lines to cross each other at some point. Now the second case here is when a system has no solutions. In that case, we say that slopes are the same. So for two lines, the slopes are same, so they are parallel. Please remember that relationship. When two lines are parallel, well, they have no solutions. This system has no solutions. That means these two lines, they never cross each other. They do not cross each other. They're always parallel. Well, slopes are same. That's the first condition. And y-intercepts are different. That is the second condition. When these two conditions are satisfied, right here we have different y-intercepts. When these two conditions are satisfied, we can say that a system has no solutions. And the third case scenario is when you have two absolutely same lines plotted on the same plot. That is, if you have y is equal to, for example, 2x plus 1, this is just an analogy, right? And 2y is equal to 4x plus 2. Although these two equations are written in a different form, here you have a multiple of 2, these two equations are absolutely the same. Their y-intercept is the same, right? And their slopes will be the same if you just divide everything by 2 here. And therefore, these two equations will lie on top of each other. That means they will cross each other infinitely many times. And that means that system has infinite solutions, so infinity. Now you may wonder, alright, so we know three scenarios where systems of equations may have one solution, no solutions, or infinitely many solutions. But how do we solve that? How do we find that point without knowing the graph? Well, there are three ways to solve systems of linear equations. First one, of course, is graphing, and it's obvious. We've been using graphs so far. The second method to solve systems of linear equations is substitution, and we will talk about it in a few seconds. Last but not least, we have the elimination method. Now we must know when to use each one of those because there are different cases, and therefore we must be aware of situations when one of those has to be more efficient and faster and easier to use. So let's talk about solving by graphing. We graph the first equation and then graph the second equation. After that, we find the solution by looking at the point where two equations intersect. But before we graph, we must bring two equations into the form y is equal to mx plus b in order for it to make it easy for us to graph. Now let's see an example. Here you have x plus y is equal to 3. Now let's bring this to the form y is equal to mx plus b. Leave y alone, throw x to the other side. Y is equal to negative x plus 3. And let's graph it right now. So y-intercept is 3 and slope is 1 to the right, 1 down, negative 1 right. And so we need to connect the dots. So let us connect the dots here. Well, this is the perfect graph of this equation. And now let's do the second one. So x minus y is equal to 1, leave y alone. Negative y is equal to negative x plus 1, and we need to have a multiple of 1 in front of y, so multiply everything by negative 1 to make this y positive. Y is equal to x minus 1, right? So you see, here you have a negative slope, here you have a positive slope. They must cross each other somewhere, and so y-intercept is 1, slope is 1, so we go 1 to the right, 1 up, and we connect the lines. And here you go. Now you can clearly see the point of intersection. That point is 2, 1, right? So we can clearly see where these two lines cross each other. Now let's make sure that this works. In order for this to work, right, in order for that to be a solution, point 2, 1 must satisfy both of these equations. So when you plug this point in here, they must be true, right? They must be equal to whatever they're equal to. So let's see. Let's plug x is equal to 2 and y is equal to 1. 2 plus 1 is equal to 3. That is true. And the other one, x is equal to 2, y is equal to 1. So 2 minus 1 is equal to 2 minus 1 is equal to 1. Well, both equations are satisfied. Both linear equations are satisfied. That means the system is satisfied. That means this is a point of intersection, and therefore it's a solution to this system. But what if I don't have a lot of time? And what if I don't want to graph anything? What happens then? Well, then for that we have another method, and that method is called substitution. Well, what we do in substitution, the first step is we simplify. So we bring the equations into a form where we know one term. For example, x is equal to something something, y is equal to something something. Then we solve one equation for either variable. For example, we try to find x, or we try to find y first. And then we substitute that into the beginning. So we already have x, for example, we substitute everything back. And we solve for the remaining variable. Now let me show you an example. Such things are learned by solving examples. So let's have a system like this. 3x minus 2y is equal to 6 and x minus y is equal to 1. Now how can I find the solution? Substitution method here. Substitution. Let's solve for x. So the first step should be to solve for one of those variables. Leave it alone. X is equal to, throw y to the other side, y plus 1. Now we know what x is. X is equal to y plus 1. Take this x, right? Take this y plus 1 and plug it here instead of x. So what we do is we write 3 times y plus 1 minus 2y is equal to 6. Now simplify. Spread this 3 into the parentheses. So 3y plus 3 minus 2y is equal to 6. And now simplify further. So y is equal to 3. We have already found the value of y. For that solution point, y will be 3. Now let's find the x coordinate. So plug this y is equal to 3 back here. So we plug it back, right? Step number 4, solve for the remaining variable. We plug everything back. X is equal to y plus 1, so 3 plus 1, and therefore x is equal to 4. Now, this is our solution. 4, 3 is the point at which two equations have the same value, and therefore two lines intersect. Now, let's try and see if that is correct. So let's see. 3x minus 2y is equal to 6. So 3 times 4, that is 12, minus 2y, that is 2 times 6. 2 times 3, that is 6. So 12 minus 6 is equal to 6. Is that correct? Yes, that is correct. And x minus y is equal to 1. So 4 minus 3 is equal to 1. That is also correct. That means both equations are satisfied by this point, and therefore this is a solution to this system of linear equations. That is this one. Now, for harder systems, or for systems where you cannot leave one of those alone, right? So you cannot either leave x alone or y alone, you may have hard time solving such a system, and therefore we have another method. It's called the elimination method, and it is used when both equations are in a form ax plus by is equal to c. So multiple times x plus multiple times y is equal to c. Right? So the first step is to simplify. Second step, multiply one or both equations by a number that will create opposite coefficients for either x or y if needed. That means we will find some constant to multiply one of the equations in the system to create opposite coefficients, and I will show you in a second what that means. Then we add two equations, so we have a system of two equations, we add them, and then we solve for a remaining variable. For example, let's have a system here, right? We have a fractional system, 1 over 2x plus 1 over 3y is equal to 13, and 1 over 5x plus 1 over 8y is equal to 5. Now, before I work with this, I want to simplify this further, alright? Because I don't like the way it looks. So I want to get rid of those denominators. I want to get rid of those fractions. Therefore, I must multiply each one of those by the least common denominator. In order to find the least common denominator, LCD, we multiply denominators 2 times 3. Least common denominator for the upper function is 6. Least common denominator for the lower equation is 5 times 8, 40. So let's multiply each of those. So the first one, 6 times 1 over 2x plus 1 over 3y is equal to 13. Multiply everything by 6, that is, open the parentheses. 3x plus 2y is equal to 78. Alright, so this is our first equation that we will be dealing with. So 3x plus 2y is equal to 78. Now let's multiply the bottom equation by its least common denominator. So 40 times, in parentheses, 1 over 5x plus 1 over 8y is equal to 5. Multiply everything by 40, you get 8x plus 5y is equal to 200. So 8x plus 5y is equal to 200. Now we have a perfect system. No fractions and nothing to distract us. How do we solve this one? In order to solve such a system of linear equations, we must either make this 8 or we must make this 5. So we must have same coefficients. Then we must subtract both equations from each other. So let's make this variable here, let's make it 8. Right? And you will see what I'm trying to do. So in order to make 3 8, we must multiply it by 8 over 3. Right? So we multiply everything here by 8 over 3 in order to make this like this. After multiplying everything by 8 over 3, we get 8 times x plus 16 times y over 3 is equal to 208. Now what we can do is we can subtract this blue equation from that orange one, right? So we can subtract everything here. Think about this like a term-by-term subtraction. So 8x minus 8x gives you 0. 16 over 3y minus 5y, well, that leaves us with 16 over 3y minus 5y. Well, we can simplify this further. Write 5y as 15 over 3y, because these are the same things, and when you subtract everything here, you get 1 over 3y, and that is equal to 208 minus 200, right? Because we're subtracting from the bottom, so that gives us 8. And we got 1 over 3 times y is equal to 8. Wow, we have already found y just by making those the same and subtracting everything, right? And so y is equal to, multiply both sides by 3, you get y is equal to 24. Great, amazing. Now we have the value of y. Sometimes on the SAT you're only asked to find one variable, for example y, and there elimination method is perfect to use. Just eliminate the one that you do not need. Here we didn't need x, for example, so we eliminated it by making those multiples same. But from here you can find x, so you can use either this one here or this one here. Just plug y is equal to 24 in each one of those, alright, and try to find x. Let's plug y is equal to 24 in here, right? And so what we will get is 8x plus 5 times 24, which is 120, is equal to 200. Now 8x rearrange, so throw 120 to the other side, is equal to 80. And so x is equal to 80 divided by 8, x is equal to 10. We have found y and we have found x. So x is equal to 10, y is equal to 24. And therefore the solution here is 10, 24. Alright, so this point right here is the coordinate where these two lines can cross each other. So that was the way how you solve systems of linear equations. We have seen 3 methods and we have said that 2 of those are effective on the SAT exam. So we may use graphing when we have a lot of time and when we can graph or when we can see 2 lines. We can use substitution when we have a short question where we can solve for either x or y very fast. And we said we can use elimination method when we have harder problems because it makes it easier for us to eliminate something, right? And therefore get rid of either x or y. So elimination method is basically useful when you only need one variable like y or like x. And when you have a system in the form ax plus by is equal to C. Now, sometimes in mathematics, we need to use systems of linear equations to solve word problems, that is, written problems. Now, let's look at an example. The cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance at the circus is 2,000 people, and the total gate revenue is 70,000. How many children and how many adults bought tickets? This question is actually easy when you know how to solve it, and we solve such types of questions when we need to find two variables or two unknowns. We solve those using systems of linear equations. We need to construct two linear equations and then solve and find the solution. That solution will tell us the exact number of children and adults. So let's do it now. The first equation is going to be about money, alright, because we have dollars here. So $25 times children plus $50 times adults, and notice I don't write names here because using shortcuts like C and A is much more efficient. So that is equal to, how much was the revenue? 70,000. So that is equal to 70,000. And now we have come up with an equation for money. What else do we have? We have information on how many people came, attendance, so people, right? And there were children and there were adults, and the amount of people is 2,000 people on that day. Now we have a system of linear equations and we already know how to solve it. So let's solve it together. What we can do here is we can use the elimination method or the substitution method. Well, since we need children and adults, so how many children were there on that day and how many adults were there on that day, right? Since we need two of those variables, using substitution may be a bit better. So let's use substitution. Solve for C first. C is equal to 2,000 minus A. And now we can plug this C right here, right? So 25 times 2,000 minus A plus 50 times A is equal to 70,000. 25 times 2,000, that is 50,000. 25 times negative A is negative 25A. Then we have plus 50A, and that gives us 70,000. Let's have constants on one side and variables on the other side. So 25 times A is equal to 20,000. And from here, by dividing both sides by 25, we get A is equal to 800. Now we have found the amount of adults that were there on that day. So there were 800 adults. What about children? Well, we know the second equation that we have constructed. C is equal to 2,000 minus A. So children is going to be 2,000 minus 800, which is 1,200. There were 1,200 children and 800 adults in that circus on that day. Now here's a practice problem for you. So you may stop the video and try to solve this. The answer to this problem is this: 700 children and 950 adults bought meal tickets on that day. Alright, so this is your answer, and if you found this correctly, then that means you understood how to solve systems of linear equations and how to construct those systems knowing some information. Now the type of the question that is asked usually on the SAT exam about systems of linear equations in word problems is this. So they have some information, and on the choices A, B, C, D, they have constructed systems of linear equations. We just need to find the one that suits our situation. So let's read the situation first. Remember, in such questions, right, the question begins at the last sentence. Which of the following systems of equations could be used to find the number of tickets for bench seats B? So B is bench seats, right? So when you see B here, that means bench seats, right? And the number of tickets for lawn seats, L. So L is lawn seats that were sold for the concert. Now let's read the statement here. Two types of tickets were sold for a concert. Tickets to sit on a bench during the concert cost $75 each. So again, let's construct an equation for money. So $75 times benches plus tickets to sit on the lawn during the concert cost $40. So plus 40 times L, and that must be equal to dollars, so 19,250. So 19,250. Well, in such questions, multiplication of terms is usually not convenient, therefore this is not the answer. Now we have 75b plus 40l, so this is also not the answer. And we have that equal to dollars, 19,250. So your only choice with the correct answer here is D. Now this is pretty much it. Today we have learned how to solve systems of linear equations and how to construct them for the word problems. We have also went over linear equations and their problems. We have learned the term slope and y-intercept, and we have introduced ourselves to the Cartesian coordinate system. Thank you very much for watching this class. If something was not clear, and if you want to contact me to ask more questions, feel free to do so using my WhatsApp number or the email address. Take care, and I'll see you in the next tutorial. Hello everybody, and welcome back to our SAT math course. Today we have an important topic, and it's the continuation of the topic that we have covered before, so the continuation of linear equations. We are going to cover in this video systems of linear inequalities and their graphs. And this one is very important because many people do not know why we have inequalities. But before that, what are inequalities? Linear inequalities could be of these forms. So f of x is bigger than mx plus b, smaller than mx plus b, bigger than or equal to, or larger than or equal to mx plus b, and smaller than or equal to, or less than or equal to mx plus b. So this sign here is greater, this one is smaller, so this sign, this one right here is less than or equal to, and this one right here is more than or equal to. Basically speaking, if you have signs like bigger than, smaller than, less than or equal to, larger than or equal to, then this is an inequality. And if you have a linear equation next to it, so equation of a line mx plus b, then it's a linear inequality. Linear inequalities represent a relationship between a variable x, so the one that we know it's on the x-axis, anything on the x-axis, and the function of x, f of x, alright? So there is a relationship, and inequalities are telling us about that relationship. They tell us about an area of the graph where we have a solution to the inequality. Alright, so in past we were talking about points on a line, and those points would satisfy that equation. But now we are going to talk about areas, and within those areas there are certain points that satisfy inequalities. So let's think about it. And the best way to think about it is by solving an example. So example is here, y is bigger than x plus 2. So how do we solve such an example? The first step is to equate this. So make this an equation, y is equal to x plus 2. After that, you have to draw it. So draw this line on the xy plot. So the y-intercept is 2 and the slope is 1. So we go 1 to the right, 1 up. Well, this is our line. The last step is to shade the region, so shade. But which region are we going to shade? We're going to shade the region that is above x plus 2, so that is above that line, alright? So when we have larger than, we are going to shade the region above the line. So we shade it like this. So what does that mean? That means the region above the line y is equal to x plus 2 contains solutions that are points that would make this inequality true. So they would satisfy this inequality. Satisfy, right? When a point satisfies an inequality, it makes it true. So let's try any point here. Let's try this point, this black point. It has a coordinate -3 comma 2. Now let's try to plug x is equal to negative 3 and y is equal to 2 into this inequality right here. So 2 is bigger than negative 3 plus 2, and that gives us 2 is bigger than or greater than negative 1. Well, this is correct, and that means inequality is satisfied. That means this point is a solution that satisfies this inequality. And basically saying any point x comma y in that region is going to satisfy our inequality. So here's a note for you. Any point in the shaded area satisfies a linear inequality. Now let's solve 3 more examples. So y is greater than or equal to x plus 2. So the first thing we do is we equate. Y is equal to x plus 2. Then again, we draw the line. So here is a line that represents this relationship in the xy coordinate plane. Now let's shade. Since we have greater than or equal to, we not only shade the region, which is above that line, so we shade that region, but we also shade the line itself. That means any point that lies on the line also satisfies this inequality. Let's try any point on this line. So this point, for example, 0, 2. Now try to plug this into this inequality. 2 is bigger than or equal to 2. Well, since we say bigger than or equal to or greater than or equal to, well, 2 is equal to 2, so yeah, that point satisfies this inequality, and therefore we can consider it as a solution to this inequality right here. And of course, any point above that line, because we have greater than, so any point above that line also satisfies that inequality. But what about y is less than x plus 2, or y is smaller than x plus 2? Again, we draw the line and then we shade, but we shade the region that is below that line because we have less than. That means any y coordinate is going to be below the line. So any point is going to be below the line, and that point will satisfy this inequality. Okay, so let's try any point again here. So let's try the easy one, right? Let's try 3, 2, this point right here. 2 is less than 3 plus 2. Well, that is correct because 2 is less than 5. And so this inequality is satisfied. And the same thing goes for less than or equal to, but here we are also shading the line. So any point can also be on the line, and that point can satisfy that inequality. And of course, since we have less than, we also shade the region below the line like this. Now, we have already learned what inequalities and linear inequalities are. But what about systems of linear inequalities? I hope you remember what the system is. In the last video, we have covered what a system of linear equations is. We said that a system of linear equations is a set of 2 or more linear equations. For inequalities, a system of linear inequalities is a set of 2 linear inequalities that depend on each other. Alright, it can be 2 or more, but on the SAT we're dealing with maximum of 2 inequalities on the same graph. So for example, we have y is greater than or equal to 2x plus 3 and y is less than or equal to negative x minus 1. This is a system of linear inequalities. Now, we said that systems have a solution, and when we talked about systems of linear equalities, we said the solution is that intersection, that point where 2 lines cross each other. What about inequalities? What is a solution of system of linear inequalities? Well, here we will try to find points. So there are many points, x comma y, that satisfy the system of inequalities. So those points will make this true and they will satisfy this one as well. Let's have an example. Find the area or sets of points where there are solutions to the system of inequalities above. So this one. Now, the first step that we needed to perform is we needed to equate, right? So we need to equate those. Let's start with this one. So we equated y is equal to 2 times x plus 3. Now we put a dot on the y-intercept and we go 1 to the right, 2 up. This is our second point. Now we connect the points. Right, so this is our first line, and it's the line of this inequality. Now let's do this second one. So we equate y is equal to negative x minus 1, and then we draw it. So y-intercept is negative 1, and we go 1 to the right, 1 down. So we run and we fall right? And we connect the dots. Now we need to shade. So let's shade the first one. Y is larger than or equal to or greater than or equal to 2x plus 3. So we shade the area above that line. And we also shade the area right above it and the line itself. So because line also contains solutions to this inequality. Now let's do the second one. So we shade the area below this blue line because it's less than or equal to negative x minus 1. So we shade that area. Now you may notice here that we have a blue area, a red area, and a combined blue and red area. Well, why do we have that combined area? It turns out that this combined area is the area that satisfies the system. Alright, so this area right here, this combination of red and blue areas is the area that contains all of the solutions to this system of inequalities. Now let's try to pick any point in that area. I see negative 4 here, so I will want to pick that one. So we got the coordinates of that point, and that's negative 4 comma 0. Now let's plug negative 4 and 0 into these inequalities. So 0 is the y coordinate and negative 4 is the x coordinate. Let's first plug it into this inequality here. So 0 is bigger than or equal to negative 8 plus 3. Well, this simplifies to 0 is larger than or equal to negative 5. And that is correct. So that point satisfies the first inequality. So the first inequality is satisfied. What about the second one? 0 is less than or equal to negative x, which is 4 minus 1. And it simplifies to 0 is less than or equal to 3. Well, this is also absolutely correct. That means this inequality is also satisfied by this point. So it is a solution to this system of linear inequalities. So please keep this in mind. This combined area contains points that satisfy the system of linear inequalities. And there is a little note for you here. To solve or draw such linear inequalities, always bring inequalities to the form y is equal to mx plus b. So equate them and draw this line. After that, pay attention to the sign. If it's bigger than or equal to, then you shade the area above the line. If it's smaller than or equal to, you shade the area below the line. For those who do not know how to bring an inequality into the form y is equal to mx plus b in order to draw the line, well, we leave y alone, alright? So we rearrange this inequality to give us the form y is greater than or equal to negative 2x plus 3, and then we equate everything to draw the line. So it goes like this. What about if we have a negative 1 in front of y? Well, now everything changes, so the sign will change. If we have a negative in front of y, we throw y to the other side and leave that side alone, so we get 2x minus 3 is bigger than or equal to y, or y is less than or equal to 2x minus 3. So see, here now, in favor of y, the sign changes. It was greater than or equal to, and because we changed the sign of y, now it's less than or equal to. So be careful in such problems. Now let's solve some practice problems. In which of the following does the shaded region represent the solution set in the xy plane to the system of inequalities above? Stop the video and try to solve this by yourself. Then we will compare the answers. So my solution is this. I will first want to shade this inequalities area, right? And this is a system, so we are dealing with two inequalities. Let's go with the first one. Y is equal to x plus 2. Now we are going to draw the line first. This is why we equate it. So y-intercept is 2 and slope is 1. So this is our second point. Now let's create that line. So this blue line is our first line. Now let's deal with the second one. So you see it's not in the original form of a linear equation. That's why we need to rearrange some terms. So we have 2x plus 3y is less than or equal to 6. Now throw this 2x to the other side. We get 3y is less than or equal to negative 2x plus 6. and we need to leave y alone, so divide everything by 3. So by dividing each term by 3, we get y is less than or equal to negative 2 over 3x plus 2. From the previous class, you may know how to draw such a line. Again, we put our point on the y-intercept, then we go 3 units to the right because of that denominator, and 2 units down because of the numerator. This is going to be our second point. Now we just need to connect them. So the line looks something like this. Now, as the last step, we need to shade the regions. So here, for the second inequality, we have less than or equal to. That means the region below the line and on the line is going to be shaded. For the blue inequality right here, right, we had y is larger than or equal to x plus 2 or greater than or equal to x plus 2. This is why we need to shade the area above the line and on the line. So you see here, right here, we have a combined region, red and blue region. That region corresponds to answer B. So B is the correct answer. This shaded area contains all of the points that could satisfy each inequality here, and therefore the system of linear inequalities. Now try to do this one. I will give you the answer for this one, but the idea here is the same. The answer to this question is C, and you had to do the same thing. So you first draw the line of this inequality and shade the region. Then you draw the second inequality's line and shade the region. Approximately, it looks something like this. Now notice, in the fourth quadrant, we only have solutions to that blue inequality. In the first quadrant, right here, we have solutions to both inequalities, so that means a solution for the system. Same thing goes for the second quadrant and for the third quadrant. That means the answer is the fourth quadrant. This one does not contain solutions to the system. It only contains solutions to the blue inequality right here. Now on the SAT exam, you may also stumble upon some word problems that are connected to systems of linear inequalities. Right now we're going to learn how to solve those. So first of all, we need to be familiar with some terms that we use in systems of linear inequalities. At least, at most, no more than, not less than, maximum and minimum. At least is this. So for example, y is at least 25. Y can be 25 and it can be more than 25. At most, for example, y is at most 50. So the maximum value, right, the largest value y can attain is 50, and it can also be less than 50. X is no more than 50. So x is less than or equal to 50. It's not more than, and there is a restriction. Now z is not less than 100, so z is either 100 or more than 100. The maximum value that w can be is 99, so w can be 89, 79, but the maximum value is 99. And minimum, so greater than or equal to. So for example, the minimum value x is 21. And x can be larger than 21 as well. So please memorize these relationships because you will need them on your SAT exam. But overall, I think you can understand those using your logic. So let's see an example related to systems of linear inequalities in word problems. Roberto is an insurance agent who sells two types of policies, a $50,000 policy and a $100,000 policy. Last month, his goal was to sell at least 57 insurance policies. While he did not meet his goal, the total value of the policies he sold was over $3 million. And the question begins at the last sentence, as we know. Which of the following systems of inequalities describe X, the possible number of $50,000 policies? So X is going to be the $50,000 policies. And Y, the possible number of $100,000 policies. So Y is our $100,000 policies that Roberta sold last month. So let's think about it. This guy is selling two types of policies, X and Y, right? So his earnings should be something like $50,000 times X plus $100,000 times Y, because this guy may sell X $50,000 policies and Y $100,000 policies. But we also know that Roberto sold over $3 million worth of policies. So that means he surpassed $3 million in the inequality for money. So this is the dollar inequality, okay? And this guy sold over $3 million worth of policies, like that. And so we need to look at the answer choices that contain this inequality first. So choice D and choice A are eliminated because they have less than $3 million here. So we eliminate those. Now we need to construct the second inequality to make sure that we're doing the right thing. So let's do it. This guy was selling two types of policies, X and Y, right? So the amount of the policies that he sold should be equal to something, or it should be more than or less than something. Now it says here, last month his goal was to sell at least 57 insurance policies. So that means he had to sell at least 57 insurance policies. But the problem is he did not meet his goal. That means he couldn't sell more than 57 policies. So he sold less than 57 insurance policies. And therefore, this is our second inequality. And we need to use that one as well. So in choice C, we have both inequalities. The one for the money he earned and the one for the amount of policies this guy sold. Therefore, choice C is correct. Now, try to do this question by yourself. It is the same concept as the question before it, this one. But here, you need to think a bit more. Now remember, the question starts at the last sentence. And usually, you need to construct the inequalities by yourself before you look at the answers. This way you will ensure that you are doing the correct thing. The correct answer for this question is B, because we have at least 10 staff members, and staff members are X and Y, seniors and juniors, and we need at least 3 juniors, which is X is at least 3, and at least 1 senior, so Y is at least 1. B is your correct answer. Thank you for watching this class. Today we talked about systems of linear inequalities and solutions to linear inequalities. If you have any questions regarding this topic, or if you need more examples, please contact me via my WhatsApp number or my email address. I'll see you in the next class, and until then, take care, and thank you for choosing emintolucanedu.com. Hello my friend, welcome back. In this video we are going to talk about an important SAT topic. In fact, we are going to cover 2 topics now. So line of best fit, mean, median, mode range, and standard deviation. Let's start with line of best fit. You may have heard this word and you may have seen it actually, but have you ever thought about it? Line of best fit is a very important topic, and you are going to see this in your university years as well. When you have a data in a scatter plot, it's usually recorded by points, so data points like this, and they are random. Let's have an example here. We have number of customers and price data recorded for a certain store. Now here, for 60 customers, for example, we have approximately $700 spent. And for 80 customers, right here, we have approximately 840, right? Or somewhere around $860 spent. So basically, these data points represent a relationship between the y and the x axis. But what happens when we want to predict that relationship? What can you do if you have a certain amount of data, like here we have around 20 points, and you want to predict the future data? So you don't want to record anything anymore, but you want to predict or make an approximation. Well, in that case, you draw an even line that passes through almost all data points like this, and this is going to be your line of best fit. Now, we use line of best fit to predict the future outcomes of experiments, of data analysis, and so on and so forth. So for example, we can extend this line like this, and we can predict what happens for 120 customers. For 120 customers, we have approximately $1,200 spent. This prediction would not be possible without the line of best fit, but thanks to this line, we can predict or approximate an outcome like price for any number of customers in that store. Another example is a declining line of best fit, a line of best fit with a negative slope. It usually represents the decrease of data or negative association between x and y. So when x is increasing, for example, it goes from 0 to 5, y is decreasing. It goes from 4 to 0. So line of best fit refers to a line through a scatter plot of data points that best expresses the relationship between those points. And we must know what types of questions are asked on the SAT exam about the line of best fit. So let's see. The first type of questions that you may see on the SAT exam about line of best fit is word problems. Word problems usually require you to understand what the line of best fit is telling you and then answer something about it. For example, here we have questions 7 and 8 refer to the following information, and the information is the graph, a scatter plot with a line of best fit, and information about this graph. Of course, in such questions, by reading one information, you can solve two questions, in this case question number 8 and number 7. Now you can choose to either interpret the graphs here or the plots, or you can choose to read the information. Either one of those works out in word problems because essentially they tell you the same thing. Now let's read the table first. Let's try to interpret it. So we have distance and density of planetoids in the inner solar system on the title, and here on the x-axis we have distance from the sun in AU, astronomical units. So as we go along the x-axis, the horizontal axis, the distance from the sun of the planetoids increases. And here on the y-axis or the vertical axis, we have the density of the planetoids in grams per cubic centimeter. So as we go up, right, as we go vertically up, the density of the planetoids increases. Now we can establish a relationship here. We can see that there is a relationship between those points in the scatter plot. As we go away from the sun, that is, as we increase our distance from the sun, as we go to the right, and as the distance in astronomical units increases, the density of the planetoids is falling down, so it's decreasing. Now I advise my students to first interpret the graph the way they can. So establish a relationship in a few seconds, right? Understand what is going on here and establish your own relationship. Usually this will make it easier for you to solve the question. It says, according to the scatter plot, which of the following statements is true about the relationship between a planetoid's average distance from the sun and its density? Well, here we need to establish that relationship between the horizontal and the vertical axis in this scatter plot according to those points. So not necessarily according to the line of best fit, but according to those points. What happens is, as we already said, as we go further from the sun, the density is decreasing, so density falls down. Well, in choice A, it says planetoids that are more distant from the sun tend to have lesser densities, and this is the correct answer. You can read the other answers and you can understand that they do not even make sense. Usually, in such questions, you will be able to determine the answer straight away once you interpret the graph. Well, another way to understand such graphs is by reading the information here, but the information won't tell you the relationship of the horizontal and the vertical axis. Of course, to understand the relationship, you must have a basic understanding of linear equations or lines in the XY plots. Now let's solve the 8th question, related question to this scatter plot here. An astronomer has discovered a new planetoid about 1.2 astronomical units from the Sun. According to the line of best fit, which of the following best approximates the density of the planetoid in grams per cubic centimeters? So basically what they're trying to ask us here is if they found a planetoid 1.2 astronomical units away from the Sun, what will be the corresponding density of that planetoid from the line of best fit, right? So according to the line of best fit. That means we need to interpret the information using the line of best fit, and here when we try to interpret the corresponding density for a planetoid 1.2 astronomical units from the Sun, we get somewhere around 4.6 and 4.7. So the correct answer is going to be 4.6 because it is the closest one to our approximation. You may also stumble upon questions like this. The scatter plot above shows data for 10 charities along with the line of best fit. So here you see the line of best fit and here you see the actual data. Remember, line of best fit is just a prediction, it's an approximation. For the charity with the greatest percent of total expenses spent on programs, so that's this one. This one has got the greatest percent of total expenses. It has the highest percent, right? And it's somewhere around 92%, right? Which of the following is closest to the difference of the actual percent, well, we already know that one, 92%, and the percent predicted by the line of best fit? Well, that one we can see here, that's this charity and its total income, so it's 85%. So our prediction predicted or approximated by the line of best fit is 85%. So the difference between the actual percent and the predicted percent is 7%, right? So the answer is B. In such questions you need to be very careful and you have to read what comes on the y-axis and what is written on the x-axis, on the horizontal axis, because there is a big difference. Let's have another question for the sake of practice. The scatter plot above shows the number of grams of both total protein and total fat for 8 sandwiches on a restaurant menu. Usually, in such questions, the first sentence is the introduction to this graph. So you can either read the first sentence or you can just try and understand what is going on here on the scatter plot. So we see total fat grams, right? So it goes from 0 to 80, and total protein in grams. So there is a relationship between total fat and total protein, and as the fat increases, protein increases as well. So there is a direct relationship. Now the question starts at the last sentence. In 99% of the cases, this is true. So according to the line of best fit, which of the following is closest to the predicted increase in total fat in grams for every increase of 1 gram in total protein? Now we're talking about increase per unit change. So we talk about increase in total fat per increase in total protein. Well, that is a rate of change. And we talked about rate of change before. We talked about slope. So what they're trying to ask us is they're trying to ask what is the slope of this line of best fit. So they're asking for 1 gram, right? So what happens when we go 1 to the right? How many units do we go up? That is going to be our slope. But the problem is we cannot see this clearly. So we can find the slope since it is rise divided by run. We can have a run of 10 units and we can find the corresponding rise. So how much do we go up when we go to the right by 10 units? So let's start from 10. At 10, we're approximately at the height of 20, right? So this is our first point. And we go from 10 to 20. So this is our run of 10. We ran 10 units, and how much do we go up? So we came from 20 to almost 35, right? So what is 35 minus 20? That is going to be our rise. That is going to be the difference in heights for that run. So it's going to be 15 divided by 10, and that is a slope of 1.5. So increase in total fat per increase for total protein is going to be 1.5. That is our slope. Now we've seen the first type of problems, the word problems. We also have equation problems for lines of best fit. In such cases, we usually get the equation of that line, and we want to predict a certain data, a certain information here. For example, the scatter plot above shows data collected on lengths and widths of iris setosa petals. A line of best fit for the data is also shown, so this black line is our line of best fit. Based on the line of best fit, so that is the last sentence, and therefore our question starts right here and ends here. Based on the line of best fit, if the width of an iris setosa petal is 19 millimeters, so what happens if the width is 19 millimeters? Well, we do not have any information on that, but luckily we have a line of best fit, so we can extend it to 19 millimeters, and we can use this line to predict something. The question goes, what is the predicted length in millimeters of the petal? So what is that length, right? Well, we already know that length is on the y-axis and the vertical axis, and y is equal to 1.67 times x plus 21.1. Well, what is x in this case? X is going to be 19. We're interested in what happens for that petal when the width is 19 millimeters. Therefore, we need to plug x is equal to 19 in order to find the length of the petal when the width is 19 millimeters. So we get y is equal to 1.67 times 19 plus 21.1, and that gives us exactly 52.83 millimeters. So the length of that iris setosa petal when the width is 19 millimeters, the length is approximately 52.83 millimeters. So the answer is C. And here's the last question, and I want you to read it by yourself and think about it. We talked about slope the last time in our first class. So what do you think? Which of the following is the best interpretation of number 3.39 in this equation? Here you can clearly see that 46.89 is the y-intercept of this line of best fit. Now 3.39 is the slope of this line of best fit, and the slope is amount of plastic divided by number of years. So that means each year the amount of plastic increases by 3.39. This is as easy as that. Therefore our answer is D. 3.39 is the average annual increase. Since slope is positive, we have an increase and it's annual. That means it's per run, so per unit year. In billions of pounds of plastic produced per year in the United States from 1985 to 2003. So basically saying here this line of best fit has a slope of 3.39, and that slope tells us how much the plastic produced per year increases in United States. Now we are done with the line of best fit, and the second topic of discussion is mean, median, mode, range, and standard deviation. These terms are actually extremely important for the SAT exam, because you're not only going to use those on your exam, but you're also going to use those to build a basic understanding of statistical analysis. So let's cover those terms one by one and understand what each one of those means. Let's talk about mean first. Now here, mean is not an emotion. It is just a mathematical term, and we can also say average or arithmetic mean. Those three things mean the same thing. So mean, also known as average, is the division of the sum of the numbers by their amount. Let's say you have a set of numbers, right? 12, 13, 18, 28, and 35. And you want to find the mean or the average of those numbers. What you do is you divide the sum of those numbers. So 12 plus 13 plus 18 plus 28 plus 35. You divide the sum by the amount. So there are 5 numbers. So you divide that sum by 5. And that gives you a number. This number here is 21.2. So this 21.2 is the average of 12, 13, 18, 28, and 35. And therefore, it is the arithmetic mean. So again, please remember this. Mean is equal to sum divided by amount. So addition of all numbers divided by how many numbers there are. Now, what is median? Well, median is the middle number in a set of numbers organized by their size. So for example, you have a set of 5 numbers here, and they're all organized by their size, so increasing from left to right. The median in this set of numbers is 18, because this is the middle number in that number set. So when you have an odd amount of numbers, like 5 numbers or 3 numbers, the median is very easy to find. It's right in the middle. But what about if you have an even amount of numbers? So for example, 6 numbers in a set of numbers. So here we have 1, 2, 3, 4, 5, and 6 numbers. What happens here is, in order to find the median, you first organize the numbers by their size, increasing or decreasing, does not matter, and then you take the average of the middle 2 numbers. So in this set, 2 middle numbers are 18 and 28. So you sum them and you divide by their amount. That gives you 46 divided by 2, and that gives you 23. So the median of this number set is 23. What about mode? Have you ever heard of this? Mode. Well, it's very easy. Mode is the number that appears the most in a set of numbers. So if you see a number a lot of the time, like you see it 5 times or 6 times or 7 times, and other numbers you see only once or twice, then mode is the number that appears the most. For example, in this number set, 1 appears 3 times, 2 appears 5 times, 5 appears only 1 time, 15 2 times, and 18 appears 4 times. So which number appears the most here? Well, 2 appears 5 times, so this is the number that appears the most. Therefore, 2 is your mode. And now let's talk about range. This one is also extremely simple. Range is the largest number in a number set minus smallest number in that number set. So here, for example, you have 6 numbers, and the largest number here is 1097, and the smallest number here is 90. So your range is going to be 1097 minus 90, which leaves you with 1007. This is your range in this set of numbers. We also have a term called standard deviation. But in the SAT exam, all you have to know about standard deviation is that it only depends on the mean. Of course, there is a very hard equation for standard deviation that you may not remember on your SAT exam. And it's okay. It's not important. The important thing to know is standard deviation changes when mean or the average changes. So if you change your mean in a set of numbers, you will basically change your standard deviation. This is your shortcut. But if you need a better explanation here, a standard deviation's explanation is this. So you can read it, and if you don't understand it, basically saying standard deviation is a measure of how much numbers are away from each other. So for example, for numbers like 1, 2, and 3, consecutive numbers, standard deviation is going to be very low because they don't deviate too much, and therefore the difference between those numbers is not so big. But when we talk about numbers like 1 million, and 52, the standard deviation is going to be very large because those numbers have a big difference between them. Now let's take a look at a few examples related to mean, median, mode, range, and standard deviation that may come out on the SAT exam. But before we do that, I want to clarify one other thing. Many students confuse the concept of median in such a way that if you ask them, if you have 3 groups of food that you ordered, for example, burgers, sandwiches, and candy, and if you ordered 25 burgers, 2 sandwiches, and 100 candy, right? What is the median element of the food here? Students would say it's sandwiches because it's 2, and in a set of numbers 1, 2, 3, 2 is the middle number. However, this is incorrect. We don't look at the numbering. We actually look at each individual category and we categorize. So what we have here is 25 burgers, so 25 little burgers. We also have 2 sandwiches, alright, so 2. And we have 100 candy, alright, so 100. Now what is the median in this set of numbers now? So we have 25 plus 2 plus 100. That gives you 127. So there are 127 characters in that set of numbers. It goes from 1 till 127. Now when you have 127 individual characters and you divide it by 2, you take the half. It gives you 63.5. That means in the half here, somewhere when you cut it in the half, you're going to have 63.5. The median is the rounded version of that. So the median here is going to be 64. The median of this set of numbers is 64. And 64th element belongs to candy, because here you have 25 and here you have 2, so 25 plus 2 gives you 27. Up until here you have 27, and up until the end of candy you have 127. So 64 lies between 127 and 27. It's somewhere around here, 64, and therefore the median group of food here is going to be candy. Now this is a great example to build understanding of the concept of median. So let's have another example. A sociologist chose 300 students at random from each of the 2 schools. You have Lincoln School and Washington School, and asked each student how many siblings he or she has. The results are shown in the table below. So here you have a table with results of a survey where a sociologist asks 300 students from each school how many siblings does he or she have. The question states, what is the median number of siblings for all students surveyed? How many students do we have? We have 300 students in Lincoln School and 300 students in Washington School. So we have a total of 600 students. Now, the median of 600 is going to be, well, you divide 600 by 2. So it's 300. The median is going to be around 300. So the 300th element here is going to be our middle element in a number line. We're going to count now. So from Lincoln School and Washington School we have 120 plus 140, 260 students that have 0 siblings. Here we have 80 plus 110, so 190 students that have 1 sibling. 60 plus 30, so 90 students that have 2 siblings. 30 plus 10, so 40 students that have 3 siblings, and last but not least 10 plus 10, so 20 students that have 4 siblings. Now we're looking for the 300th student. That student is going to be the median, the middle element in a set of numbers, and therefore the corresponding number of siblings will be the median number of siblings. And we go down. So from here we go down. From 260 we want to find 300th element. So from here to here you got 260, and from here to here you got 260 plus 190 more, so 450. That means the 300th student has to be somewhere between 260 and 450. That means it's in this group. That student is in the group where students have 1 sibling, and therefore B is your correct answer. Please be careful with the questions related to median. Now we have another question. The table above lists the length to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. So this one right here is an error. It is not supposed to be in that table. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data. Now, we have a set of numbers here. We have exactly 21 numbers in this set. So imagine 21 numbers and you remove 24 out of those all numbers and you divide it by 20. The average will not change so much because you have so many numbers that, for example, if your average was 21, that average will become, well, maybe 19. And if you want to prove that, you can try. So sum up all the numbers here. 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 plus 11 plus 12 and so on until 24, and divide everything by 21. Of course, on the SAT you won't have so much time, but this is just to prove a point that when you remove one data point from a set of numbers where you have many numbers, the average or the mean does not change a lot. So mean is not going to change a lot. Mean does not change. What about the median? Well, when you try to set all of these numbers in an order, we got 8, 9, 9, 9, 10, 10, 11, 11, 12, 13, 13, 13, 14, 14, 15, 15, 16, and 24. We have 21 data points. Now, the middle of 21 is going to be 11. So we're looking for the 11th data point, and it's 12. So this is your median when you had 21 numbers in that set. What happens if you remove 24? When you remove 24, you're left with 20 numbers, alright? And so for 20 numbers, the median is going to be somewhere around 10, right? So for 20 numbers, the median is going to be somewhere around the 10th number in that set. And the 10th number is 8, 9, 9, 9. So that's 4, 5, 6, 7, 8, 9, 10. Again, 12. So 12 is your median again. Median does not change at all. But what about range? Let's talk about range for a second. We know that range is the difference between the highest number and the smallest number. So the largest number and the smallest number tell us something about range. So range, before we remove 24 from that set of numbers, is going to be 24 minus 8. So it's going to be 16. Now what happens when we remove 24? The largest number becomes 16, and range is 16 minus 8 now. So it becomes 8. Range changed significantly. We know median didn't change a lot. We already told that mean doesn't change a lot, but range changed by 8 units. Therefore, range changes the most. In such questions, usually when you remove the largest number, range is the thing that changes the most. So keep this in mind. This will be very useful on your SAT exam. Now here we have another problem, and it's about mean, or the arithmetic mean, or as we call it, average. You may read this one, and then we will solve it together. So the table above lists the ages of the first 12 United States presidents when they began their terms in office. According to the table, what was the mean age in years of these presidents at the beginning of their terms? Round your answer to the nearest tenth. Now, this is a question without an answer, so without a choice, and therefore you have to generate your own answer and round it to the nearest tenth. So we need to find the mean here, mean age in years. And we already know that there are 12 presidents, so we divide everything by 12. Now the sum here is going to be 57 plus 62 plus 58 up until plus 65. So we sum all of those numbers. You can do it on your calculator to ensure that you're solving this question correctly, and then you will get 703 when you sum everything. So we divide 703 by 12, and we get on our calculator 58.583. Now we need to round our answer to the nearest tenth. That means we need to round it here, and therefore when we round it, we get around 58.6. This should be your answer that you write in your answer sheet. Let's have one last problem for the sake of practice, and then we are going to finish this video. The mean score of 8 players in a basketball game was 14.5 points. So we had 8 players, that is our amount, and we had a sum, and we divide that sum by 8, and we get an average or mean of 14.5. Now, the highest individual score is removed, and the mean score of the remaining 7 players becomes 12 points. So now we have a second sum, alright, when we remove the highest individual score. So we removed one of the 8 scores, that was the highest score, and we divide everything by 7 since we are left with 7 players, and that average or the mean becomes 12. The question is asking what was the highest score. We need to find the difference in sums, and that way we will find that one player's score. So let's see. First, let's find the first sum. So we multiply everything by 8. Here 8's cancel out, and 14.5 times 8 gives you 116. So this is your sum of scores before you remove the score of the 8th player. Now let's find out what happens when you remove the score of the 8th player that scored the highest individual score. So we multiply the second case scenario, here everything by 7, so we get the second sum, and that gives us 84. Now before sum was 116. After you remove the highest individual score, the sum of scores of 7 players became 84. Therefore, to find what's missing or what you removed, you just need to subtract. So 116 minus 84 will give you the score of the player that scored the highest. So 116 minus 84 gives you 32. So 32 is your answer. When you remove 32 from this set and then again take the average, you will find the average of 12 points. Such questions come out on the SAT exam a lot, so therefore you need to practice the equation sum, that is the addition of everything, divided by amount, that is how many numbers you have in that set, is equal to the mean or the average of that set of numbers. Thank you very much for watching this video. If you have any questions or if you need more examples, please make sure to contact me via my WhatsApp number or my email address. Take care, and I will see you in the next class. Thank you for choosing emintolucanedu.com. Hello everybody! In this part of our SAT math course, we're going to cover parabolas and quadratic equations. We're also going to cover word problems related to quadratic equations. Quadratic equations are amazingly important equations in algebra, and aside from their importance, they're a lot of fun to deal with because they're very easy and beautiful. Quadratic equations have this form: a multiplied by x squared plus b times x plus c, and this is the general form of a quadratic equation, where a, b, and c are just constants. They're coefficients of the x squared and x terms. Here are some examples of quadratic equations. You may have seen those, and you will be dealing with those on the SAT a lot. Questions related to quadratic equations come out on the SAT calculator section, as well as the no calculator section. As you may have already noticed, quadratic equations have coefficients a, b, and c, and these coefficients play a very important role because they tell us how the graph of this quadratic equation looks like and what the solutions to the quadratic equation are. We're going to talk about the graphs of quadratic equations first, and after that we will talk about the solutions to quadratic equations. Now, the graphs of quadratic equations are called parabolas. You may have also heard this word before. Parabolas may look like this. So these are the graphs of the quadratic equations, and they may have different shapes. They may be upward facing or downward facing. They may be narrow or wide. Now, the shape of those graphs, that is parabolas, depends on terms a, b, and c. Graphically, ax squared is the quadratic term, because here we have x squared. Bx is the linear term. The variable x has a constant multiple b, and c is just a constant term. It is a number. The coefficient of the quadratic term a determines how wide or narrow the graphs are, and whether the graph turns upward or downward. Now, let's see examples. When a is more than 0, that is, when a is positive, so for example 1, 2, 3, and so on, parabolas are upward facing, that is, they have a shape of the letter U. And if a, the coefficient of the quadratic term, is negative, that is less than 0, for example -1, -5, and so on, that means your parabola will be facing downward, so it will have a shape of letter N. If a is larger than 1, for example 5, 7, 20, then your parabola is going to get narrower as a increases. So the width of your parabola decreases as the coefficient a increases. That is, if your coefficient a is, for example, 25, your parabola will be extremely narrow. If coefficient a is a fraction, for example 1 over 3, then your parabola is going to be relatively wider. And as the denominator of the fraction, that denominator, as it grows, your parabola becomes wider and wider. So larger denominator gives us a wider parabola. Now let's repeat that. If a is larger than 0, parabola has a shape of letter U, that is, it's opening upwards. If a is less than 0, the parabola has the shape of letter N. It opens downwards. If a is larger than 1, then parabola is narrow. It gets narrower as a increases. And if a is in between 0 and 1, that is, if a is a fraction that is less than 1, then parabola is wide, and it gets wider and wider as the denominator of that fraction. So, for example, x, as x increases. Now, let's say 1 over 25. This parabola is going to be relatively wide, but a parabola with a coefficient a, 1 over 100, will be much wider than the parabola with a coefficient a, 1 over 25. So basically speaking, as you increase the denominator of the coefficient a, your parabola gets wider. Now what about coefficient b? On the SAT exam, what we need to keep in mind about coefficient b is that it shifts your parabola's symmetry axis, this middle line where we cut the parabola in half, either to the right or to the left. Now let's look at it in detail. Let's say your b is 0. That means you do not have a linear term x. When b is equal to 0 and there is no c, your parabola is placed in the middle. Let's see what happens when we add b, that is, when we add a positive b term to this parabola. So let's do it. This was your symmetry axis when b was 0. Now when we add b, parabola shifts to the left. And again, we added one more b. Parabola shifted half a unit to the left again. Let's add one more b. So parabola shifted again, half a unit to the left. Now let's see what happens when we subtract b. So we have a negative linear term. That is, b is negative. This is when b is equal to 0 and we subtract b. So parabola starts shifting to the right. Now let's think about it. We subtracted 3x from this parabola, that is, our b is equal to negative 3. We know that when b was 0, the symmetry axis was at x is equal to 0. And when we added b is equal to negative 3, parabola shifted 1.5 units to the right. This means that if we subtract b, the parabola will shift to the right b divided by 2 units. So we subtracted 3b and parabola shifted 1.5, that is 3 over 2 units to the right. So here is a little review. If b is larger than 0, then parabola shifts b divided by 2 units to the left. So for example, if b is equal to 2 and your quadratic equation has a form y is equal to x squared plus 2x, your parabola's symmetry axis will be at x is equal to negative 1. Just like in this picture, the symmetry axis is at x is equal to negative 1. Now, if b is less than 0, then parabola shifts negative b divided by 2 units right. For example, if b is negative 10 and your quadratic equation has a form y is equal to x squared minus 10x, the parabola shifts 5 units to the right. That is negative b, which is negative 10, which is just 10, divided by 2, that is 5 units to the right. For instance, here we have b is equal to negative 2. So parabola has shifted from x is equal to 0 to x is equal to negative 2 divided by 2, which is just 2 divided by 2, and that is 1. Parabola shifted 1 unit to the right. Now, the amount of vertical shift is not very important on the SAT exam. We only consider the shift of the symmetry axis, that is the vertical line that cuts the parabola in half. And there is one last thing that we need to know about this quadratic equation, the coefficient c. Coefficient c tells us where the y-intercept of a parabola is. Now, if you remember what the y-intercept is the point on the y-axis at which any curve or any graph intersects with the y-axis, with the vertical number line. Now let's say c is equal to 0. Here, the graph of this quadratic equation, that is this parabola, crosses the y-axis at 0. When we add c, for example, c is equal to 2, and the parabola has a form x squared plus 2, our y-intercept, that is the point where the parabola crosses the y-axis, becomes 2. And when we subtract c, so when c is equal to negative 2, for example, parabola intersects the y-axis at y is equal to negative 2. You may ask, why else do we need equation ax squared plus bx plus c and parabolas in SAT? And we actually needed to also find its zeros, that is, the roots of that parabola. In the first video, we talked about a zero of a function. A zero of a function is its x-intercept. So a zero of a function, in other words, is the point or points where the graph of that function crosses the horizontal axis, the x-axis. You may ask yourself, why do we call it a zero of a function? And the answer is very simple. Because a zero of a function is denoted as y of x is equal to 0. This gives the point x where y, the vertical coordinate, is equal to 0. So for example, on the x-axis, the vertical coordinate is 0. So we have a level here that is denoted as y is equal to 0. And we're trying to find at which points the parabola crosses y is equal to 0, that is the x-axis. Now, there may be 3 cases that you may stumble upon on the SAT exam. And overall, in mathematics, there are actually 3 cases that you may have with parabolas and their zeros. So you may either get 2 zeros, that is 2 x-intercepts, 1 0, that is 1 x-intercept or 1 root, and no real zeros, that is no x-intercepts. So let's look at each case scenario on the graph. When you have 2 zeros, your parabola crosses the x-axis twice, and you can clearly see those points when you graph your parabola. When you have 1 0, the peak of the parabola, that is the vertex, and we will talk about the vertex a little bit later, but the vertex crosses the x-axis, and therefore parabola literally touches the x-axis. Therefore you only have one point at which the parabola intersects the x-axis. And the last scenario is no real zeros. This is when the parabola doesn't even cross the x-axis. Here, parabola is either above the x-axis and is facing upward, or it may be below the x-axis and it may be facing downward, right? So it looks like the letter N. And it's very important to be able to find zeros, or the roots of a parabola. Now, there are 3 main ways to do that, and these ways are extremely simple. First of all, before we look at the methods, we need to understand that before you find the zeros, you need to set your equation of a parabola equal to 0. That will allow you to find the x values at which y is equal to 0, and therefore the parabola crosses the x-axis. We already know how to do that for linear equations. So for example, for a linear equation y is equal to 2x plus 1, when you set y is equal to 0, you can solve for the unknown variable, that is x, by rearranging. So you get 2x is equal to -1 and x is equal to -1 over 2. But what about parabolas? Here we have a quadratic term that actually prevents us from being able to do this. And therefore we need to find a way to solve for that x that allows us to get y is equal to 0. As I already said, there are 3 ways to do that: the discriminant formula, factorization method, and simplification method. Let's talk about the discriminant formula first. To find the roots of a quadratic equation, you can use the discriminant formula, and it goes like this: x is equal to -b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. Here, all you need to know to find the roots is a, b, and c, the coefficients of the quadratic equation. Now let's practice a little bit. So for example, you have this parabola, this quadratic equation, and you would like to find the zeros of that parabola. First, you need to determine the coefficients a, b, and c. So a is going to be 1, we can clearly see here. B is going to be -4, and c is going to be 3. Now, you may plug these values into the discriminant formula, and you will find two values of x. So let's do it. X is equal to -b, which is -4, which is +4, plus or minus square root b squared, which is 16, that is -4 squared, so 16, minus 4 times a, which is -4 times 1, times 3, which is -12. All divided by 2 times a, which is 2 times 1, so 2. This leaves you with 4 plus and minus square root of 4, and square root of 4 is 2, so we can replace this by 2, all divided by 2, and that leaves you with 2 plus and minus 1. I just divided everything by 2. Now here you may have two cases. You have 2 plus 1, so x is equal to 2 plus 1, which is 3, or you may have x is equal to 2 minus 1, so 2 minus 1, which gives you 1. So here you have x1 and x2, 2 points on the x-axis where your parabola has an intersection. X is equal to 3 and x is equal to 1. Now let's take a look here. The graph of this quadratic equation looks something like this, and we can clearly see here that it crosses the x-axis at x is equal to 1 and at x is equal to 3. So this plus and minus here is just to denote that you have to first add and then subtract -b from b squared minus 4ac and divide everything there by 2 times a. So for this parabola we had two x-intercepts. What about other cases, like one x-intercept or no x-intercepts? Let's see. Let's try and solve for the roots of this quadratic equation. Again, a here is going to be 1, b is going to be 4, and c is also 4, as you can see here. Let's plug all of these coefficients into the discriminant formula. We get x is equal to -4 plus minus root 16, which is b squared, minus 4 times a, which is -4, times c, which is -16. So -16 divided by 2 times a, which is 2 times 1, and that gives you 2. In order to simplify this, we can subtract 16 from 16, that leaves you with 0. And here you get -4 plus minus 0 divided by 2. Well, 0 doesn't play a role here, so we can just cross it out, and you get x is equal to -2. So x is equal to -2 is your only root, that is your only 0. And therefore we say that parabola has only one x-intercept, only one root, or only one 0. Notice, what we had here is a 0 inside the square root. So remember, when you get a 0 inside that square root, that is, when your orange term here, b squared minus 4 times a times c, leaves you with 0, that means your parabola will only have one x-intercept, only one root, or only one 0. And last but not least, let's take a look at the case when we have no zeros. So again, we determine our coefficients a, b, and c. A is going to be equal to -1, b is equal to -5, and c is equal to -7. So we plug all the coefficients into the discriminant formula. X is equal to 5 plus or minus square root b squared, which is -5 squared, that gives you 25, minus 4 times a, which is -4 times -1, that gives you 4, multiplied by -7. So 4 multiplied by -7 gives you -28. And you divide everything here by 2 times a, so -2. What you get here is -3. So inside the square root you have -3. And let me ask you, have you ever seen a negative number inside the a square root? Mathematically, this is not real. That is, this is not possible. Therefore, we say that such a parabola will not have any roots, or at least it will not have any real roots. So the parabola has no real roots. But although it doesn't have real roots, it may have imaginary roots. Now, what are imaginary roots? Imaginary roots appear when you have an imaginary term, that is, a term containing a negative value in a square root. So for example, square root negative 3. What we do in such cases is we simplify everything as 5 plus minus square root negative 3 divided by negative 2, and this square root negative 3 can be replaced by I multiplied by 3. Now let me tell you how did I get here. In mathematics, we have a term called I. This is an imaginary number, and it is equal to square root of negative 1. I is an amazing term, and we will talk about it in more details in the 6th class, that is in the 6th video. But for now, we need to know that I is square root negative 1, and it's called the imaginary number. So I is square root of negative 1 and its imaginary number. What this imaginary number does is it allows us to write down solutions to such parabolas, that is, the roots to such parabolas, in a very convenient way. Instead of writing square root of negative 3, we can divide this into the multiplication of square roots of square root of 3 and square root of negative 1. And we already know that square root of negative 1 is just I. So this all is equal to I times root of 3. Let's practice here. Square root of negative 25, for example, can be rewritten as square root of negative 1 times 25. We can spread this root like this. Square root of negative 1 times square root of 25. And we already know what the square root of 25 is. It is 5. So that equals to 5 times square root of negative 1. We already said that square root negative 1 is equal to I. So this all is equal to 5 multiplied by I. It is as simple as that. Now let's go back to our problem. Instead of leaving the roots of a quadratic equation like this, what we can do is we can write 5 plus or minus I times root 3. Therefore, x is either equal to 5 plus I root 3 divided by negative 2, or it is equal to 5 minus I times root 3 divided by negative 2. But since I is an imaginary number, we just say that this quadratic equation has no real roots. So the parabola will never cross the x-axis, and therefore it has no x-intercepts. To sum everything up, if the orange term b squared minus 4 times a times c is larger than 0, then we have 2 real roots. If it is equal to 0, then we have 1 real root. And if it's less than 0, then we have no real roots, or no real solutions. So 2 roots, 1 root, and no real roots. Now, this was the discriminant formula, and it is useful when we want to find the roots of a quadratic equation. What about 2 other methods? We said we also have factorization. Factorization is basically separating a quadratic equation into 2 parentheses. The example of a factorization is when you have a quadratic equation and you open 2 parentheses and you try to determine what terms need to be in those parentheses in order to, when you multiply them both, they give you this quadratic equation back. So what we do is we determine that in order to get x squared as a multiplication of 2 terms, we need x and x in 2 parentheses. In order to get negative 4x and 3, we need to think what adds to give us a negative 4 and what multiplies to give us positive 3. Well, we already know negative 1 and negative 3 add to give us negative 4, and when you multiply them, they give us positive 3. So you put them into the parentheses, negative 1 and negative 3. Now let's multiply everything. X times x gives you x squared, x times negative 3 gives you negative 3x, negative 1 times x gives you negative x, and negative 1 times negative 3 gives you positive 3. So all of this simplified gives you x squared minus 4x plus 3. This is factorization. Now why do we need it? Well, we said that we need factorization in order to find the roots of a parabola or the quadratic equation easily. So we set this equal to 0. In order for this multiplication to be 0, either one of these parentheses have to be 0. Therefore, in order to get 0 in that parenthesis, we need x to be equal to 1, because 1 minus 1 is 0, and 0 multiplied by this will give you 0. Or we may have this parenthesis equal to 0, and for that we need x to be equal to 3. So x is equal to 1 and x is equal to 3 are your roots or your zeros. Alright, factorization is a quick method, but you need to practice it in order to master it and to be fast. Let's repeat it. So first you open up two parentheses and then you ask yourself, what two terms multiply to give you x squared? Well, you put x and x. Then you ask yourself, what two terms multiply and add to give you 3 and negative 4? Well, negative 1 and negative 3. When you multiply those terms, you get 3, and when you add those terms, you get negative 4. But are there shortcuts for this? Well, of course there are. If the coefficient b and coefficient c are both positive, then you will have a plus and a plus in both parentheses. If your coefficient b and c are negative, then you must have 1 minus and 1 plus. This is a must. If your coefficient c is positive but b is negative, then you must have both of the terms in the parentheses negative. So for example, negative 1 and negative 2. When you multiply negative 1 by negative 2, you get 2. And when you add negative 1 and negative 2, you get negative 3. So b is equal to negative 3 and c is equal to 2. Let's practice a little bit. Try to factorize this expression right here. Now, I hope you were able to do this, but if you were not, well, here is the way you do it. Then again, open two parentheses. You have x squared, so you put x and x here. You have positive and positive, so you put plus and plus. Then you ask yourself, what multiplies to gives you 1, and what two terms add to give you 2? Well, those are 1 and 1. So you only have one root. X is equal to negative 1. Try to do this one. Try to factorize this expression. Now it goes like this. Again, open two parentheses, put x here and here. You have both negative terms. That means you have one positive and one negative. What two terms multiply to give you negative 7 and add to give you negative 6? Well, that is positive 1 and negative 7. Positive 1 times negative 7 gives you negative 7 here, and 1 minus 7 gives you negative 6. So your roots are x is equal to negative 1, it will make this expression 0, and x is equal to 7, it will make this expression 0. So factorization is an efficient way to find the roots of a parabola or a quadratic equation, but it requires practice. Now let's talk about the third and the last method of finding the roots of a parabola that is very good to go with on the SAT exam. It is called simplification. Simplification works best when you have no c in the equation. So when c is equal to 0 and you have no constant terms, you only have the quadratic term and the linear term, you can use simplification. What happens here is you take the x parenthesis, so you factorize x out of this equation and you get a times x plus b. Here you equate it to 0 in order to find the roots, so one of the roots will have to be 0, right? And the other one of those will have to make this expression right here equal to 0. So this depends on the expression inside the parentheses. And let's have an example. Find roots of y is equal to x squared plus 4x. Now here we have c is equal to 0, no constant terms. So let's use simplification. Take the x parenthesis, take out x from both of these terms, and you get x times x plus 4. Equate this to 0 to find the roots. For this expression to be equal to 0, you either need x to be equal to 0 or this parenthesis to be equal to 0. And here you need x to be equal to negative 4. Therefore, x is equal to 0 and x is equal to negative 4 are your roots. This is a very good method, but it only works with quadratic equations where c is equal to 0. Now try to do this one on your own. Find roots of y is equal to x squared minus 25 times x. Again, we factorize x, so it goes outside the parentheses. We got x minus 25. And then we equate to 0. So x has to be 0 or x has to be 25. Now I hope you have noticed something. In simplification, you will always have one of the roots equal to 0. This is a must, because when c is equal to 0, your parabola has a y-intercept at x is equal to 0. And therefore, it crosses y is equal to 0 at x is equal to 0. Now let's talk about the vertex of a parabola. You may have heard about this. The vertex of a parabola is either the bottom point for the parabolas that face upward or the top point for the parabolas that face downward. So this point where the parabola turns, it is called the vertex. So it is a peak or bottom point of a parabola, and it also has coordinates as well as any other point. Since it is a point, we can describe it with coordinates. And instead of using x comma y for vertex, we actually use h comma k. So keep this in mind. H will be the x coordinate of the vertex and k will be the y coordinate of the vertex. Now, we already talked about the general form of a quadratic equation, but it turns out quadratic equation may have a vertex form. In this form, we can clearly see the coordinates of the vertex of that parabola, h and k, and we can also see the multiple a. Now, in order to find h, all you need to know is the coefficient b and coefficient a of the general form of the quadratic equation. So h is equal to negative b divided by 2 multiplied by a. You need to keep this in mind for your SAT exam. In order to find k, the vertical coordinate of the vertex of a parabola, you need to plug h instead of x. So k is equal to function of h instead of function of x. Let's practice. Find the vertex of a parabola y is equal to x squared minus 4x plus 3. Here, we can clearly see that a is equal to 1, b is equal to negative 4, and c is equal to 3. Therefore, h is going to be equal to negative b divided by 2a, which gives you negative 4, which is positive 4, divided by 2 times 1, which is 2. h is equal to 2. So we write it down, h is equal to 2. What about k? Well, in order to find k, we need to plug h into the quadratic equation. So k is going to be 2 squared minus 4 times 2 plus 3. I just plugged h instead of x into the quadratic equation. That leaves you with k is equal to 4 minus 8 plus 3. So k is equal to negative 1. K is negative 1. Now let's try to write down the vertex form of the equation of the parabola for this example. So remember, the vertex form is this. So f of x is going to be equal to a times x minus h squared plus k. And that is equal to 1 times x minus 2 all squared minus 1, because k is negative 1. And you can just erase this one because it's a constant multiple of 1. So this is the vertex form of this equation. And when you open it up, it gives you x squared minus 4x plus 4, and you got a negative 1 here, so minus 1. That all simplifies to x squared minus 4x plus 3. Notice when you open up the vertex form of the equation of a parabola, or the quadratic equation, you get exactly what you have in the general form. Now let's try to draw this parabola here. We already know the coordinates of the vertex. So h is equal to 2 and k is equal to negative 1. The vertex, or the bottom part of the parabola, is going to be here. y-intercept is 3, so parabola has to pass through this point, and it's symmetric, so it will pass through this point as well. The parabola will look something like this. So it opens upward because a is a positive term, it has a vertex at the coordinate 2, -1, and it is shifted to the right by 2 units because b is -4. So this is the exact graph of that parabola, and turns out we graphed it correctly. Now this is it for the theory about parabolas. We have covered the general form and the vertex form of the quadratic equation, as well as the function of coefficients a, b, and c. We have also learned how to solve quadratic equations, how to find the roots or the zeros, and therefore we are ready to practice. Welcome back. In this video we are going to solve 11 problems related to quadratic equations and parabolas. These examples will be essential, so try to solve them beforehand, and if you're not able to, just continue watching. So let's start from the first one. In the equation above, a is a positive constant and the graph of the equation in the xy plane is a parabola. Which of the following is an equivalent form of the equation? Now, we look at this equation and we try to find which one of those is the factorized version of this equation. Now notice we do not have a middle term, the linear term, ax. That means there will be a positive and a negative number inside the parentheses. So we get x minus and x plus. Then when we add everything up, two same values simplify. Also, two things multiply to give us a negative a. The only thing that would allow this is the multiplication of negative root a and positive root a, because when you multiply negative square root a and positive square root a, well, there you get negative a. Therefore, choice B is correct. Try to solve this one as well. In the equation above, p and t are constants, so this and this are just constant terms. Which of the following could be the value of p? So what is p? Well, here we can multiply the first terms. We will get p squared times x squared. And the only x squared term on the left hand side is this one, so that is equal to 4 times x squared, since it's the only term with x squared on the left side. Now we can cancel out x squared from both sides, so we will get p squared is equal to 4. Therefore p is equal to square root of 4, which is 2. So 2 is the correct answer. Now try to do this one. This one is tricky, so read the question carefully. The vertex of a parabola in the xy plane above is 0, c. So here we have a y-intercept and the vertex lies on x is equal to 0. Which of the following is true about the parabola with the equation y is equal to negative a times x minus b in parentheses squared plus c? Well, we need to find the fact that is true about this parabola. This equation is written in the vertex form, where a is the coefficient of the general form, and this coefficient defines if the parabola opens upward or downward. So since a is negative, the parabola will open downward. This is something that we already know. Now what about b and c? Well, here b and c will be the coordinates of the vertex of this parabola. Now in the original equation we have a negative sign here, so therefore the coordinates are b, c. So choice B is correct. It contains the correct information about this parabola. The vertex is b, c, and the graph opens downward. Try to do this one. It contains a scatter plot, and here you need to draw the parabola of best fit. Now the scatter plot below shows the amount of electric energy generated in millions of megawatt hours by nuclear sources over a 10-year period. In such questions, such details are not important because here you only have equations and the graph, the plot, so reading the plot would just be enough. We can see that this is a scatter plot and it resembles a parabola, so let's draw our parabola. It may look something like this. Of the following equations, which best models the data in the scatter plot? Well, before we even look at those equations, let's look at this red parabola here. We know the general form of the equation of a parabola. Y is equal to ax squared plus bx plus c. Now, when a parabola is downward facing, this term must be negative. So answer choices with a as positive have to go away. This cannot be correct. Now we can also look at the y-intercept of this parabola. We can see that this parabola crosses the y-axis at approximately positive 750 or so. Therefore, the y-intercept has to be positive, because here we have a positive value. Therefore, anything with a negative y-intercept should also go away. Therefore, answer choice D is correct. This is the approximate graph of that parabola. Now here, we didn't even have to think about the coefficient b. Although it is positive, and you may think that the parabola should be at the left side of this plane, it is flipped, and therefore the sign of b cannot tell us exactly where the symmetry axis is. So we just had to look at coefficients a and c in this question. Try to do this problem now. Now let's solve it together. In the xy plane, the graph of y is equal to 3x squared minus 14x intersects the graph of y is equal to x. Now let's imagine this. So we have an xy plane and we have a line y is equal to x. So it's a straight line. We also have a parabola y is equal to 3x squared minus 14x. Now here we do not have any c, that means y-intercept is y is equal to 0. The parabola looks something like this. Now from here we see that indeed the parabola crosses the line at point 0, 0. So this is your first intersection, 0, 0. We also have another intersection here, and on the question it is clearly stated that this is the point A, A. So the x-coordinate here will be equal to the y-coordinate. Now the question is asking for the value of A, so we need to find the location of this intersection. Notice, at that point, the graph of this line is equal to the parabola, so we can equate 3x squared minus 14x to x. That means the parabola here crosses the line. Now we can put this x to the other side, so we get 3x squared minus 15x is equal to 0. From here, what we can do is we can use the simplification method that we talked about in the theoretical part of parabolas in order to solve for the roots of this quadratic equation. So let's solve for the roots. We can factorize 3x out of the parentheses and we will get x minus 5. That is equal to 0. Now, in order for that to be equal to 0, x must be 0, or it can be equal to 5. And therefore, 5 is our second point. So here we got x is equal to 5. And since x is equal to y, y is also equal to 5. This is our second intersection. Therefore, a is equal to 5. This is a great example, and it explains you what to do when you have an intersection of a parabola with a line. Now take a look at this example and try to do it by yourself. Which of the following is equivalent to the expression above? Now there are two methods to do this. Let's use the first method. Here I will just open these brackets and I will look at each of the choices and I will compare them with this equation because it has to be equal to one of those. So let's do this one. We got x plus 3 times x plus 3 plus 5, which gives you x squared plus 6x plus 9 plus 5. And that leaves you with x squared plus 6x plus 14. So this cannot be your correct answer. We cross it out. Now let's take a look at choice B. So first we open the parentheses by simplifying. We get x plus 3 times x plus 3 minus 5, which is equal to x squared plus 6x plus 9 minus 5. And that leaves you with x squared plus 6x plus 4. This is exactly what we have here. So this is equal to this. And therefore B is correct. Now this was the first method. We just simplified the answer choices. But what if you do not have a lot of time? If that is the case, then you can use a second method in which we will just think about this quadratic equation as the general form and these ones, all of them, as the vertex form of the parabola. In order to find the coordinate of the vertex h, we need to know the coefficients b and a. So the x-coordinate of the vertex is going to be -6 divided by 2. H is equal to -3. Now we already know how the vertex form of a parabola looks like. It goes like y is equal to a times x minus h in parentheses squared plus k. So here we already have -3, so we can plug it in here. We get y is equal to, a is 1 here, so we just don't write it down, and we get x plus 3 squared plus k. Now we need to find k. So k is equal to the function of h. So we plug h into this general form of the quadratic equation. K is equal to 9 minus 18 plus 4. K is equal to -5. So this becomes -5. Basically speaking, this is the correct version of the vertex form equation of this parabola. Therefore, the answer is again B. It is up to you to choose which one of those methods to use. But if you're running late on time, then you can quickly use the vertex form method. Try to solve this question. Now, let's solve it together. The function f is defined by f of x is equal to x plus 3 in parentheses multiplied by x plus 1 in parentheses. The graph of f in the xy plane is a parabola. Which of the following intervals contain the x-coordinate of the vertex of the graph of f? Here, we need to find the x-coordinate of the vertex of this parabola. Therefore, the first thing we do is bring it to the general form. X squared plus 3x plus x plus 3. That leaves you with x squared plus 4x plus 3. Now here, b is equal to 4 and a is equal to 1. So the x-coordinate of the vertex, that is h is going to be -b divided by 2 times a, and that is -4 divided by 2. That is equal to -2. -2 lies between 1 and -3. Therefore, choice B is correct. Take a look at this problem. The expression above can be written in the form ay squared plus b, where a and b are constants. What is the value of a plus b? Well, first of all, let's rewrite this expression. We must first spread 10 into the parentheses. Well, this expression is equal to 100y squared minus 1100. Now we sum this with this. So what we get is 7532 minus 1100 plus 100y squared plus 100y squared. That leaves you with 6432 plus 200y squared. So this is a and this is b. And a plus b is going to be equal to 6432 plus 200. That gives you 6632. So this is the correct answer, 6632. Be careful with the calculations in such problems and avoid calculation mistakes. If you need to, double check your calculations in order to make sure that you're doing everything correctly. Try to do this problem and then we will solve it together. In the equation ax plus 3 in parentheses squared is equal to 36, a is a constant. If x is equal to -3 is one solution to the equation, what is a possible value of a? Now, we can plug x is equal to -3 here, so we get -3a plus 3 squared is equal to 36. We can then simplify this by opening the parentheses, so we get -3a plus 3 times -3a plus 3 is equal to 36. Now let's multiply everything. -3a times -3a gives you 9a squared. -3a times 3 gives you -9a. You have another one of those, and you have +9. All of that is equal to 36. You can simplify this by summing up the like terms and dividing everything by 9. So here is the simplified version of this expression. We get a squared minus 2a plus 1 is equal to 4. We can throw this 4 to the other side and we get a squared minus 2a minus 3 is equal to 0. Now you may ask yourself, how can I factorize this? So what two things multiply to give you negative 3 and add to give negative 2? That is negative 3 and positive 1. Therefore, for either this or this to be equal to 0, a has to be either 3 or negative 1. Therefore, choice C is correct. Now, if you're not sure of the correct answer, let's plug a is equal to negative 1 and x is equal to negative 3 and check. Negative 3 times negative 1, that is this multiplication, is equal to 3. And 3 plus 3 squared is indeed equal to 36 because that is 6 squared. And 6 squared is equal to 36. So this answer has to be 100% correct. Take a look at this example and try to solve it by yourself. It says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation. The form of the equation that describes a parabola from which the coordinates of the vertex can be identified as constants is the vertex form, and it looks something like y is equal to a x minus h squared plus k. We already know this. So now we need to approximate the vertex coordinates. Here, k looks like it is below negative 15. So we will say that k is equal to negative 16. And h is precisely 1, so h is equal to 1. Now let's plug these two values into this equation. We get y is equal to a times x minus 1 squared minus 16. The parabola doesn't look too wide and doesn't look too narrow. Therefore, we will say that a is equal to 1. And indeed, from here, you can see that a is equal to 1. So we can just ignore it. Therefore, this is exactly the vertex form equation of this parabola. So we can surely say that the correct answer is D. Try to do this last question by yourself, and the solution to this question you will find on my YouTube channel. Now, these were 11 examples related to quadratic equations and parabolas. I hope you understood everything, and I hope the explanation was clear. Parabolas and quadratic equations are extremely important, so if you ever forget something, please repeat it before the exam, and I guarantee you that once you see such questions in the exam, you will be able to solve them correctly. Thank you for watching this video, and I'll see you next time. Take care. Welcome back. In this video, we're going to talk about general geometry and basic trigonometry for the SAT exam. This class is going to be divided into two parts. In the first part, we're going to cover angles and shapes, areas and volumes, and triangles. Whereas in the second part, we'll be looking at basic trigonometry, circles, and circle equations. SAT geometry is extremely important because this, of course, is a field of math that everybody has to know before the university. So we will look at each of these topics in detail, and we're going to cover all the key strategies and rules for you to succeed in SAT geometry on the exam. For the SAT, you need to know some properties of angles, and you must know that a straight line makes 180 degrees of angle. So the angle that corresponds to a straight line is 180 degrees. Therefore, a line has an angle of 180 degrees. Now, when we have two lines that are directed at the same angle from the horizontal, we call them parallel lines. These lines are inclined at the same angle and they are equidistant. So these are parallel lines, and we're going to be using them a lot in SAT geometry. We already talked about perpendicular lines in the first class, but we defined them with slope and the negative reciprocal of the slope. Today we are going to define perpendicular lines as the lines that have a 90-degree angle between them. So all of the angles here are going to be 90 degrees. And when you sum everything up, it is going to give you 360 degrees. Now let's talk about an angle. An angle is the meeting of two lines. Therefore, for any two lines that intersect or that meet each other at some point, we can create an angle and we can figure it out. The point at which two lines meet is called the vertex. So this is going to be our vertex. Equal angles are the angles that are equal to each other. For example, if you have two angles labeled x, and if they correspond to different shapes, they may still be equal to each other. Now, supplementary angles are angles that add up to 180 degrees. So let's say here you have 70 degrees, here you have 30 degrees, and let's say here you have 80 degrees. All of these angles are supplementary because when you add them all up, they give you 180 degrees. And usually, angles that all lie on top of the same line, for example x, y, and z, are supplementary angles. Now the first rule that we are going to talk about is the opposite angle rule. When two or more lines intersect, they form a series of opposite angles. Angles that are exactly opposite will always be equal to one another. In other words, when you have two lines that somehow intersect at one point, then the angles that are opposite each other, that is, that can be shown with an arrow, those angles will be the same. They will be equal. So if we have 40 degrees here, then we must have 40 degrees here because of the opposite angle rule. Now we also know one other thing. It is that the sum of all these angles here, 40, 40, and x, is going to be 360 degrees. So from one angle that is 40 degrees, we can figure out the other one, since it's the opposite, is going to be also 40. And here we have opposite angles as well, so x and x. We write our equation. 2 times x plus 2 times 40, which is 80, is going to be 360. Therefore, 2x is going to be equal to 280 degrees, and we can divide both sides by 2. So we will get x is equal to 140 degrees. We have just figured out these angles right here. They are going to be 140 degrees. This means that by knowing the opposite angle rule, we can figure out all the angles knowing only one angle. So if this is 40, this must be 40, and we're left with two other opposite angles, which are going to be 140 and 140. This is applicable to all lines that intersect together. Try to solve this question and then we will solve it together. In the figure above, lines L and K intersect at point Q. Also, the figure is not drawn to scale. That means you cannot trust this figure. It is not correct. Therefore, we can only trust this information in such questions. And pay attention, you will get a lot of those on the SAT exam. So trusting this information, we can determine that line L and K intersect at point Q. Also, M is 40 degrees, so this is going to be 40 degrees. And P here is going to be 25 degrees. We're interested in the value of x. One thing we may notice is that this angle and the total angle here are going to be equal because of the opposite angle rule. Therefore, we can say M is equal to P plus x. So 40 is equal to 25 plus x, and x must be 15 degrees. We figured out the answer using the opposite angle rule. Let's talk about opposite interior angles now. When there are two parallel lines that are crossed by another line, called a transversal, the angles on alternate interiors will be equal to one another. In other words, when you have two parallel lines, for example, here we have two parallel lines, and when you have a line crossing those two parallel lines, the angles on opposite sides, this, and this, they will be equal to each other. So if this is x, this must be x from the opposite angle rule, and from the opposite interior angle rule, this will be x, and therefore this will be x. Now, if we say that this angle is y, then we can complete the picture. This is y as well, and this is y, and this is y. Please remember this rule. It is extremely important, and you can find out many things about a shape just by knowing this one rule alone. So let's repeat it. We have two parallel lines, and it must be stated that, for example, line L and line M are parallel. This is the notation of parallel. When you see this, that means two lines are parallel. Next, you have a line crossing those, all right? A straight line that is crossing these two parallel lines. After that, you put one angle, and then the other one on the opposite side. Then on the other side you put another angle. It's going to be equal to those, so x, 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 and on the opposite side of that you put another angle that is equal to x as well. This is the opposite interior angle rule. Now let's try to solve this example. The figure above shows 5 lines. If line L is parallel to line M, which of the following is not equal to 90 degrees? Well, firstly, what is equal to 90 degrees? Well, from the opposite angle rule, this must be 90 degrees. And from the opposite interior angle rule, we'll draw a straight line, so this and this. And this and this, and therefore this and this must be 90 degrees. The same thing goes for the right side. So this, and this. All of those are 90 degrees. But notice, here we have another line, and the angle here, r, from the opposite interior angle rule may be determined as equal to 89 degrees. Therefore, r is not equal to 90, so your answer is A. Try to solve this question as well, then we will solve it together. Again, here it says figure is not drawn to scale, so we can only believe this information here. In the figure above, 3 lines intersect at a point. So let's draw 3 lines that actually intersect at one point. What we can determine from here is this angle and this angle, this one and this one, and last but not least, this and this must be equal by the opposite angle rule. It says if f is equal to 85, that means this one is 85 degrees, and c is equal to 25 degrees, that is this one right here, what is the value of a, this green angle? Well, from the opposite angle rule, let's label all the other angles. We have 85 degrees here and 25 degrees here. Now we said that a is equal to e. These are opposite. So instead of e, we can put another a, like that. Now we can construct an equation. We know that the sum of those must be equal to 360 degrees. So 2 times a plus 25 plus 25, that is 50, plus 85 plus 85, that is 170, must be equal to 360. Now we simplify. 2a is equal to 360 minus 170 minus 50. That's 360 minus 220. That gives us 140 degrees. And therefore a is equal to 140 divided by 2, so 70 degrees. C is the correct answer. Try to do this one right here. It's an amazing question, and you should be able to solve such a question on the SAT exam correctly. In the figure above, L and M are parallel, so we may label that. These 2 lines right here are parallel, so let's draw them, L and M. Now you can see here we have another line passing through them, so that will be our green line, and we have another one, that will be our orange line. Right here we have angle K, and so by the opposite angle rule, here we must also have the angle K. By the opposite interior angle rule, therefore, we must also have K here and here. But it says the angle here is named R, so we can also equate it to R. R and K will be the same angles, they're equal. Now let's label all the others. We have N here, so therefore N is going to be here as well. And by the opposite interior angle rule, N is going to be here and N is going to be here. But since there's an S is equal to N. Also, we have a T here, so N is also going to be equal to T. Now the question is asking, which of the following must equal 180 degrees? And we know that supplementary angles, that are angles on the straight line, when you sum them up, they give you 180 degrees. So here we need to find 3 angles that lie on a straight line. Let's consider this straight line right here. We also have another angle P here. So N, K, and P must be equal to 180 degrees. But since N has another name S, and since K has another name R, we can say S, R, and P equal to 180 degrees, or N, R, and P equals 180 degrees. In the first choice, we have K and an R. K and N and R not necessarily are equal to 180 degrees, because we do not know if R and K plus N will give us 180. So the first choice goes away. Now let's look at the second choice, K, P, and S. So K, P, and S. Well, we already know that those 3 angles lie on the same straight line, so S, K, and P. And therefore we can say that S plus K plus P is indeed equal to 180 degrees. So choice B is actually correct. In such questions, you should label all the angles by all the names they may have, and then find the answer that matches your prediction. Try to solve this one as well. Again, here it says the figure is not drawn to scale, so we can only believe this information. On the figure above, point B lies on segment AC, so let's draw our segment AC. Now point B is somewhere here. If x and y are integers, so we have 1, 2, 3, so 3 lines right here, and we have two different angles. We have x, y, y, and y. Which of the following is a possible value of x? That means, which one of these choices can be one value of x? Well, here we know that x plus y plus y plus y, so plus 3y, must be equal to 180 degrees. Now let's assume different values for y. Let's say that y is equal to 50 for the sake of this example. Now x plus 3 times y, which is 150 degrees, is going to be equal to 180. Therefore, we can determine that x is equal to 30 degrees. So if y is 50, then x must be 30. Well, this is one possible value of x. Therefore, A may be correct. But this is not the only one possible value of x. We may have different values that may yield to a correct answer. Now let's say that y is 40 degrees. X plus 120 is going to be 180, and therefore x may even be 60 degrees. So x is the dependent variable in this question, and y is independent. It can be anything, but the x depends on y. In such questions, you need to assume a value and then try to solve the question. But assume logical values, because otherwise it will take a lot of time. So instead of assuming that y can be, for example, 5 or 10, assume a larger number so that when you multiply it, x is somewhere around all of these numbers. And then you will be able to solve such a problem fast. Try to do this problem as well. In the figure above, which of the following is greatest? Well, first of all, we may determine C. C is going to be equal to 180 minus all the other angles, so minus 60 and minus 70. Well, from here we can understand that C is equal to 50 degrees. Now we see a straight line here, and therefore C plus D has to be equal to 180, like that. And we already know what C is, so plug 50. 50 plus D is equal to 180, therefore D must be 130 degrees. We can also determine E in the same way. This has to be a straight line, and since we have 70 degrees already, 70 plus E will give 180 degrees. So E is 110 degrees. Now here, from the opposite angle rule, we can determine that A must be equal to 60 degrees. And we have two other equal angles here, B, from the opposite angle rule. We already have 60 and 60, so 120. 360 minus 120 gives 240, and when we divide this by 2, we get B is equal to 120. So out of all these choices, D is the greatest. Therefore, the answer is D. Try to solve this question. This will be the last one for the angles. Now, in the figure above, what is the value of y? So, what is the value of this? Well, here, we can see that y and 2x are opposite. Therefore, they're equal. So, we can say y is equal to 2 times x. And 4x and this angle right here will be opposite. So, this is also 4x. Now, we can sum all of those angles and we can equate them to 360 degrees. 4x plus 4x, which is 8x, plus 2x plus 2x, which is 4x, is equal to 360 degrees. So 12x is equal to 360 degrees. And therefore, x is equal to 360 degrees divided by 12. That gives us x is equal to 30 degrees. We already know that y is equal to 2 times x. So y is equal to 2 times 30 degrees, which is 60 degrees. Well, the correct answer is D. This was everything you needed to know about angles. Try to practice the opposite interior angle rule and the opposite angle rule, and you will be able to do literally any question related to angles on the SAT exam. Now let's talk about perimeters, areas, and volumes of different shapes. On the SAT exam, you're sometimes required to find or compare volumes or areas or even perimeters of different shapes. And when we talk about those terms, you should imagine this picture. So the perimeter is the frame or the sum of all sides of a shape. Area is the region inside that shape. And volume is how much space that shape takes up, or how much water you may put in there, for example. Some basic equations to find perimeters, areas, and volumes for different shapes are provided on the booklet. And the equations look like this. So you have equations for the circle, for a rectangle, and for triangle. These are the area equations. So these are areas. You also have triangle equations on the SAT. We will look at them a little bit later. And of course, you have the volume equations. So you do not need to memorize all of those equations. The ones that you see on your screen right now are given to you on the SAT exam, and you can use them whenever you need to. Now let's talk about the perimeter. Perimeter is the sum, the addition of all the lengths of all sides of a two-dimensional shape. For example, here we have an orange rectangle and it has a length and a height. So for this shape, perimeter will be length plus height plus length plus height, since it has two of those. Therefore, perimeter is 2 times length plus 2 times height for a rectangle. Now for a triangle, you will be provided with the sides of all legs, so leg 1, leg 2, and leg 3. And the perimeter of this triangle will be just the summation of all those legs. So L1 plus L2 plus L3. This can be any numbers. The perimeter of a circle is also called the circumference of a circle. And the equation of a circumference of a circle is provided right here. Circumference is 2 times pi times r. So if your radius is here, r, the circumference of the circle, that is the black surrounding or the perimeter of the circle, will be 2 multiplied by pi multiplied by r. Now, pi is a rational number and it's 3.14. We use this number to approximate the perimeter or the circumference of a circle. But on your calculator, pi looks a little bit more complicated. You can use 3.14 for the SAT exam. It will give you good enough approximations. Now let's talk about the perimeter for different shapes, the shapes other than those that we use in our daily lives. For such shapes, again, lengths of all sides will be provided, and you can sum all of those lengths, and by summing those, you will get the perimeters of those shapes. But what if the notation is indirect? So for example, here you have x, here you have x over 5, and here you have x over 5, and if here you have 2x. What do we do in such cases? Well, in such cases, we determine what x is, so here 2x is equal to 50, and therefore x is equal to 25. And then we change those to what we already found, so x is equal to 25. 2x is equal to 50. And x divided by 5 is 25 divided by 5. That gives you 5. When you sum all of those up, you get perimeter equal to 85. So in such questions, look for the unknowns. Now let's talk about areas. You can get the area of any shape by shading the inside of that shape. So for a circle, we can shade the inside and it's going to be something like this. The inside of that shape is going to be your area. Area equations are also provided on the SAT exam. Now we will talk about the areas of rectangles, and for triangles and circles, we will cover those a little bit later. So if your rectangle has a height h and length l, area of that rectangle is going to be length times h, height. So for example, if a length is 3 units and the height is 2 units, the area is going to be 3 times 2, which is 6 units squared. Now, what about the surface area? We have simple area, and we have already seen it, but we also have surface area, and it is the sum of all areas, of all faces of any three-dimensional shape. So here you have a three-dimensional shape, that is a cube. For a cube, all the sides are going to be equal. So if this is a, the height will be a, and the length is also going to be a. So the area of each side of that cube is going to be a times a, which is a squared. Now we said that the surface area will be the summation of all those areas. So now you can see 3 faces, but also behind this picture there are other 3 faces. Cubes have 6 faces. So that is top and the bottom there, right and left, and front and back. Therefore, you're going to have 6 of those, and surface area is going to be 6 multiplied by a squared, that is the length of the side squared. So if the length of one side is 2, then surface area is going to be 6 multiplied by 2 squared, which is 4. That gives you 24 units squared. For rectangular prisms, you also have 6 faces, but this time all sides have different lengths. So you have length here, you have width, and you have the height. And all of those will be different. So we first determine the area of the front and the back. That area is going to be length times height. Now we can determine the area of the sides, the right and the left side. That area is going to be width times height, so A is equal to width times height. And for the bottom and the top face, we also have another area. That area is going to be length times width. Now we have 2 of each face. Therefore, you're going to have 2 of those for rectangles. Therefore, total surface area is going to be 2 multiplied by length times height plus 2 multiplied by width times height plus 2 multiplied by length times width. You can plug any numbers here and you can try to find your own surface area. And now cylinders. Cylinders are made of circles. So on the top you're going to have a perfect circle. Now you're also going to have this side. This side can be thought of as rolling the paper. So think about rolling a paper in your hands. You can roll a paper into a cylinder, and when you open up that paper, you get something like this. And so this area will also be included in the surface area of a cylinder. Now you have 2 circles, top and the bottom. The area of a circle is going to be pi multiplied by r squared. This side, that is this length of the paper that you roll into a cylinder, will be equal to the circumference of the circle that is on top of this cylinder. So they're equal. And we know the circumference of a circle. It's equal to 2 times pi times r. We also know the height of the cylinder. It is labeled as h, so this is going to be h. So the area of this shape here, A, is going to be 2 pi r h. Please remember this. Now the surface area of a cylinder, the whole area here, summation of all those areas, is going to be 2 circles, so 2 times pi times r squared, plus this side, right? So 2 pi r h, this rolled paper here. So this is your surface area of a cylinder. Please do not forget this. You will be using this on your SAT exam. And the surface area formula for a cylinder is not provided in the formulas. So you must keep this in mind. Now let's talk about volume. Despite the fact that you have volume equations on your SAT booklet, we still must know what the volume is. For any 3-dimensional shape, the volume will be width times the length times the height for a rectangular prism, and we said for such cubes, for example, all of those will be the same, so it will be A, and A. So volume here is going to be A cubed, A multiplied by A multiplied by A. For a rectangular prism, you may have a length, a width, and the height, h. So the volume is going to be length multiplied by width multiplied by height. And for cylinders, we must think of volume as the top area multiplied by height. Top area of a cylinder here is going to be the area of a circle that makes this cylinder, so pi times r squared, where r is the radius of that cylinder, that circle on top. And the height is just any number that they give you, so h. So the volume of the cylinder is going to be top area pi r squared times height h. This is the volume of your cylinder. Now let's see some example problems from the SAT. Which of the rectangular solids shown above has a volume closest to the volume of a right circular cylinder with radius 2 and height 4? Now let's think about this case scenario for a second. Before we solve this problem, we must find the volume of a cylinder with a radius 2 and height 4. We already know what the volume equation for a cylinder is. Volume is going to be equal to pi r squared times h. So here the volume is pi times r squared, which is 2 squared, which is 4, times height, which is also 4. That is equal to 16 pi. Remember what we said about pi? Pi on the SAT will be approximately 3.14. And for this example, we can take 3. Therefore, volume of this cylinder is approximately 16 times 3, which is 48. So we're looking for a shape that has a volume of 48 units cubed. This shape has a volume of 3 times 3 times 3, so 27 units cubed. This one, 4 times 3, that's 12, times 3, that's 36. This one is 5 times 3, 15, times 4, 60 units cubed. This is 4 times 4, 16, times 4, that's 64. And here, 4 times 4, it's 16 times 3, well, that's exactly 48. That means this is the shape that has approximately the same volume as this cylinder. So the answer is E. Let's see another example. Try to read this and solve it by yourself. The interior dimensions of a rectangular fish tank are 4 feet long, 3 feet wide and 2 feet high. So let's imagine this fish tank. It is 4 feet long, that means this is 4, 3 feet wide, so the width is 3, and 2 feet high, so the height is 2. The water level in the tank is 1 foot high. That means we have water here, and the level of that water is 1. Therefore, we can find the volume of this water. Volume is going to be 1 multiplied by 4 multiplied by 3. So the base times the height. That is going to give us 12 units cubed. And since the units is feet, right? Feet, so we get 12 feet cubed. The volume of this water in the tank is 12 feet cubed. Now it is stated in the question that all of the water in this tank is poured into an empty second tank. So let's draw that empty tank. So let's assume that it is empty in the beginning, and the measures of this tank are 3 feet long, 2 feet wide and 4 feet high. So we pour all of this water into this tank and we fill it somehow, right? But we do not know how much we fill it. We do not know the height level of the water in that tank. So we're looking for the height level. What is the height of the water in the second tank? Now we already know the volume of the water. So it's 12. And that's going to equal to 3 times 2 times height, since we poured the same amount into the new tank. So height multiplied by 3 multiplied by 2, that's height multiplied by 6, is going to equal to 12. Therefore, height is equal to 12 divided by 6. That gives us 2 feet. So the level of the water in this tank is 2 feet. D is the correct choice. In some questions, like this one, you're required to go backwards. So you already know the volume, find the height. And we know that height is equal to volume divided by the base. Height is equal to volume divided by base area. The area of the base is 3 by 2 here. The area of the base is 4 by 3 here. So height here is 1 and here height is 2 feet. Now keep this in mind. In some questions on the SAT exam, they may ask you to find the volume of a combination of shapes. So here we have 2 cones like this, 1 and 2, and we have 1 cylinder here. So that is your cylinder. So the combined volume of all of those shapes will give you the total volume of this shape here. And in order to find that, you can use these provided equations. You have the equation of a volume for the cone, that is 1 over 3 times pi, times the radius of the cone, so this, squared times height, the maximum height of the cone here, and you already know the volume equation for a cylinder. So by combining 2 volumes in 1 cylinder, you can obtain this shape, and therefore its volume. This was it for the volumes. Now let's talk about triangles. Triangles are very important because you will see a lot of questions related to them on the SAT exam. And knowing many properties is going to be useful for you during the exam. There are different types of triangles and certain rules for those triangles. So first of all, let's talk about what a triangle is. Not everything can be a triangle, right? Triangle is the intersection of three lines. So three straight lines intersect, and they intersect at some different angles, and they make a shape called a triangle. The sum of those angles inside the triangle, x plus y plus z, is going to be equal to 180 degrees. Now there are a few special triangles that you must know before going to SAT. These special triangles have special rules and special names. Let's start with the first one. Equilateral triangles. Such triangles have equal sides. So if this is L, then this is L, and this must be L as well. For instance, 3, 3, and 3. The lengths of all sides are the same, and therefore the corresponding angles must be the same as well. So all of the angles are going to be the same for equilateral triangles, and therefore each interior angle is going to be 60 degrees. In the figure above, triangle ABC is inscribed in the circle with center O and diameter AC. If AB is equal to AO, that means this segment right here is equal to this segment right here, what is the degree measure of triangle ABO? First of all, AO is a radius, and this is radius as well, because they're equal. Also, we know BO is a radius of this circle right here. Therefore, all these sides are the same, and this is an equilateral triangle. So each angle here will be 60 degrees. The correct answer is D. Now let's look at isosceles triangles. Isosceles triangles are triangles with two equal sides. So as opposed to equilateral triangles here, only two sides are going to be equal, and therefore the corresponding angles. So two angles of the isosceles triangles are going to be equal. By knowing one of those, for example 20 degrees, you can learn the other from the rule, that is going to be 20 degrees as well, and by summing everything up and equating it to 180 degrees, you can find the other one, the missing angle, 140 degrees for example. Now here, if this side is 5 units long, this side must also be 5 units long. This is isosceles triangles. Try to do this example. Two isosceles triangles are shown above, and the figure is not drawn to scale. 180 minus z is equal to 2y, and y is equal to 75. So let's write down this relationship. 180 minus z is equal to 2 times y, which is 2 times 75, that's 150. Therefore z, by rearranging, is 30 degrees. So this angle right here is 30 degrees. These two triangles are isosceles. So if this angle right here is 30, these both are going to be equal because of the rule for isosceles triangles, and 30 plus these two angles is going to be 180. So let's call those angles K, alright? So this is K, and this is also K. Now 2K plus 30 is going to be equal to 180, the internal sum of angles for a triangle. So 2k is going to be equal to 150, and k is equal to 75 degrees. So this angle right here is 75 degrees. We're asked to find the value of x, and we may notice that if k is this and x is this, they lie on one line, a straight line, so they're supplementary angles. And so if k is 75, then here we must have 105 degrees. Therefore, x is equal to 105 degrees. This is your correct answer. The other type of special triangles is the right triangles, and such triangles can be categorized. But the first thing you have to know about such triangles is that right triangles have one angle that is equal to 90 degrees. So one of the three angles of that triangle is going to be equal to 90 degrees. Therefore, the sum of the others is going to be equal to 90 degrees as well, because all of that, 90 plus x plus y, is going to be 90 plus 90. So 90 plus x plus y is going to be equal to the total 180 degrees. When we cross out 90 here, we are left with x plus y is equal to 90. So the rest of the angles must always complete a 90 degree. Let's talk about special right triangles now. Special right triangles include isosceles right triangles. This is a triangle where you have one 90 degree angle and two 45 degree angles. It's isosceles because those angles are equal and therefore the sides must be equal as well. For such a triangle, there is an important rule. If the length of those sides is s, then the length of the larger or the longer side that corresponds to the 90 degrees is going to be s times root of 2. And root 2 is approximately 1.41. Alright, so that's an approximation. So if s here is 10 and this is 10, then this side is going to have a length s root 2, which is 10 times root 2, which is 10 times 1.41. So approximately 14.1 units long. Alright, that's a rule. Now what if you have only this side's measure? For example, what if they said that this side is equal to 20. How do you find the other ones? Well, we know that s times root 2 is equal to 20 in this case, alright? And therefore, s must be equal to 20 divided by root 2. So s is approximately 14.14, alright? So this side will be 14.14, and this side as well, 14.14. Well, that is our relationship that we must know for isosceles right triangles. The other type of right triangles is the 30, 60, 90 degree right triangle. Alright, this triangle is an amazing one because we have a set of rules that we can apply for this one as well. Here, if the shortest side is x, then the longest side is going to be 2 times x, and the one at the bottom is going to be x times root 3. Now, this one is not always at the bottom. The triangle may look something like this as well, where here we have 30, here we have 60, and here we have 90. But anyway, you have to know that the side that corresponds to 60 degrees is going to be x root 3, side that corresponds to 30 degrees is going to be x, and the hypotenuse, or the side that corresponds to the 90 degrees, is going to be 2 times x. Therefore, if you're given one of the measures, one of the sides, so for example, x is equal to 5, right, here we have 5, then we can find all the others. Here we're going to have 10, and here we're going to have 5 root 3. Another very important rule that you're not only going to use in the SAT exam but also in your university is the Pythagorean theorem. And it applies only for right triangles. The theorem goes like this. The length of the longest side squared is going to be equal to the length of the short side squared plus the length of the other side squared. So a squared plus b squared is equal to c squared. Therefore, from here, c, longest side, is going to be equal to square root a squared plus b squared. So if you have a and b, you can find c using this equation. So if a is 10 and b is 12, for example, you can plug the values here and you will get c. And of course you can rearrange this equation. So if you do not have a but you have b and you have c, you can solve for a by rearranging. A is going to be c squared minus b squared all in square root. This is how you can find one side that is missing when you have a right triangle. So let's solve a problem now. The height of a right circular cylinder is 5. So let's draw our right circular cylinder. The height of this cylinder is 5, right? So this side is 5. And the diameter of the base, so this diameter here, is going to be 4. So this is 4. Therefore, we can also determine the radius. Radius is going to be 4 divided by 2, which is 2. Now the question is asking, what is the distance from the center of one base, so from this center, to a point on the circumference of other base? So here we have a circumference of the other base, and we may find a point like this. So we're asked about the distance here. Distance from the center of one base to the point on the circumference of the other base. This makes a right triangle because right here we have 90 degrees. In order to find that distance, what we need to do is we need to use the Pythagorean theorem. X squared is going to be equal to 2 squared, the short side squared, plus 5 squared. And therefore x is equal to square root 2 squared plus 5 squared. All of that gives you square root 29, and therefore the answer is C. So you see, sometimes you use the Pythagorean theorem for different shapes. Therefore, you need to be able to notice the situation and choose the appropriate equation to use. Pythagorean theorem, along with the relationships for special right triangles are provided on your SAT booklet, so you do not need to memorize those, but you just need to know how to use them. Now, another thing you may want to know about triangles is the area formula for a triangle. This one is also given on the booklet. Area of a triangle is equal to 1/2 times the base, so the length of the base, times the height of a triangle. But here the height is not this and not this. The height is the largest height that a triangle may have. So for example, here the largest height is this green line. Therefore, we say that that's your height in this formula. The value that you get here is going to give you the total area of that triangle. Another relationship is the perimeter of the triangle. And as we already said, when you sum up the length of each leg of a triangle, you will get that perimeter. One last thing that you need to know about triangles is the relationship between similar triangles and the ratio. When you have triangles that have the same angles but different sides, you can find a relationship. You can find something in common. Well, here, the angle x is equal to the angle x here, and angle y here is equal to angle y here. So let's say this is 30 degrees, and this is also going to be 30. Let's say this is 70, and therefore this has to be 70 as well. And let's say z is 80 degrees, so this is also 80 degrees. Same goes for the bottom triangle. Now, in such cases, what we must know is the sides that correspond to those angles. So, for example, side C and F will have a proportion. These sides will be proportionate to each other. Let's say side C has a measure 10 and side F has a measure 5. The proportion here is going to be 2. We multiply 5 by 2 to get 10. So if this is the case, this triangle is 2 times smaller than this triangle. And if we know any other side of that triangle, for example, the one that corresponds to angle x, let's say it's going to be 8, then we can find that same corresponding side on the other triangle. We said the proportion is 2, this one is 2 times smaller, so that side is going to be 4. And of course, we can find the side that corresponds to the 70-degree angle here. If this, for example, is 12, then this must be 2 times smaller, so 6. Such a shortcut will be very useful for you. You just need to know that the triangles are similar when they have equal angles for all sides. Now, another form of such triangles may come out when you connect two parallel lines. So let's say this is L and M, and L is parallel to M. So when you connect those by two opposite lines, you get a butterfly triangles. What this means is that those two triangles will be proportional, or they will be similar as well. Here you have the opposite angle rule. That means if this is x, then this has to be x as well. And from the opposite interior angle rule, if this is y, then this must also be y. And last but not least, if this is z, then this also must be z, right? You see, they're all opposite. Now, what you must know is that if you know two sides, so for example 10 here and 2 here, you may learn about the proportion or the ratio. The ratio here, R ratio, is going to be 10 divided by 2. That's 5. That means this triangle is 5 times larger than this triangle. So let's keep this ratio in mind. So if I say that this side right here has a measure 3, then this side right here that lies on the same straight line must be 5 times larger than 3. So that's going to be 15. Notice they lie on the same line. That's why I compare this one to this one. Also, they are opposite to angle Z, right across it. This is why I compare them both. And try to guess what happens if I say that this side is 25 right here. What do you think this side will be? Well, it will be 5 times smaller. It will be 5. Of course, this triangle is not drawn to scale, but it is just there to show you that there is a rule called the similar triangle rule, and that it states that there is a ratio between two triangles that are connected by two parallel lines. And you can find a lot of information on the sides of those triangles just by knowing the ratio. So let's try to practice. Try to solve this problem. In the figure above, AE is parallel to CD. That means these two lines right here are parallel. And these triangles will be similar then. Segment AD, so that is this segment, intersects CE at this point B. What is the length of segment CE? Now we already may find the proportion, 10 and 5. So 10 divided by 5 is equal to 2. Therefore this triangle will be 2 times larger than this one. From here we can find the length of the side CB. It is going to be 2 times smaller than 8. That's going to be 4, because they lie on the same line. Now in the question we're asked to find the length of segment CE, the whole segment here. So CE is going to be equal to 4 plus 8. That's 12. All we had to do is find the length of segment CB. Try to do this one as well, and you will find the solution to this problem on my YouTube channel. So thank you for watching this video. I hope it was useful for you. Today, as a reminder, we have covered angles and shapes, areas and volumes, and triangles. In the next part of this video, geometry, we're going to cover basic trigonometry, circles, and circle equations. I hope the explanation was clear and the examples were good. Thank you for watching, and I'll see you the next time. Take care. Hello there! In this video we are going to cover basic SAT trigonometry and circles and circle equation. So let's start with basic trigonometry. Now first of all, we need to define the term trigonometry, what it means and how do we deal with it on the SAT exam. Trigonometry is a branch of math that deals with relationship between angles and lengths of triangles, and it's actually a lot of fun. Before we come to equations, we first need to understand the names of the sides of triangles and what they represent. So first of all, let's define the angle of interest. So angle of interest is the angle that we are going to be building our trigonometric equations upon. And when we talk about the angle of interest, we just mean the angle that we're dealing with. This angle, for example, here, or this angle here, right? So let's deal with the first triangle on the left side. The side that is right across this angle is going to be called the opposite side of this triangle, so opposite. Now the side that is right across the 90-degree angle, so this side, is called the hypotenuse of this triangle. And the side that connects the hypotenuse to the angle right here, so this side, it's going to be called adjacent. So that is your adjacent side. Now what about this triangle? Here the angle of interest is different now. So the side that is right across that angle is going to be again opposite, and we will call it up, right? So instead of opposite we will be writing up. Again, we have a 90-degree angle here. So right across it we have the hypotenuse. Hypotenuse. It's always the side that is right across the 90-degree angle. And the side that connects the hypotenuse to the angle is going to be called the adjacent, right? So this is the abbreviation. Instead of hypotenuse, we can in fact write hype, alright? So that's easier to deal with. So now we know the names of the sides of triangles. Now, as you may have already noticed, the names of the sides depend on that angle, right? So as the angle changes, names of the sides change as well. Now let's come to the trigonometric equations. So we have this little shortcut here for the SAT. So, ka, toa. Now this thing you really need to memorize because it's going to save you on the exam. So, ka, toa is the abbreviation for our trigonometric relationships. S stands for sine. Sine is a mathematical operator. C stands for cosine, again a mathematical operator. And T stands for tangent, alright? So tangent, cosine and sine. Now the shortened versions of sine, cosine and tangent are sin, cos and tan. So this is the way you're going to be seeing those on the SAT exam. And basically speaking, what this relationship stands for here is the ratio. So sine of angle A is going to be opposite, right? The side that is right across the angle A divided by hypotenuse, right? The side that is right across the 90-degree angle. So sine of A is going to be opposite divided by hypotenuse. Sine A is equal to opposite divided by hypotenuse. And this is exactly what this SO stands for. Sine is equal to opposite divided by hypotenuse. So numerator, denominator. Okay, opposite divided by hypotenuse. Now let's talk about cosine. So cosine of this angle right here, cosine is going to be the ratio of adjacent side, and we already know adjacent side is this one right here. It's going to be the ratio of adjacent to hypotenuse. Well, hypotenuse is right here. So for example, if this angle right here is 60 degrees, let's say, and if adjacent is 1 and let's say hypotenuse is 2, then cosine of that angle 60 degrees, cosine of 60, that is A, is going to be adjacent over hypotenuse, so 1 over 2. That is just an example, but this is the way it goes. It's a ratio of an angle, right? It's the ratio of these sides. Now, what about tangent? So if this is an angle A, right, and if this is the opposite side to A, let's say it's going to be 3, okay, and this is the adjacent side, so let's say adjacent side is going to be 4, okay, so the tangent of that angle A then is going to be the ratio of opposite side, which is 3, to the adjacent side, which is 4. So tangent A is going to be 3 over 4. And this is exactly what TOA stands for. T, tangent is equal to O, the numerator, so the opposite, divided by A, denominator, that's adjacent. Now this relationship is extremely important because it's going to relate lots of numbers in triangles on the SAT exam. So remember this. Sine of A is opposite divided by hypotenuse. Cosine of A, let's say A is 60 degrees, is going to be adjacent over hypotenuse, and tangent of angle A is going to be opposite divided by adjacent, the relationship between these sides. If you need to, then stop this video for a second and try to memorize this and try to understand the relationship here. Of course, we're going to solve many examples, so we will have time to practice those problems. Now, another very important relationship here for the trigonometry part of the SAT exam is this. Cosine 90 degrees minus x is equal to sine x, and sine 90 minus x is equal to cosine x. Now, what is this set of rules here? I mean, what does it imply? Well, first of all, let's say this is our x, and let's say right across it we have the opposite side, and let's say opposite is equal to 3. And right here we have the adjacent side. Let's say adjacent is equal to 4. Now here we know that we have hypotenuse. So let's say hypotenuse is 5. Alright, now let's build our relationship. Sine x, right, sine of x is going to be equal to opposite divided by hypotenuse. So opposite over hypotenuse. And that's going to be equal to 3 divided by 5. Well, that is great, and that is our sine x. What is cosine 90 minus x? Well, you need to keep in mind that this angle right here is going to be angle 90 degrees minus x. So this is your angle. This actually is an angle. This is the rest of the triangle. And let's find the cosine of this angle right here. So right across it we have the opposite. Here we have the adjacent. And right here we have the hypotenuse. So cosine of 90 minus x, ka, adjacent over hypotenuse. We already said that the adjacent is going to be 3, right? Because it connects this angle to the hypotenuse. So that is 3. And the hypotenuse is 5. So you see the relationship holds true. Sine of x, that is equal to 3 over 5, is equal to cosine 90 minus x. And that is equal to 3 over 5 as well. And the same goes for the opposite, right? For the absolutely opposite relationship. Let's say we're now dealing with this angle and it's going to be called x. And of course this is going to be 90 minus x. So right across x we have the opposite side. Right next to it we have the adjacent side. And here we have the hypotenuse. So hyp. Now let's say hypotenuse is again 5. Let's say adjacent is 3. And let's say opposite is 4 for the x. Now cosine x is going to be adjacent over hypotenuse, which is 3 over 5. And the same thing goes for sine 90 minus x. Sine 90 minus x here, the opposite now is 3, right? So this is not adjacent anymore. This is opposite. Well, here we don't have opposite anymore for 90 minus x. It connects 90 minus x to hypotenuse. And therefore, here we have the adjacent side. This is going to be adjacent. And hypotenuse, it always stays the same. So sine 90 minus x is again opposite over hypotenuse. So 3 over 5. And again, sine 90 minus x is actually equal to cosine of x. So this relationship always works. It depends on how you define x, right? But as long as this is x and this is 90 minus x, it will work. Same goes for here. If this is 90 minus x and this is x, this relationship will always work. Both relationships work both ways. And you need to basically understand this idea, and you need to know the reason why it works. Of course, you need to memorize these relationships because you will be asked directly about this relationship on your SAT exam. Now, let's practice the basic SAT trigonometry by solving a few questions. So read this question, try to solve it by yourself, and then we will solve it together. My advice to you, whenever you're dealing with trigonometry questions and whenever you have sine, cosine, tangent, or some relationship, you need to draw your triangle first, alright? And then you should work on it. So in a right triangle, one angle measures x degrees. So let's say this is our x, where sine of x is equal to 4 over 5. Now we said so, ka, toa. So is for sine. Sine of x is going to be equal to opposite side divided by hypotenuse side. So opposite divided by hypotenuse, that is, this is opposite, so that's 4, and this is hypotenuse, right? So that is 5. Opposite divided by hypotenuse is sine x, and that is 4 over 5. Now we have found the lengths of both sides, okay? So the length of both sides is 4 and 5. Now the question is saying, what is cosine 90 minus x? Well, we know the rule, and for those who know the rule, they can straight away say, okay, if sine x is equal to 4 over 5, then cosine 90 minus x also must be equal to 4 over 5, right? But if you don't believe this, then let's try and see for ourselves. This is going to be our angle 90 minus x. Now, let's erase the arrows here, and let's say this side right here is going to be the opposite side to 90 minus x. And this side right here is going to be the adjacent side. Well, this stays the same. It's the hypotenuse side. Now, cosine is ka, and that stands for cosine 90 minus x is equal to adjacent over hypotenuse. So the adjacent for this angle right here is going to be 4, right? So that's 4. And the hypotenuse, we already know, is 5. Again, we have proved this relationship. Sine x is equal to cosine 90 minus x. So 4 over 5 must be equal to 4 over 5. The answer is 4 over 5. Now let's try to solve another problem. Try to read it and then we will solve it together. So it says, the angles shown above are acute and sine A is equal to cosine B. So sine of this angle right here is going to be equal to cosine of this angle right here. Now if A is equal to 4k minus 22 and b is equal to 6k minus 13, what is the value of k? First of all, we must know that if sine A is equal to cosine B, then we can replace this b by 90 minus A, right? So sine of A is equal to cosine 90 minus A. This is our relationship. From this relationship, we can understand that b is actually 90 minus A. So we can write it down. B is equal to 90 minus A. Well, that is also equal to 6k minus 13 as given here. So we have one relationship. 90 minus A is equal to 6k minus 13. So let's erase this. We have figured out one important relationship. We are also given that A is equal to 4k minus 22. So why not take it and plug it in here? Instead of A, we will write 4k minus 22. So 90 minus, in parentheses, 4k minus 22 is equal to 6k minus 13. Now we have an equation with one unknown. The unknown is k, and we need to solve for it. So yeah, let's try to solve. First, open the parentheses. 90 minus 4k plus 22 is equal to 6k minus 13. Throw this k to this side and 13 to that side. Negative becomes a positive. So we get 90 plus 22 plus 13 is equal to, and here negative becomes a positive on the other side, 6k plus 4k. And when we add everything up, 125 is equal to 10k. Alright, so 125 is equal to 10k. Therefore, we can divide both sides by 10, and we will get k is equal to 12.5. So there you go. K is equal to 12.5, and therefore the answer is C. Now, here I have demonstrated the importance of this relationship. We can actually use it to solve some hard problems on the SAT exam. Now, try to solve this question, and then we will solve it together. So as I said, whenever we see sine or tangent or cosine, we need to draw our triangle. So triangle PQR has a right angle Q. So let's say this is our triangle PQR. It has a right angle Q. Let's say this is P and let's say this is R for the sake of this problem. If sine R, that is this sine of this angle right here, angle R, is equal to 4 over 5, what is the value of tangent P? Now, in order to find tangent of this angle right here, angle P, we first need to find all of the sides, the measures of all sides for this triangle. From this relationship, sine r is equal to 4 over 5. Well, we already know that sine is equal to opposite divided by hypotenuse. For this angle of interest, opposite is going to be right here, so that's 4, and hypotenuse is always right across the 90-degree angle, so that is 5. Now what about side QR? What is the length of that side? From the Pythagorean theorem that we've covered in the previous class, we know that x squared plus 4 squared must be equal to 5 squared. Well, from here we can rearrange, throw 4 squared to the other side, and therefore x squared becomes 5 squared minus 4 squared. So x squared becomes 25 minus 16. So x squared is equal to 9. And therefore, by taking square roots of both sides, we get x is equal to 3. So this side right here is going to have a length of 3 units, right? So we have found the length of this side. It's 3 from the Pythagorean theorem. Now we also know the relationship. Sometimes students know this, and you should know this as well. So there is a 3, 4, 5 triangle. As long as the hypotenuse is 5, any of those sides may be 4 or 3, right? So that is something to keep in mind as a shortcut. Now we're interested in tangent P. First of all, tangent of any angle is going to be opposite side to that angle divided by the adjacent side to that angle. We're talking about angle P, so right here, right? So opposite here is going to be this one, 3. So we write it as the numerator, and the adjacent side to angle P is going to be this side, right? Because it connects angle P to the hypotenuse. So that is 4, okay? So there you go. Tangent P has to be equal to 3 over 4. And the relationship SOHCAHTOA, right? SOHCAHTOA helped us to solve this problem. So you should just keep this one in mind and know how to use it. You should of course know the names of the sides of the triangles, and you should remember this relationship right here. This will help you a lot on the SAT's trigonometry questions. Now let's talk about circles and circle equations. So first of all, what are circles? Well, we know these are the circular objects, but mathematically, how can we define circles? A circle is a two-dimensional shape that is formed from the infinite number of points equidistant from a single point. Let's have a center here. That is our single point. Now, a set of infinitely many points that are going to be equidistant, and therefore they're also going to be connected, right? So set of those connections is going to give us our circle right here. And all these points are going to be equidistant from the center circle. Now we measure circles in degrees. Since of course circles do not have any sides, the only thing that we can measure actually with degrees is the angle about the center of the circle. And the total angle that a circle makes is actually 360 degrees. So the full circle is going to be 360 degrees. Well, a semicircle, that is the half of a circle, is going to be 360 divided by 2, so 180 degrees. And think about it like that. You just have a line, and it's also 180 degrees, and you draw the semicircle here, so the half of a circle. Well, to find a piece of a circle, you must find it in relation to 360 degrees sometimes. Therefore, you may even think about a slice of pizza. Let's say we have a slice of pizza like this, and let's say the corresponding angle measure here is 30 degrees. Well, that means the piece of a circle here is going to be 30 divided by 360 degrees. That gives you 1 over 12. So this is 1/12 of a circle. That means you can draw 12 more pieces like that, and they all are going to have the angle measure of 30 degrees. Okay, so when you are interested in a fraction, you need to divide the angle measure of that little piece of a circle by 360 degrees, and you will get what part of a circle that little chunk is. So in our case, it's 1 over 12. Now let's also define circumference. We have talked about the perimeter for different shapes. For rectangular shapes, the perimeter was the summation of all sides, alright? So we could exactly sum all the sides and we could get the perimeter. But what about the circle? As we said, circles do not have any sides. Well, that means they just have a surrounding, right? Surrounding. And therefore, when we talk about a perimeter of a circle, we actually call it the circumference of a circle here. This is going to be the circumference of a circle. Now, the diameter of a circle is any straight line that passes through the center of the circle and connects both ends, alright? So anything that passes through the center of a circle and connects two ends of a circle will be your diameter. We also have radius of a circle. Radius is the half of a diameter. So any segment that comes from the center of a circle to any point on the circle will be your radius. So this is r, radius. Now there is an equation, the formula to find the circumference of a circle. Circumference of a circle is going to be pi multiplied by diameter, or 2 times pi times radius. What does that mean? That just means this. If you need to find the perimeter of a circle, all you need is its radius. Okay, so r. Let's say radius is equal to, for example, 4. Now the circumference of this circle is going to be pi multiplied by diameter. And diameter is 2 times radius. So diameter of this circle is going to be 2 times r, which is 2 times 4, which is 8. Therefore, circumference is going to be 8 multiplied by pi. What is pi then? Well, pi is a constant. It's a number, and it can be approximated by 3.14. So we can say that pi is almost equal to 3.14. And when you need to find the circumference of a circle and you do not have a calculator, you can take pi as 3.14, or sometimes you can take it as 3. So the circumference of this circle then is going to be equal to 8 times almost 3, and that's almost 24. So this perimeter, the circumference of the circle, is going to be 24. Well, we do not necessarily need to use a diameter. Instead, we can just plug a radius, so 4 inside this formula. Well, since diameter is 2 times r, well, here you have that simplified version. Circumference is equal to 2 multiplied by pi multiplied by r. Let's have a little practice here. The two semicircles in the figure above have centers r and s. So this is r and this is point s, and these are actually the centers of these two semicircles. We have this semicircle right here, and we have another one right here. The question is stating if rs is equal to 12, so that means this segment right here is going to be 12 units long. What is the total length of the darkened curve? So what is this curve's length here? Now, we may find the length by using the circumference formula. Circumference of a circle is 2 multiplied by pi multiplied by r. Here we have semicircles, so halves of the circles. So circumference of the semicircle is going to be 1/2, because we only deal with the half of a circle, times 2 times pi times r, and that gives you pi times r. So circumference of the half of a circle is going to be pi multiplied by radius. Now what is the radius for each of those circles? Well, we know the sum of them. There are some, so radius of the smaller one and the radius of the biggest one is going to be 12. We can divide them like this. This one can be 4 and this one can be 8. Or it doesn't matter, this one may be 6 and this one may be 6 as well. As long as it satisfies this, it's okay. Now we already know the circumference formula for the semicircle. We're just looking for the total length here. So let's find the circumference of the red semicircle. Circumference of the red semicircle is going to be pi multiplied by 4. And now for this one, circumference is going to be pi multiplied by 8. Now we need the sum because we need the total length of the darkened curve here. If I erase these colors, you will see a darkened curve. Therefore, the sum right here is going to be 12 pi. And the answer is 12 pi. The length of this darkened curve right here is going to be 12 multiplied by pi. We found it using the circumference of a semicircle equation. Now, let's talk about something else that we need to know about circles. We said that the angles of circles can be measured with degrees, but we also can measure them with radians. So this is a new term that you must know for the SAT exam. 1 radian is the measure of the central angle whose arc length, this is your arc length, right, is the same as the radius of the circle. So if radius of the circle, for example, is 3 and your arc length is also 3, the angle right here, the angle that corresponds to the arc length of radius, is going to be equal to 1 radian. 1 radian. Now what exactly is 1 radian? 1 radian is equal to 180 degrees divided by pi. This is almost 57.3 degrees. But we do not use this number usually. What we usually do is we construct the equation that states 2 times pi radians is equal to 360 degrees. So 2 pi radians will give us the full circle, 360 degrees. That means 2 times pi times this angle right here is going to give the total rotation, 360 degrees. So if 2 pi radians is equal to 360 degrees, then we can divide all by 2, we will get pi radians is equal to 180 degrees. And we can divide both sides by pi to get radian. 1 radian is equal to 180 divided by pi. So that is almost 57.3 degrees. There you go. Now, this one right here, this whole relationship is pretty important because sometimes instead of dealing with degrees, sometimes you're dealing with radians, right? And knowing how to convert from radians to degrees or from degrees to radians is also pretty important. So keep this in mind and please try to remember this relationship right here. It's going to be very useful on your SAT. 2 pi radians is 360 degrees. Let's now talk about the area of a circle. Now, just like any other two-dimensional shape, a circle also has an area, and it turns out in order to find the area of a circle, all we need is the radius of that circle. Once we know the radius, we can plug it into the equation here. Area of a circle is equal to pi multiplied by radius squared. So let's say if radius is equal to 4, for example, then area is going to be pi multiplied by 4 squared. That gives you 16 pi. So the area of the whole circle is going to be 16 pi units squared. So if it's meters, it's going to be meters squared because area is multiplication of lengths, so to say. So it's going to be meters squared, or maybe even centimeters, or feet squared, or I don't know, inches squared, but it's going to be squared. So either meters squared or centimeters squared, it may be millimeters squared. As long as it's squared, it's okay, it's the area. So here you go, the equation of the area of a circle. What if you don't want to find the whole area, but you want to find the area of a little chunk, of a little piece of a circle, like a pizza slice? What do you do then? Well, then you need two things. You need the radius of that circle, and you need to know the angle that corresponds to that slice of the circle, alright? So there you go. Let's call this angle theta, right? So this is your Greek letter and it's called theta. You will see this a lot in geometry. Now, if we have this angle and we have this radius, then we can actually find the area of this little piece of the circle. Area of a sector. The sector is this piece. This is what we call sector. So area of a sector is going to be the angle divided by 360 degrees multiplied by pi r squared. What is pi r squared? pi r squared is the area of a full circle, right? Pi r squared is the full area of a circle. And so essentially what we're doing right here is we take the angle measure, and for example, if it's 30 degrees, then we divide 30 by 360, we get a proportion, for example 1/12, and we multiply it by the area, the full area. So we get 1/12 times pi times r squared. If r is, I don't know, let's say r is equal to 3. So if r is 3, then you get pi times 9, right? So your area becomes 9/12 pi. This is the same as 3/4 pi. So the area of this little sector here is 3/4 pi. We found the ratio of the angle. We said the angle would be 30 degrees, let's say. We found the ratio. So 30 divided by 360, and we multiplied by the full area of this circle. And we found the area of that little sector, little slice of pizza, so to say. So keep this in mind. The area of a sector is this angle measure divided by 360 degrees multiplied by the area of a circle. Of course, the area of a sector can be also found using radians instead of degrees. So if you have not 30 degrees, right? If you have pi over 6 radians, let's say, right? Pi over 6 radians, then you can plug this angle right here, and you can use this formula for the area of a sector, okay? So instead of 30 degrees, they said the angle measure here is pi over 6 radians. Well, what do? You plug that angle measure in order to find the area of a sector into this equation. You put everything in there and you calculate the area using the angle measure of a radians. Of course, we don't deal a lot with radians on the SAT, so you should be happy about it, but at the same time it's a good thing to know. Now let's also learn how to convert from degrees to radians, or from radians to degrees. So conversion of angles from degrees to radians. Well, the only thing that we need to convert is the initial formula that I taught you. 2 pi radians is going to be equal to 360 degrees. So if you want to find 30 degrees, you need to divide 360 by 12, right? So you divide this by 12 as well, and you get 30 degrees is equal to 2 pi over 12 radians. That's pi over 6 radians, right? Or if you want to convert to 90 degrees, you divide 360 by 4, that gives you 90, and then you divide the left hand side by 4 as well. So pi over 2 radians is also going to be 90 degrees. There you go. And essentially you can use this equation here as your guide. It will help you to convert from degrees to radians and from radians to degrees. Now let's talk about the length of an arc. Well, first of all, what is an arc? Arc is a little piece on the circumference of this circle, right? So you have the circumference, the full surrounding, and you have a little piece. Now you may have an angle that corresponds to that arc, n degrees. For example, let's say 40 degrees, or I don't know, 50 degrees. It doesn't really matter. When you want to find the length of an arc, you use this equation here. Length of the arc is going to be angle that corresponds to that arc divided by 360 degrees multiplied by 2 times pi times r. First, we need to understand what is 2 pi r. 2 pi r is actually the full circumference, or the full perimeter of that circle, right? 2 pi r. We have already seen this equation. Now again, just like with the area of a sector, we multiply the full circumference by some ratio of this angle that corresponds to that arc to 360 degrees right here. So for example, if your radius is equal to 4, and if your angle right here is, for example, 60 degrees, then you can find the length of this arc by plugging everything into the equation right here. Length of that arc is going to be 60 degrees divided by 360 degrees multiplied by 2 times pi times 4. This gives you 8 over 6 multiplied by pi, and you can further simplify this and write it down as 4 over 3 times pi. This will be the length of this arc. So keep this in mind and it will be very useful for you. Now let's solve an example. Point O is the center of both circles in the figure above. So right here we have the center, and it's the center of these two circles, the smaller and the bigger one. If the circumference of the large circle is 36, so that means circumference of this circle is equal to 36, and the radius of the small circle, so let's say radius of the small circle will be little r, is half of the radius of the large circle. Let's say the radius of the large circle is going to be big R. So they said that radius of small circle is half the radius of the large circle. That means little r is equal to big R divided by 2. What is the length of the darkened arc? So what is the length of this arc right here? Well, first of all, let's go step by step and let's find the larger radius. We know that circumference of the large circle is 36 and is also equal to 2 multiplied by pi multiplied by big R. This is the equation of a circumference of a circle. Now, by dividing everything by 2, we get 18 is equal to pi times big R. And by taking pi as approximately 3, right, we can divide both sides by pi and we will get R is equal to 18 over pi. So we said pi is almost equal to 3, so R is equal to 18 over 3, and therefore R is equal to 6. 6 is equal to R. After that, we can find the radius of the small circle by plugging this in here. So radius of the small circle is equal to 6 over 2, and that is equal to 3. Now we have found the radius of the small circle. What about its circumference? Let's think about the circumference of this small circle. We know the formula for the circumference. Circumference is equal to 2 multiplied by pi multiplied by r. So it's going to be equal to 2 times 3 times pi, which is 6 pi, right? So 6 pi is our circumference of the small circle. And pi, we said, is approximately 3. So circumference of the small circle is approximately 18. Now we need the length of the darkened arc here. We know the angle that corresponds to that arc, so it's equal to 80 degrees, and we know how to find the length of the arc. Length is equal to the degree measure of that arc divided by 360 multiplied by the circumference of that circle. That's equal to 18. So 80 divided by 360 is actually going to be 8 divided by 36. I just cancelled out these zeros. Now if you're bad with division, what you can do is you can put this 36 under 18. So we have 36 here. So length is 8 times 18 over 36. 18 over 36 is actually 1/2. So that's 0.5, 1/2. And 8 times 1/2 is equal to 4. So there you go. The length of that darkened arc right here is equal to 4. Try to do this problem again, but by yourself, and this will be a very good practice for you. We may also get some word problems about circles. What we need to do in such cases is we need to imagine the case scenario in our mind and draw it on our paper. So let's have an example here. Point X and Y are two different points on a circle. Now, before we solve this anyhow, we first need to visualize. So X and Y are 2 points on a circle, X and Y. Point M is located so that line segment XM and line segment YM have equal length. So let's say M is somewhere right here. XM and YM are going to be same. They're going to be equal, alright? So if this is 2, then this must be 2 as well, according to this problem. Which of the following could be true? Number 1, M is the center of a circle. Well, let's think about the first case scenario. Let's put a center right here. And let's think about it. If X and Y lie on the circumference of the circle, then indeed, if the center is M, then the distances XM and MY are going to be the same. They are going to be equal to radius. So this is correct. Number 2, M is on arc XY. So this is your arc XY, right? It's right here. And they said M is on that arc. Indeed, if we put M here, we can draw equidistant lines from XM and YM, and they may indeed be equal in distance. So for example, this may be 1 and this may be 1, and it's absolutely okay. It's up to you and it's up to your imagination. So this is correct. And last but not least, M is outside of the circle. Well, we already proved that we can have equidistant lines YM and XM if m is outside the circle, so this may also be correct. Therefore, the answer to question which of the following could be true is actually all of those. 1, 2, and 3, they may be true. Now try to solve this one as well, and then we will solve it together. In the figure above, the smaller circles each have a radius of 3. So we have this circle, and let's actually give them their radius. So radius is going to be 3. They're a tangent to the larger circle at points A and C. That means they touch the larger circle. When you see tangent, it doesn't necessarily imply trigonometry. It also may mean that they are just touching. Alright, so that means actually that the radius of the larger circle, let's draw it in blue, it's going to be from B to C or from B to A, right? So either this or this. And it's going to be 2 multiplied by 3 because that's going to be the diameter of the smaller circles. So the radius of the big circle is going to be 6. This whole big circle has a radius of 6. The question is asking, what is the perimeter of the shaded region? Now, also, the smaller circles touch each other at point B as well. So we are looking for the perimeter of the shaded region. So the gray region has a perimeter, and it's something like this. And we need to find the length of that perimeter. How do we do that? Well, first of all, let's simplify this problem. We have 3 circles, and each of those circles has a circumference. Here we have the circumference of the semicircle AB. Here we have the circumference of the semicircle BC. And right here we have the circumference of the semicircle AC. So by summing up all those circumferences of semicircles, we can get the length of the shaded region, or the perimeter of the shaded region right here. So first of all, let's remember the equation of a circumference of a semicircle. It's going to be equal to pi multiplied by the radius of that circle. For this smaller circle AB, circumference of this semicircle is going to be pi multiplied by 3. For the green semicircle, again, circumference is going to be pi multiplied by 3, since the radius of the green circle is also 3. And for the blue one, circumference of the semicircle is going to be pi multiplied by 6, since the radius of the blue circle is going to be 6. Therefore, by summing all of those up, we will get the perimeter of the shaded region that I'm showing with my mouse right now. Right? So there you go. This is your perimeter. And it's actually going to be equal to 12 pi. So D is the correct answer. Now let's talk about the equation of a circle, and this is an extremely important concept that connects SAT geometry to algebra. The equation of a circle looks like this. So x minus h in parentheses squared plus y minus k in parentheses squared is equal to radius squared. But what does it mean, and how did they take this equation? How did they obtain this equation? We need to first look at that. So let's say you have a circle on the xy plane, right? We have been dealing with these graphs in the past classes. Now let's say you put the center of that circle at the coordinate h, k. So this could be 2, 1, this could be 3, 4, this could be any point on the xy plane. And let's say you have another point on the circumference of the circle with the coordinates x, y. Now the horizontal distance from the center to the projection on the x-axis of that circle, that horizontal distance right here, this horizontal distance from the center to the projection on the x-axis is going to be x minus h. That's the difference between the x coordinate right here, x, minus the h coordinate, right? So this is going to be your horizontal distance. The vertical distance, the difference between point y and point k, is going to be y minus k. So this is your y minus k. And there you go. That's this segment here. The radius of that circle is the segment that passes through the center until that point on the circumference. So that's your r. Now, let's combine all of those sides of this triangle that we have obtained and put them into the Pythagorean theorem. If you don't remember what the Pythagorean theorem is, it is actually applicable for right triangles. If this is your side A and this is B and this is C, then A squared plus B squared must be equal to C squared. Well, the same goes for this triangle because it's a right triangle, right? So instead of A, we actually have x minus h. Instead of B, we have y minus k. And instead of C, we have the radius. So we can construct the Pythagorean theorem for this little triangle. X minus h squared plus y minus k squared is going to be equal to r squared. And there you go. This is exactly where the mathematicians have obtained the equation of a circle from. They obtained it using the Pythagorean theorem. Now we actually use this equation of a circle to define the circle in the xy coordinate plane. Now let's actually try and do this. Alright, so let's say x minus 1 in parentheses squared plus y plus 2 in parentheses squared is equal to 1. And there you go, you obtain your circle. Now let's actually increase the diameter or the radius. Let's say it's equal to 4. Now we are increasing the radius. Let's say it's equal to 16. There you go, radius becomes 4. Now let's say it's equal to 25. Oh, the radius became 5. So there you go, this is how you draw circles in the xy plane by using the equation of a circle. Here, the center is 1 comma negative 2. So x is equal to 1, right? And y is equal to negative 2. This is your center when I'm pointing with my cursor, and this actually is the point that is described briefly in this equation of a circle. Now this is exactly why we need this equation. We need it to be able to graph circles on an xy plane. And you actually need to memorize this equation. So let's put 3 stars right here. This equation is essential for your SAT exam because you're going to be using it a lot. And this is the general form of the equation of a circle. Now let's practice a little bit. A circle has a center at 5, 5 and a radius of 2. If the format of the equation for the circle is this, what is C? Well, we said that actually the format of equation is going to be x minus h squared plus y minus k in parentheses squared is going to be equal to r squared. Radius squared, right? So 2 squared. And let's replace this by 2. There you go. On the right hand side you are going to have 4. So C is actually 4. So the correct answer is 4. Now try to do this one. If the center of a circle is at 0, 4 and the diameter of the circle is 6, what is the equation of a circle? So 0, 4 is the coordinate of the center, and we can say that it's equal to h, k. The diameter is equal to 6, and therefore radius is equal to diameter over 2. That's 6 over 2, and that is 3. Now let's construct the equation of a circle. We know the general form x minus h in parentheses squared plus y minus k in parentheses squared is equal to radius squared. So plugging all these values right here, we have h, we have k, and we have r, we get x minus 0 squared plus y minus 4 squared is equal to 9. And by simplifying, therefore ignoring this 0, we get x squared plus y minus 4 squared is equal to 9. There you go. Second choice is the correct choice, and it represents the equation of a circle centered at 0, 4 with diameter 6. Try to do this question as well. Circle A is given by the equation x minus 4 squared plus y plus 3 squared is equal to 29. Circle A is shifted up 5 units and left by 6 units. So let's first of all think about this circle. It was first centered at h, k is equal to 4, negative 3, right? So it was first centered somewhere right here. So this is negative 3 and let's say this is 4, right? So this is our circle and it was something like this. Now the radius is going to be square root 29, so root 29. So we're told that this circle is shifted up 5 units. That means from the center we go up 1, 2, 3, 4, 5 and left by 6 units. So 1, 2, 3, 4, 5, 6. And the center comes right here. What is the coordinate? Well, negative 3 plus 5, which is 2, and 4 minus 6, which is negative 2. So the coordinate, the new coordinate h, k of that circle is going to be negative 2, 2. Now the radius of the circle is doubled. So the radius is doubled. Remember the radius was square root 29? Well, now it's double. So it's twice bigger than the blue circle. And the radius here is going to be 2 multiplied by square root 29. The question is, what is the new equation of circle A? Well, the equation of the new circle, that is this red circle, is going to be equal to x minus h squared, which is x minus minus 2, that is x plus 2 squared, plus y minus k squared, which is y minus 2 squared, equal to radius squared, so 2 root 29 squared. 2 root 29 squared. And 2 times root 29 squared is actually 2 squared times root 29 squared. Root 29 squared will give you 29 because square root and square, they cancel out, and 2 squared is actually 4. So you get 4 times 29, and this gives you 116. So there you go. This is your new equation of a circle. This is the circle that was originally of this form, but it was then shifted up by 5 units and left by 6 units, and the radius of that circle was doubled. So this is the new equation that you get. Therefore, the correct answer is the first choice. Now, on the SAT exam, we also have an important concept that is called completing the square. Well, completing the square is a very basic mathematical operation that you must know. When you get the equation of a circle not written in the original form, x minus h squared plus y minus k squared is equal to r squared, but instead you get some form like this, you need to convert it back. So let's convert it back. In order to find the radius of this circle, we need its original equation. How do we go from this to the original equation? First, we rewrite it. Then we need to leave the multiples of x squared and y squared alone. In this question, we just need to divide everything by 2 to do that. So we get x squared minus 3x plus y squared plus y is equal to 22.5. Now we need to factorize or try to factorize this hypothetically. So not really, but we need to just think about something that multiplies to give us x squared minus 3x. So we got x, and since we have negative 3, we need something that adds to give us a negative 3. So those two things must be the same. So negative 1.5 and negative 1.5. When you add these two, you're going to get negative 3. The same thing goes for y. Y and y multiply to give us y squared, and 0.5 and 0.5 add to give us 1 that is in front of that y. So I will repeat it again. We try to find what multiplies to give us x squared, and we write it in parentheses, x, and then we try to find what adds to give us negative 3, the multiple in front of x. So negative 1.5 and negative 1.5. Same thing goes for y. We try to find what multiplies to give us y squared, this is y, and we try to find what gives us 1 when we add. And those two things must be the same, so 0.5 and 0.5. Now, after doing this, we need to open those parentheses, so multiply everything. So we get x squared minus 3x plus 1.5 times 1.5. Also the same thing goes for negative 1.5 times negative 1.5 gives you 2.25. So that's this, and let's do this side now, plus y squared plus y, well we already have that, plus 0.25, that's 0.5 times 0.5. Now this all is equal to 22.5. But the thing is, in the original equation right here, we didn't have 2.25 and 0.25. So let's subtract them from this side. So minus 2.25 and minus 0.25. But instead of subtracting, we will just put this to the right hand side and this one to the right hand side as well. So by sort of subtracting, we will actually get all of that is equal to 22.5 plus 2.25 plus 0.25, and all of that summation gives us 25. So there you go. All of this is equal to 25 actually, right? So we converted from this, from all of that, into the original form. Now we can go back. We have found what SAT stole from us, right? So completing the square is actually finding what they stole from us. They stole this 2.25 and 0.25, and we brought them back by just throwing them to the other side. We said, in the original equation, we do not have 2.25, we do not have 0.25, so let's just add them as well here. Since we added them to the left hand side, we need to add them to the right hand side. So that's what we did. Now we can convert back to the original form. So we get x minus 1.5 squared, this is this, plus y plus 0.5 squared, that's this parenthesis, is equal to 25. 25, right? So that's the right hand side of the now obtained original equation of a circle. And we know that the right hand side of the equation of a circle is actually radius squared. So this is radius squared. Therefore, radius is going to be square root 25. So the radius of this circle is actually square root 25, which is 5. Now this is completing the square. So we complete this square here, it's a perfect square, and we actually complete the right hand side. So we found what was missing in the right hand side. It was 22.5, 2.25 and 0.25 were missing, so we put them back together, and so we got the radius. Now try to do this one as well, and then we will do it together by using the completing the square method. Alright, so we rewrite this. So x squared plus 20x plus y squared plus 16y is equal to negative 20. Now this does not make any sense. First of all, on the right hand side we have a negative number. Radius cannot be negative. So we need to do something with this. What we do is we complete this square. First of all, let's check. X squared and y squared have multiples of 1. Therefore, we do not need to divide by anything. We just open two parentheses now. One for x terms and one for y terms. Then we put squares and we put numbers. So what two things multiply to give x squared? That is x. What two things add to give you 20? That is 10. What two things multiply to give you y squared? That is y. And what two things add to give you 16? That is positive 8. All of that is equal to negative 20. Now what we need is we need to open those parentheses. So you can try it on your paper, but I will do it fast. X squared plus 20x plus 100 plus y squared plus 16y plus 64 is equal to negative 20. Now in the equation here we do not have 100, so they actually stole it from us, and we do not have 64, they stole it as well. But why not keep it but throw it to the other side, right? So throw it to the other side. What we get is negatives become positives, so we add them to the right hand side. Plus 100 plus 64. Negative 20 plus 100 plus 64 gives you positive 144. Now we can go back to the original equation of a circle. X plus 10 squared plus y plus 8 squared is equal to 144. There you go. This is the original form of a circle that we must have, and this is the wrong version. And we created this one, we fixed this wrong version by using the completing the square method. Alright, so the radius of that circle is going to be square root 144, which is 12. The center, h comma k, if you remember in the original formula we had negative here, so it was negative and negative here. In this one it's positive 10 and positive 8. That means h comma k will be negative 10 and negative 8. There you go. The center of this circle is equal to negative 10 and negative 8. So choice B is correct. Another very short rule that you must remember about circles, just in case for the SAT exam, is right here. So these ones you should just memorize. Number 1. Inscribed angles subtended by the same arc are equal. So you have an arc here and you have angles that are subtended by that arc. So they all have ending points right here, those triangles. Those angles will be equal. That's the first rule. The second rule, angles subtended by the diameter, right, or the semicircle, so this is the diameter, and angles subtended by it, that means angle created from two lines that actually end on this diameter, are going to be 90 degrees, so this will always be 90 degrees. And number 3, central angle is twice any inscribed angle subtended by the same arc. So if you have an arc right here, and if you have two angles looking at that arc, central angle, the angle of the center, will be twice the angle that is inscribed in that circle. There you go. This is another rule to know. So this is it for the theory about circles. If you need additional practice, then try and watch the next video. There you will find lots of useful examples on circles and circle equations that may come out on the SAT exam. But for now, take care and I'll see you in the next class. Goodbye. Welcome back to our 6th class. In this class we are going to cover exponents, imaginary number, probabilities, and percentages. These are 4 different topics and each one of those is extremely important for SAT mathematics. We're going to start with exponents, then we will continue with imaginary number. After that we will cover probabilities and percentages. And of course, we are going to solve many useful examples along the way. So let's go with exponents first. Now, what are exponents and how do you define them? First of all, any number has an exponent. For example, 7 is actually 7 raised to the first power. Now this right here is called a power, alright? So power, or in parentheses we can call it an exponent. And the number that is raised to an exponent or to a power is called a base. So this is going to be our base. Exponents can be all types of different numbers. So for example, we can have positive exponents, we can have negative exponents, we can have fractional exponents, and we can even have negative fractional exponents. Alright, so exponents can have a different look. A good knowledge of exponent rules is required on the SAT exam. You have to know how to simplify exponents, and you must understand where to use which rules for exponents. So let's cover the rules for exponents and let's get familiarized with each one of those one by one. We have a total of 8 rules for exponents: product rule, quotient rule, power of a product rule, power of a fraction rule, zero exponent, negative exponent rule, and fractional exponent rule. Let us first talk about the product rule. If you have 2 same bases, so for example 7 and 7, but if those 2 bases have different exponents, so for example 3 and 2, you can actually write it all as 7 to the power of 3 plus 2, so 7 to the power of 3 plus 2, and that is equal to 7 to the power of 5. So the product rule states that the multiplication of same bases and different exponents leaves you with the base to the power of summation of exponents. In this case, 7 to the power of 3 multiplied by 7 to the power of 2 is equal to 7 to the power of 3 plus 2. That's 7 to the power of 5. Now, quotient rule. That's about division. So if you have 2 same bases, for example 5, and if you divide them, but if those bases have exponents, let's say 7 and 4, what happens here is you can actually rewrite it as a base raised to the subtraction or the difference of those exponents or the powers. So this is going to be equal to 5 to the power of 3. Again, quotient rule states that if you have 2 same bases, like 5 and 5 on numerator and denominator, and if those bases have different exponents or different powers, then you can write this all as the base raised to the difference of powers. So 5 to the power of 7 divided by 5 to the power of 4 is equal to 5 to the power of 7 minus 4. That's 5 to the power of 3. That is equal to 5 times 5 times 5, so 125. Another very important rule is the power rule. Now, if you have an exponent in the parentheses, for example 7 to the power of 2, and if outside the parentheses you have another exponent, so that parenthesis is raised to an exponent, well, you can simply multiply this 2. So you get 7 to the power of 2 multiplied by 2. That gives you 7 to the power of 4, right? So in some cases, you just need to simplify it like this. Or in other cases, if you have, for example, 9 to the power of 3, you can write this 9 as 3 to the power of 2, right? Because 3 to the power of 2 is equal to 9. And here, you are just going to have 3. So 3 to the power of 2 is 9 to the power of 3. Well, that can also be simplified to 3 to the power of 6. So 9 to the power of 3 is actually 3 to the power of 6. There you go. This is a very good method and it's useful in simplification. Another important rule here is power of a product rule. Now when we have a multiplication of bases inside the parentheses, so let's say 7 multiplied by 4, and outside the parentheses we add a power, for example, all of this is raised to the power of 2, then we can rewrite it as separate multiplications of exponents, 7 to the power of 2 multiplied by 4 to the power of 2. And there you go. Well, that gives you 49 multiplied by 16. Now this is a bit easier to do. So this is called power of a product rule. Whenever you see a multiplication inside parentheses and you see an exponent outside the parentheses, you may simplify everything like this. Now, very important thing here is that power of a product rule doesn't work with additions or summations or subtractions inside parentheses. Let's say you have 2 minus 3 to the power of 2. Well, that in any case does not equal to 2 to the power of 2 minus 3 to the power of 2. It's not equal to that. It's actually equal to 2 minus 3 multiplied by 2 minus 3. Well, that is always the case, and you should be aware of that. So, power of a product rule only works when you have multiplication inside parentheses, so not summation and not subtraction. Power of a fraction rule. This one is also pretty important, because when you have a division inside the parentheses, right? So for example, a divided by b raised to the xth power, well, you can rewrite it as a to the x divided by b to the x. One great example of this would be 27 divided by 2 to the power of 3. Of course, you cannot divide 27 by 2 to get a whole number, so you leave it like that and you rewrite it as 27 to the power of 3 divided by 2 to the power of 3. And this is also possible in mathematics. Zero exponent rule in itself is an amazing rule, and it's applicable for any natural numbers. What it states is that any number raised to the 0th power is always going to give you 1 in return. So 25 to the 0th power, that's going to be 1. 200 to the 0th power, that's again going to be 1. So this one is very important. Please remember this. Negative exponent rule is something that you will see a lot, and it's quite important for simplification of exponents. Let's say you have 7 raised to the power of negative 3. How can you rewrite this? Well, you can rewrite it as 1 divided by 7 to the power of 3. This always works with negative exponents. And let's say you have 25 to the power of negative 6. Again, we put 1, and on the denominator we write the positive exponent, so 25 to the power of 6, right? This is your negative exponent rule. Last but not least, let's talk about fractional exponent rule, and then we will do some practice. Fractional exponent rule is extremely important in simplifying as well. Let's say you have a fraction on the exponent, so 6 over 5, right? Now, how can you rewrite all of this? Well, you first put your number inside the root. Then you're going to raise that number to the power of the numerator. So if numerator is 6, you're going to raise that to the power of 6. And outside the root, you are going to write the denominator of that fraction, so 5, right? So this is equal to that. And the same thing is actually applicable for any other fraction. Let's say you have 8 to the power of 1 over 2. Now, that can be rewritten as root 8 to the power of 1, which is just 8 root 2. And 8 root 2, well, that's just 8 square root, right? So there you go. Square root is actually a power of 1/2 or 1 over 2. Now let's combine our knowledge. So stop the video right now whenever I ask a question and try to simplify anything that I ask by yourself. Then we will solve it together. So try to simplify 15 to the power of negative 1. Well, this gives you 1 over 15 to the power of 1, which is just 1 over 15. So if this is your answer, it is correct. Now try to simplify 7 to the power of negative 3 over 4. If your answer is equal to 1 over 7 to the power of 3 over 4, Well, this is correct, but this is not the final answer. We can simplify it a little bit further. We can actually, instead of writing 7 to the power of 3 over 4, write 7 to the power of 3 in root 4, okay? So this is your final answer. This is the correct answer. Now we are ready to solve some SAT problems. So let's begin with the first one. Which of the following is equivalent to 9 to the power of 3 over 4? Try to do it by yourself. So 9 to the power of 3 over 4. Well, we can actually rewrite this, since 9 is 3 to the power of 2, we can write it as 3 to the power of 2 outside of the parentheses to the power of 3 over 4. Now we can multiply this. So we get 3 to the power of 2 times 3 over 4, which is 6 over 4. 6 over 4 can be further simplified to 3 over 2. Now, 3 to the power of 3 over 2 can be rewritten as the multiplication of equal bases, right? And different exponents. So 3 over 2 is actually 1/2. 1/2 is the summation of 0.5 and 1. So we can write it as 1 and 1/2, right? So when we multiply this, we actually add the exponents and we get 3 over 2. You can try it. So 3 to the power of 1 is actually 3. And 3 to the power of 1/2 is actually square root of 3. So there you go. All of this, so this 9 to the power of 3 over 4 is actually equal to 3 root 3. Who would have thought? But actually, using the rules that I just provided you with, you can simplify any exponent you want. Now try to do this problem, and then we will solve it together. If a to the power of b over 4 is equal to 16 for positive integers a and b, that means a must be bigger than 0 and b must be bigger than 0 since they are positive integers. What is one possible value of b? So what is one possible value of b? How can we solve this question? Well, this question has more than one solution and more than one answer, but we need to find one possible answer. What we do for that is we first rewrite it. So a to the power of b over 4 is equal to 16. Now, what is equal to 16? Well, we know that 4 to the power of 2 is equal to 16. We know that 3 to the power of 4 is equal to 16. And we also know that 16 to the power of 1 is actually equal to 16. So on this side, we can either have 16 to the power of 1, 4 to the power of 2, or 2 to the power of 4. All of that is going to equal 16. Let me go with the simplest one, with this one. I need 16 to the power of 1. So let's say a is equal to 16. And b, in order to get an exponent of 1, b has to be equal to 4. This way I will get 16 to the power of 4 over 4 is equal to 16. Well, this is just 1, and this holds true. So one possible value of b is actually 4. Well, another one of those, we would need a 2 on the exponent. So b must be 8. So b can also be 8. So that when we divide 8 by 4, we will get 2 right here. And b may also be 16. So let's say b is equal to 16. So when you plug b is equal to 16 and you divide everything by 4, you get something to the power of 4. Well, 2 to the power of 4 gives you 16. So b is equal to 16 is also correct. All of those are acceptable answers, and it just depends on which one you want to choose. Try to solve this one as well, and then we will solve it together. So the expression here, where x is larger than 1 and y is larger than 1, is equivalent to which of the following? So we need to simplify this expression. X to the power of negative 2 multiplied by y to the power of 1/2 divided by x to the power of 1/3 multiplied by y to the power of negative 1. Firstly, let's simplify all of this. X to the power of negative 2 will give you 1 over x squared. Y to the power of 1/2 will give you square root y. X to the power of 1 over 3 will give you root 3x, and y to the power of negative 1 will give you 1 over y. We have fractions in a fraction. That means we can change their places. So 1 over y becomes positive y on the numerator, and 1 over x squared becomes x squared on the denominator. So let's do it. There you go. This is how we changed everything. Since they were fractions, we can change their places. And this is your answer. So basically, this expression right here is equivalent to this, and we have obtained the solution just by using the rules that we have already learned. So choice D is correct. In the next part of the video, we're going to talk about the imaginary number. So let's talk about another very important concept for mathematics, imaginary number. Have you ever seen square root of -1? Well, mathematically, this is not possible, but mathematicians defined this number as imaginary number, which is called I. So we say I is equivalent to square root of -1, and that is called imaginary number. Why is it imaginary? Well, because it's not possible. Having a negative number inside a square root does not make any sense. But this is a useful method in mathematics, because we usually deal with such numbers. So I is equal to square root of -1. Now, we already know from the exponent rules that any number, including I raised to the 0th power, is going to be equal to 1. So I to the 0th power is 1. Now, I to the 1st power is just I. We already know that. I squared is going to be equal to root -1 multiplied by root -1. Well, multiplication of square roots cancel out, and that gives us -1. So I squared is equal to -1. Another very important one is going to be I to the power of 3. Now, I to the power of 3 is I squared multiplied by I. Well, that gives us -1 multiplied by I. That just gives us -I. So I cubed is equal to -I. Alright? And last but not least, we have I to the 4th power. That is just equivalent to I squared multiplied by I squared. And that gives us -1 multiplied by -1. Well, that is just 1. So these are the derivations of the first 4 powers of I. And these are actually pretty important. You must memorize this. So please pause this video and try to memorize the first 4 powers of I, because we will be using them a lot. Now, the reason we will be using the first 4 powers of I is actually pretty simple. What if you want to find I to the 15th power? Well, what you do here is you rewrite this as I to the power of 4 multiplied by I to the power of 4 multiplied by I to the power of 4 multiplied by I to the power of 3. Remember the exponent rules? I hope you do. We have the same base, we have different exponents, so we can just add them. 4 plus 4 plus 4 plus 3 is going to give us 15. And so I to the 15th is actually the multiplication of all of this. Now we know that I to the 4th power is already 1. We also know this one, and this one of course. And I to the 3rd power, well, we said I to the 3rd power is equal to -I. So this is going to be equal to -I. Now we're multiplying all of them. So 1 times 1 times 1 times -I. That gives us -I. So I to the 15th power is equal to -I. This is amazing. Now we can actually figure out what the I to the 15th power is. Now we know what I is. I is actually a imaginary number that is equal to square root of -1. But what about complex numbers? Complex numbers are numbers that are composed of the summation of real numbers like 3, 2, 1, -2, root 15, pi, and the imaginary number multiplied by something. So 2 multiplied by I, 7 multiplied by I, -2 multiplied by I. When you have summation of real numbers and pure imaginary numbers, you get a complex number. One example of a complex number would be -7 minus 15i, or pi plus root -16. Now, first of all, in order to simplify complex numbers, we need to know how to simplify imaginary numbers. Here we're going to simplify negative roots. So let's say you have root -25. You can rewrite this as root -1 multiplied by 25. And from properties of exponents, you can simplify this as root negative 1 multiplied by root 25, where root 25 is just 5. So that gives you 5 times root negative 1, and that is just equal to 5 times I. There you go. You can actually simplify such numbers. Let's try another one. Let's try root negative 200. So that is equal to square root negative 1 times 100 times 2. And that is equal to negative 1 in the root multiplied by root 100 multiplied by root 2. We know that root negative 1 is just I, and we know that root 100 is 10. So all of that gives you I multiplied by 10 multiplied by root 2, and that is equal to 10 root 2I. Alright, so there you go. This is the simplified version of root negative 200, and you can do it with literally any other negative root. Now, complex numbers. Let's come back to them and let's define their parts. So complex numbers have two parts, a real part and an imaginary part. Real part is the part of a complex number that has a real number. So that's this one. And the complex part, or the imaginary part, is the part that is multiplied by I. Okay, so the part that contains I, imaginary number, is called the imaginary part of a complex number. Okay, so complex numbers contain of two numbers, real numbers and imaginary numbers, and the real part is the one that contains real numbers, and the imaginary part is the one that contains imaginary number. Let's now start some practice problems. So try to solve this one by yourself. What is the sum of the complex numbers 2 plus 3i and 4 plus 8i, where I is equal to root negative 1? Well, we already know how to do that. This is a complex number summation. We can treat I like any other unknown, like x, like y, right? So in summations of complex numbers, terms with I add up together and constant terms add up together. So you got 2 plus 4 plus 8i plus 3i. And that gives you 6 plus 11i. So choice C is correct. Now let's define a complex conjugate. When you see this complex conjugate, you need to understand that a complex number can be written in a form of its complex conjugate. In order to find the complex conjugate of a complex number, you just need to change the sign of the complex term or the imaginary term. Alright, so if it's positive, it becomes a negative. Let's have an example. Let's say, find the complex conjugate of 3 plus 2i. Well, complex conjugate of 3 plus 2i is just going to be 3 minus 2i, because here we have just changed the sign of the imaginary term. So this is how you find complex conjugates, and the same rules are actually applicable, or the same rules actually work for the negative complex numbers. So the complex conjugate of the negative 2 minus 3i is actually going to be negative 2 plus 3i. So what I said is, in order to get the complex conjugate of some complex number, you just change the sign in front of the complex term or the imaginary term. And there you go, we have changed negative into positive, and this is our complex conjugate. Now let's see a practice problem here. From 17 minus I root 17, subtract its complex conjugate. How do we do that? Well, first of all, we write this term, so 17 minus I root 17. Then we need to subtract its complex conjugate. What is that? It's 17 plus I root 17. That is your complex conjugate. And of course, when we subtract, we will just change the signs. So here, we spread this negative, we get negative 17 minus I root 17. Well, positive 17 and negative 17 cancel out, and we get the summation of negative I root 17 and negative I root 17. That gives you negative 2I root 17. So the last choice is the correct one. Try to do now this problem. This is going to be very basic, but it's a good practice for you. So simplify this summation here. Well, first of all, we know how to simplify negative roots. Root negative 3 is actually going to be I multiplied by root 3. root negative 9 is going to be equal to I multiplied by root 9. So I multiplied by 3. And root negative 16 is just root 16 times root negative 1. And that gives you 4 multiplied by I. So I times 4. Now we need to add all of this here. So 4I plus 3I plus I root 3. Well, that is going to give you 7I plus I root 3. This is your final answer. And the order of summation does not really matter as long as you have the same terms. So this choice is correct. Now try to do this one by yourself, and then we will solve it together as well. So we got 9 times I to the 9th power. Well, 9 times I to the 9th is actually 9 multiplied by I to the 4th times I to the 4th times I to the 1st power. And this gives you 1 times 1 times I. So that all is equal to 9 times I. So we write it down right here, 9 times I. Now let's do the second one. 10 times I to the 10th power is equal to 10 multiplied by I to the 4th times I to the 4th times I to the 2nd power. Well, that gives you 10 times I to the 2nd power. And I to the 2nd power is negative 1. So that gives you negative 10. So we'll write it down as well. Now let's do 11I to the 11th power. So 11 times I to the 11th power is equal to 11 times I to the 4th times I to the 4th times I cubed. We know that I cubed is equal to negative I, so all of this is equal to negative 11I. So we write it down as well, negative 11I. And last but not least, I to the 12th power times 12. So 12 times I to the 12th power is equal to 12 multiplied by I to the 4th times I to the 4th times I to the 4th. And that gives you 12 multiplied by 1, which is 12. So we write it down as 12. So when you sum all of this up, 9i minus 11i, that gives you negative 2i. So we get negative 2i, and negative 10 plus 12 gives you plus 2. So your final answer is negative 2i plus 2. So this choice right here is the correct one. Try to solve this one as well, and then we're going to solve it together. So which of the following complex numbers is equal to this expression right here? Let's simplify it. Can we simplify this further? Well, 5 plus 12i is just 5 plus 12i, so we cannot simplify it further. But we can actually simplify this. We spread the negative, so negative 9i squared plus 6i. And then that is going to equal negative 9 times negative 1, because I squared is negative 1, plus 6i. That's going to give you 6i plus 9. Now we add this, that's the red term, to this, right, the blue term. So let's add them together, plus 5 plus 12i. That is going to give you 18i plus 14. So choice D contains the same summation, so choice D is correct. So practice the imaginary number and summation of complex numbers, and you will definitely be successful in imaginary numbers or complex numbers problems. But I would like to note something very important before we finish this topic. Sometimes on the SAT exam, you get multiplication of summation of complex numbers. So 2 plus 2i multiplied by, let's say, 3 minus 4i. What we do here is we multiply these terms one by one, just like we would do with x or y instead of I. So we say 2 times 3, that's going to give us 6, plus 2 times negative 4i, that's going to give you negative 8i, plus 2 times I times 3, that's going to give you plus 6i, minus 2 times I times 4 times I, so that's going to give you minus 8i squared. Now when we look at here, we actually see that we can simplify it. So let's simplify everything together. 6 minus 8i plus 6i, that's going to give us minus 2i minus 8 multiplied by I squared. Now we know that I squared is just negative 1, so we can rewrite it there. So rewrite it as -1, and that's going to give you 6 minus 2i plus 8. Well, 6 plus 8 gives you 14, and -2i stays the same. So this is your answer. This is equivalent to this multiplication right here. So be careful with the multiplication of complex numbers. This will be essential for your SAT exam. In the next video, we're going to talk about an important topic, that is probabilities. Let's talk about probabilities. Probability is an important SAT math subject, and it's actually related to your logic. The questions related to probability are very easy, but we just need to know the strategy, how to solve them. So, what is a probability first? Probability is the likelihood or the chance of something happening. For example, there may be a probability of it raining tomorrow in the place that you're living. There may be a probability that you will become a president. There may be a probability that if you put your hand in a jar with different colors of candies, you may be able to pick the yellow candy or the blue candy or the red candy. There is a probability. So, for example, what is the probability that of a total of 20 males and 13 females, a person you will point at with your closed eyes will be a male? So you have a room, and in that room you have 20 males and 13 females. You close your eyes and you point at somebody. What are the chances that the person that you point at will be a male? Well, the chances are actually 20 plus 13, which is 33, divided by how many males we have, so 20. Now, how did I get here? Well, in order to know how to construct SAT probability ratios, we need to know one very simple formula. Probability, P, is equal to what we're interested in divided by total. Here we were interested in the chance of picking a male, and we have 20 males, so we write it on the numerator. And the total of things that we can pick, so the total, is going to be 20 males and 13 females, so 20 plus 13, which gives you 33. Probability is equal to what we're interested in divided by the total. And that's a very simple equation. Now let's try to solve this problem. Read it by yourself and we will solve it together. A bag of jelly beans has 20 watermelon jelly beans, 45 sour apple jelly beans, 30 orange jelly beans, and 5 cotton candy jelly beans. How much is that in the total, first of all? 20 plus 45 plus 30 plus 5. Well, that gives you 50 plus 50, so 100. So on the numerator, we are going to have 100 if we're looking for probability. Now, the question is asking what is the probability that it will be a watermelon flavored jelly bean if you reach and grab one. So watermelon flavored. How many of those do we have? We have 20 of those. So we write it on the numerator. So the probability of picking a watermelon flavored jelly bean is going to be equal to 20 divided by 100, which is actually equal to 1 divided by 5. And that gives you the choice with 1 over 5. Now, let's actually look into more details. So we always have ratios and probabilities, like 20 divided by 33 or 1 over 5, but is it possible to have a probability that is equal to 1? Is it possible? Well, yes. If a probability is equal to 1, that means something is going to happen 100%. So, for example, if you have a bag or a jar of red jelly beans, and let's say there are 33 red jelly beans, what is the probability that you will pick a red jelly bean? Well, if we have 33 of them, the probability is going to be what we're interested in, red jelly beans, 33, divided by the total, 33. That's going to be equal to 1. The probability that you will pick a red jelly bean is going to be equal to 1. That means if our probability is 1, something will definitely happen. Alright, so the probability is 100%. Well, on SAT, they don't ask you straightforward questions like this. What they do is, they give you a table. So, probabilities are usually determined from tables. And on the table, you have two groups and two types. So each group contains a certain amount of people, and each type contains a certain amount of people. Let's say types of students. So we have males, so we have 2 males that go to school and 10 males that study online. We have a total of 12 males, so that's total. We have a total of 15 females, so here we have 15 females. Now, we have 2 males that go to school, right, and 10 males that study online. At the same time, we have 3 females that go to school and 12 females that study online. The total amount of people that go to school is actually 5, and the total amount of people that study online is, well, 10 plus 12, 22. So such tables usually contain the total of each type. So each type here has a total: go to school 5 people, study online 22 people. It has a total of groups. So how many groups do you have? 2 groups, and in each group you have, alright, so 12 males and 15 females. And an overall total is the summation of both the types, so 5 plus 22 gives you 27, and the groups, so 12 plus 15 again gives you 27. Let's say you want to find the probability if you pick a person at random. So if you close your eyes and if you point your finger at somebody from this table, what is the chance that it will be a male that goes to school? So again, male that goes to school. The chance is going to be what we're interested in. So male that goes to school. Males and go to school. Well, that's 2 divided by the total. Total is 27. The chance that you will pick a male that goes to school is 2 over 27. What about the chance of picking a female that studies online? Well, females and study online, well, that's 12. So 12 over 27. You see, probability, or the chance of something happening, can be determined by finding that ratio. And what we do is we usually draw tables like that. So draw these little sort of selections in the tables, and we select the thing that we're interested in. In our case, females that study online, so 12. And that way you can easily determine any probability. Let's have a little practice problem right here. Try to read it and solve it by yourself, then we will solve it together. So, in a survey, 607 general surgeons and orthopedic surgeons indicated their major professional activity. We have 607 total. That means denominator most probably will be 607, but we do not know yet. What we know is the results are summarized in the table above, so these are the results. Again, we have general surgeons, 414 of those, and orthopedic surgeons, 193 of those. We also have surgeons that have a major professional activity of teaching, so we have 377, and we have research, so that's 230 people. Well, the question usually starts in the last sentence. If one of the surgeons is selected at random, which of the following is closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activity is research? How many orthopedic surgeons do we have? Well, that's this much, right? 919 plus 74. And how many orthopedic surgeons that do research we have? Well, we pick this column right here and we get their cross-section, which is 74, right? So these two, they cross each other at 74. We have 74 orthopedic surgeons that do research. Now the probability is going to be out of everybody, so out of 607. And when you divide this, what you are going to get is approximately 0.122. 0.122. Well, A is the correct answer here. Alright. Now let's have another practice problem. Pause the video, try to read this, and then we will solve it together. So here we have dreams recalled during 1 week. That means the table here summarizes how many people in a certain group recalled how many dreams in a certain week. The question here is, if a person is chosen at random from those who recalled at least one dream. So at least one dream means dream is going to be bigger than or equal to 1. That's either 1 and 4 and 5, right? So we're going to be dealing with all of that for now. So if a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to group Y? How many total people do we have here that recalled at least one dream? Well, we have 28 and 57 and 11 and 68. So a total of 39 plus 125. So 39 plus 125 will be our total. But how many people in group Y have recalled at least one dream? That's 11 and 68. So we got 11 plus 68. That gives us 79 over 164. So out of all people that have at least recalled one dream, that means at least these people saw one dream that week, from group Y there were 79 people that recalled at least one dream. And from total, there were 164 people like that. So we're trying to find the probability, if we pick that person at random, what is the probability that the person will be from the groups that have at least recalled one dream, and that this person will be in group Y? Well, that's 79 over 164, and the correct choice is C. Now let's talk about either or probability. We don't only deal with one outcome. So, for example, sometimes we're not only interested in one thing, sometimes we're interested in two things at once. In this case, we're going to use either or probability. Such questions look something like this. What is the probability that you will pick either group A or group B? You will either pick a red jelly bean or a green jelly bean. What is the probability that you will either pick a male or a female? In either or probability, we're going to sum the outcomes or the probabilities. So let's have an example here. What is the probability that if a student is chosen at random from this table, it will be a male studying online or a female studying at school? So we have either a male studying online. Well, what is the probability of picking a male studying online? Out of 27, probability of picking a male studying online, well, males and study online, is going to be 10, right? So males and study online, that's 10. So we write down 10. We sum it up with the probability of picking a female studying at school. How many females studying at school are there? Well, there are 3 of those. So we are going to write 3 over 27. So the probability of picking either a male studying online or a female studying at school is 13 divided by 27. This is either or probability. You sum up 2 different probabilities and you get 1. Now try to solve this one. It's extremely easy, and I'm sure you will be able to do that. And then we will solve it together. So the table above shows the distribution of age and gender for 25 people who entered a contest. There are a total of 25 people. Now let's say 25 and 25. What is the probability that the winner will be either a female under age 40? So how many females under age 40 do we have? Under age 40 we have only 8 females here, right? So that's going to be either 8 out of 25 or a male age 40 or older. How many males age 40 or older do we have? We have 2 of those, so that's going to be 2. The probability of picking either a female under the age of 40 or a male age 40 or older is actually going to be 10 out of 25. So here, choice B is the correct choice. Now this was all you needed to know about probabilities. They're extremely easy, but only when you understand the question correctly. You should remember that the question is usually at the last sentence. So sometimes you don't even need to read the introductory sentence, right? The question lies in the last sentence. Try to use my strategy, which is shading the columns and the rows that we're interested in. So female under the age of 40, well, that's going to be the one that falls into two groups, female and under age of 40, which is 8. Male 40 years or older is going to be here, so 40 plus and males. So this is how we determine the correct value. It's going to be here, and this one as well, right? So try to use this strategy and you will definitely be able to solve probability problems on the SAT exam. In the next video, we're going to cover percentages. So have a little break and then you may start the next video. Welcome back. In this video, we're going to talk about percentages. We see percentages in our daily lives and you will see them on the SAT exam as well. So we need to get familiarized with a few equations and a few concepts. First of all, let's learn how to find x% of a number n. Let's say you want to find 30% of 700. What you need to do is you need to divide x, that is your percent, by 100 and multiply it with your n. So that is 700, for example, right? So multiplied with n. Well, that is 30 divided by 100 multiplied by 700. Zeros here cancel and zeros here cancel as well. So we got 30 times 7, which is 210. That means 30% of 700 is equal to 210. We used this little relationship here. Now let's practice a little bit. Try to solve this one. What is 21% of 900? Well, we know the equation. It is actually going to be 21 divided by 100 multiplied by 900. Zeros here and here cancel out, so we get 21 multiplied by 9. 20 multiplied by 9 is 180 and 9 multiplied by 1 is 9, so we get 189. If you're not able to perform this multiplication mentally, then you should write it down on a paper and you should try and multiply using the method that you're comfortable with. 9 times 1 is equal to 9 and 9 times 2 is just 18. So this is it. This is your answer. Try to solve this one. What is 37% of 1250? Again, we use the same method. 37 divided by 100 multiplied by 1250. Such hard percentages are going to be asked on the calculator section. So here you are allowed to use your calculator, but I can even simplify it further. So it's equal to 3.7 multiplied by 125. That is equal to 462.5. This is 37% of 1250. Now here's a little shortcut for you. If you want to find 50% of any number, then divide that number by 2. If you want to find 25% of any number, divide it by 4. If you want to find 10% of a number, divide by 10. These are shortcuts that will improve your efficiency of basic percentages. Now let's see an SAT problem. So try to read it and solve it by yourself, then we will solve it together. So the table above shows a summary of 1,200 responses to a survey question. Based on the table, how many of those surveyed get most of their medical information from either a doctor or the internet? So we have an either-or problem. That means we need to add percentages. So 63% of those who are surveyed get their medical information from doctors. So we got 63%. And we also are interested in the internet. So 13% are getting that information from the internet. When you add this, you get 76%. Now, we need to find 76% of responses, so 1,200 responses. That means we need to divide 76 by 100 and multiply it by 1,200. Zeros here cancel out, so we get 76 multiplied by 12. That gives us 912 responses. So correct answer is C. Now, of course, this is the easiest problem that they may ask you on percentages. But what else do we need to know? Well, we need to know the percent increase and percent decrease equations. The relationship between a new number and the original number can give us the equation of percent increase and the equation for percent decrease. So let's summarize those two equations. Percent increase in is equal to new number minus original number divided by original multiplied by 100. Percent decrease is going to be equal to original number minus new number divided by original number multiplied by 100. Now you should memorize those equations if you do not know how to get proportions. or deal with percent increase or decrease, because memorizing these will ensure that you know how to deal with percent increase or decrease. Now, these are amazing shortcuts, so make sure you know these two equations. Let's say you want to find the percent increase when you increase 700 to, let's say, 920. What you do is you write increase is equal to, well, new number minus old number, so 920 minus 700, divided by the old number, which is 700, all multiplied by 100. That gives you 220 divided by 700 multiplied by 100. Zeros here cancel out, so you get 220 over 7, and that gives you 31.43%. That means you need to increase 700 by 31.43% to get 920. The same thing may go for percent decrease. Let's say you want to buy a t-shirt, and the price of this t-shirt was 70 bucks, but now with the sale it's going to be 20 bucks. So you want to find out how many percent that sale or the discount is. Now, as you see here, the price decreased. That means we need to use the decrease formula. So percent decrease is going to be equal to old number minus new number divided by old number multiplied by 100. So percent decrease is equal to 70 minus 20 divided by 70 multiplied by 100, and that gives you 71%. That means this t-shirt is on a sale of 71% off. But what about if you want to go the other way around? Let's say the price of this t-shirt was 90 bucks and there is a sale for this t-shirt, minus 30%. So what is going to be your new price? Well, since this sale is going to be decrease, you write the equation. Decrease is equal to old minus new divided by old multiplied by 100. Now, old is equal to 90, so decrease is equal to 30. So we can replace everything here by what we already know. Decrease is equal to old, which is 90, minus new, which we would not know yet, divided by 90 multiplied by 100. Let's rearrange this equation. Let's multiply both sides by 90 and divide by 100. We will get 90 minus n. Let's put n to this side and all of this to the other side. New price n is going to be equal to 90 minus, well, 90 times 30 gives you 2,700 divided by 100. Well, zeros cancel out and you get 27. So the new price is 90 minus 27 bucks, which is equal to 63 bucks. Therefore, with the sale of 30%, this t-shirt is going to cost 63 bucks. This equation always works. Even if you know the shortcuts or whatnot, if you are confused, you can always use this one and it will always give you the correct answer. Now, let's see some practice problems. Try to do them by yourself by pausing the video and then we will solve them together. So, let's go with the first one. A customer's monthly water bill was 75.74 bucks. Due to a rate increase, her monthly bill is now 79.86 bucks. To the nearest tenth of a percent, by what percent did the amount of the customer's water bill increase? Well, here we're looking for the percent increase, and we know that increase is going to be equal to, well, new minus old divided by old times 100. That gives us 79.86 minus 75.74 divided by 75.74 multiplied by 100. Such questions come out on the calculator section, so you can use your calculator in order to solve this, and you will find that percent increase is equal to 5.4397%. Now we are interested in the percent increase to the nearest tenth, so this is your tenth, this is your hundredth, and this is your thousandth, and this is your 10,000th. But we're interested in the tenth. So we can erase the other decimals and we're going to get 5.4%. So choice D is correct for this question. Now try to solve this one as well, then we will solve it together. A customer paid 53 bucks for a jacket after a 6% sale tax was added. So the percent increase here is actually 6%, and that is going to be equal to, he paid for this $53. So this is the new price. We know the new price. We're interested in the old price, that is the price before the sales tax was added. Now the equation for percent increase, that is the sale tax, is going to be equal to 6 is equal to 53 bucks, which is the new price, minus old divided by old multiplied by 100. We do not know the old price, so we can solve this equation rearranging everything. Let's divide both sides by 100. 6 divided by 100 is equal to 53 minus old price divided by old price. Now multiply everything by O. So multiply this side and this side. These two cancel, so you get old price times 6 over 100 is equal to 53 minus the old price. Now bring old to the other side. You get this summation. Now instead of this, you can write 100 over 100 times old, because this essentially gives you 1. Now you can sum them up. You get 106 divided by 100 multiplied by old price is equal to 53. And finally you can rearrange this equation. So let's divide both sides by 106. Let's multiply both sides by 100. This, and this cancel out, so we can just erase them. And the old price becomes 53 times 100 divided by 106. Well, you can do it on your calculator. You will get old price is equal to $50. So this is your final answer, and therefore choice B is correct. This is it for the percentages. Thank you for watching this video, and I hope the explanations were clear and good for you. Practice percentages and all the other topics in this section by solving practice problems, and I guarantee you will be successful on the SAT exam. Take care until the next time. Hello everybody and welcome back. In this video we are going to learn everything about general graphs, interpreting graphs, polynomials, and polynomial division. So this video is going to be amazingly useful for some aspects of the SAT exam. Let's take a look at general graphs. Now, why are graphs important? Well, graphs tell us a lot about data and certain mathematical equations. Well, basically speaking, graphs are visual representations of equations and inequalities. So if you do not understand math on paper, well, you can basically visualize some equations or inequalities by plotting different types of graphs. And on the SAT, graphs come out a lot. So there are a few types of graphs that you need to know. But first, let's review the ones that we already know. We know linear graphs, we know parabolic or quadratic graphs, and we know scatter plots, but we do not know cubic graphs. Cubic graph is a graph of a cubic function, or a function of third order. F of x is equal to a times x cubed plus b times x squared plus c times x plus d, and so on. This is a cubic function, a polynomial of third order. The order of a polynomial is its highest power. In cubics, the highest power is 3. Therefore, this is a third order polynomial. Now, the cubic graphs look something like this. So, they go up, then they turn, they go down, and then they go up again. Here, they have two turning points. One right here and other one right here. So, cubic graphs may be like this, or they may even be like this, so something like this, right? These are cubic graphs. Now, what about graph of square root x? Well, do you remember the graph of a parabola? It looked something like this. Now, imagine taking 1/2 away, right? So you're left with this green portion, and imagine flipping it, all right? So flipping it. So when you flip it, you get 1/2 flipped, and it looks something like this. This is the graph of square root x. It can only be positive, therefore it does not attain any negative values, because root gives you a positive number. Also, it is becoming more and more horizontal, so first you have a slope, then that slope is decreasing, finally it's going to be almost horizontal. We also have exponential graphs, like y is equal to 2 to the power x, or y is equal to 3 to the power x, or y is equal to 20 to the power of x. Anything to xth power will have a zero asymptote. Zero asymptote. Now, what is the asymptote? Asymptote is the line that a function is not allowed to pass. So functions of xth power cannot go beneath or under the x-axis or the zero axis, and therefore we say that they have an asymptote. You may have noticed that all of them do not go below x. This is because y is equal to any number to the power of x cannot be negative, because even if you have x negative, for example y is equal to 2 to the power of negative 100, from exponent rules we know that this is equal to 1 over 2 to the 100th power. Now this is going to be a very small number, like this. But it's never going to equal 0. Well, this is not the exact value of this number, but you get the idea. It never reaches 0. It gets closer, but never reaches 0. Now, as we increase the base, so we go from 2 to 3 and from 3 to 20, you can see that the graph goes up more rapidly. Well, this is because the base is larger. That means when you square it, it gives you a larger number. When you raise it to the third power, it gives you an even larger number. But you need to remember that anything raised to x, when plotted on the xy graph, will go up very fast and very rapidly. Now, let's learn a few shortcuts for polynomial graphs. First of all, a polynomial y is equal to x to the power of n plus all the other values may have at most n many roots. What do we mean by that? Okay, let's imagine a second order polynomial. Now, let's say we have a polynomial of second order y is equal to x squared plus 2x minus 5. We already know that this is a second order polynomial because this is a quadratic equation and the highest power of x is 2. So, second order polynomial. How does it look on the xy plot? Now, the graph of this quadratic equation may look something like this. We know that this quadratic equation has two roots, so 1 and 2. Now, this is a second order polynomial and it has at most 2 roots, but it may also have 0 roots, or it may have 1 root. We know such parabolas. The idea here is this. A polynomial of nth order may have at most n many roots. Second order polynomials will have at most 2 roots. Third order polynomials will have at most 3 roots, just like the cubic equations we have drawn. Cubic equations are third order polynomials, and they have 1, 2, 3. So at most 3 roots. That is at most. That means we can have even less roots. You may have a cubic equation like this, and you can see that it only has 1 root. But you get the idea now. Now, when you see such polynomial graphs, or such curves, how can you tell what the order of this polynomial is, and how the equation can be written approximately? Well, one very good shortcut for us is that an nth order polynomial must have n-1 turning points. What is a turning point? For example, parabolas, second order polynomials. They have n-1, which is 2 minus 1, which is 1 turning point, TP. That's the point where parabola changes from going down to going up, or maybe even from going up to going down. This is the turning point of a parabola. Therefore, we say an nth order polynomial must have n-1 turning points. Now, let's look at third order polynomials. N here is equal to 3, so they have 3 minus 1, which is 2 turning points. Well, it's this one and this one. It was going like that, so up and down, now down and up. 2 turning points. Let's look at a fourth order polynomial. They must have 4 minus 1, which is 3 turning points, right? So here we have 1 turning point, second one, and third one. So turning points may be considered as peaks. A fifth order polynomial will have 4 turning points, 1, 2, 3, and 4. And let's finally look at a sixth order polynomial. 1, 2, 3, 4, and 5. So this is a necessity. Now, I think you may have also noticed the trend. Even order polynomials will have both ends facing upwards or facing downwards together. So let's look at a fourth order polynomial. Both ends here are facing upward. That's a fourth order polynomial. That's an even order. Sixth order polynomials, both of them are facing upwards. But of course, sixth order polynomials may look like this as well, right? And again, here we have both ends facing downwards. The same thing goes for parabolas, second order polynomials. 2 is an even number. Both ends are either facing downwards or both ends may be facing upwards. Now the odd order polynomials will have one end facing up and other down, or vice versa. Just like you see here, one down, the other one is facing up, or like you see here, one down, the other one up. Now, how do we understand if it's a positive or a negative odd order polynomial? So, how do we understand the coefficient of x cubed or the coefficient of x to the fifth? So, is this positive or negative? Well, let's see. A is going to be positive when one end of that odd order polynomial on the left hand side was facing down and the other one on the right hand side was facing up. These are positive. And A will be negative if on the left hand side we have the end facing up and on the right hand side we have the end facing down, so up and down. These are negative odd order polynomials. You should keep this in mind as a shortcut. Let us now talk about general graph shifts that you need to know, and this will be extremely important for the SAT. First of all, what do we mean by a graph shift? Let's suppose that we have a line that is described by the linear equation y is equal to 2x plus 1. Now, what if you want to take this exact line and shift it 2 units to the right? So this is the line that you get. You shifted this red line 2 units to the right. What you need to do to the equation in this case is you need to write y is equal to 2 in parentheses. Instead of x, we write x minus how many units we shifted to the right. So we shifted 2 units to the right, we say minus 2 plus 1. Your equation becomes y is equal to 2x minus 4 plus 1, and this is equal to y is equal to 2x minus 3. So this is your new equation. What you did is you plugged x minus how many units you shifted to the right. So x minus 2 in this case, instead of x. This is called horizontal shift to the right. Let's say you have the same exact line, but now you want to shift it to the left. So let's say you shifted it 1, 2, 3 units to the left. How do you write this equation then? Well, you say y is equal to 2 multiplied by, instead of x you write x plus how many units you shifted to the left. So plus 3, and outside you complete it, so plus 1, just like we had here. Now spread 2 everywhere, so y is equal to 2x plus 6 plus 1, and that gives you y is equal to 2x plus 7. This is the new equation. What we did to shift that line or any other curve, literally any other curve, if you want to shift it to the left, right, what you do is you add how many units you want to shift in parentheses to x. Now it's important to open parentheses. So instead of x, you write x plus how many units you shifted to the left. What if you want to take this line and what if you want to bring it down? So 1, 2, 3 units down. Well, what you need to do is you need to subtract 3 from this red equation. So y is equal to 2x plus 1 minus 3, because we shifted this line 3 units down. So this gives us y is equal to 2x minus 2. And this is the new equation. If you need to shift your curve or anything else, it can be a parabola, it can be a random graph, as long as it has an equation. If you want to shift it down, you subtract how many units you want to shift it down from that function. So this is called the vertical shift. You subtract or add. Now what happens when you add? So let's say I say y is equal to 2x plus 1, but this time plus 3. That means I need to take this line and shift it 1, 2, 3 units up. So it will give me a line like this. Y is equal to 2x plus 4. I shifted my red line 3 units up. This is why I added 3. So here's a little shortcut table. If you need to perform vertical shift, you need to add a constant to the function outside the parentheses. If your function is 2x plus 1, you have to add a constant to shift it up. So we add, for example, plus 4 is 4 units up. What if you want to bring it down? We already said we need to subtract outside the parentheses of x. So we need to subtract some value from the function. This is the function, and we subtract 3. So we go 3 units down. What if you want a horizontal shift? So you want to move your function to the left or to the right. What we do in that case is, if we want to move right, we subtract some value inside the parentheses. And if we want to move to the left, we add the value inside the parentheses. So these are our horizontal and vertical shifts. Now, the same thing can be performed on any other function. And let's give an example of a cubic function. This function is y is equal to x cubed, and you can clearly see the plot. Let's subtract a value in parentheses. So we said y is equal to x minus 1 in parentheses cubed. We shifted this function 1 unit to the right. It was like this. Now it shifted 1 unit to the right. Now let's shift it back. So we bring it back into the form y is equal to x cubed. And now let's shift it to the left. So we shifted it to the left by 1 unit by adding 1 in parentheses. Now let's go back again. Y is equal to x cubed. Now let's bring it up. So y is equal to x cubed plus 2. Outside the parentheses of x, we added 2 units. We shifted that one up by 2 units. It was like this. Now it's like this. Now let's go back. So y is equal to x cubed. And now let's go down, right? What we need to do to go down, we need to subtract x cubed minus 2. So it was like this. Now it's like this. It went 2 units down, right? We subtracted 2 out of the parentheses. And same goes for any other functions graph. This is not limited to linear and polynomial equations. This is applicable for literally any other type of graph that you can plot. Now here are some other function transformations, and you may take a look at each one of those by yourself and read them and try to memorize them. But for the SAT exam, we need the first 5. So these are the ones that we need. Now what about reflection over x-axis? Well, you just add a negative sign to the equation of your function. Let's say we had a parabola, y is equal to x squared, right? And let's say you want to reflect it over the horizontal x-axis. So you want to take this function and reflect it like this, or just flip it. What you do is, you just say y is equal to negative x squared. Now it's reflected over the horizontal x-axis. So we had this and we reflected. And the only thing we did is we added a negative. The same goes for cubic functions. We had y is equal to x cubed. Now let's reflect it. Y is equal to negative x cubed. So this is what we get. So this is extremely easy, but it's important. Now let's see a couple of questions related to graphs. Try to solve them by yourself first, and then we will solve them together. So a system of 3 equations is graphed in the xy plane above. How many solutions does this system have? Well, what is this solution of a system of equations? The solution is the point x comma y where all the lines in the system or all the curves intersect with each other. In this case, in this graph, we have one point where the linear equation with the positive slope, linear equation with the negative slope, and the parabola all cross together. This is this point. Therefore, this system of equations has one solution. That is this green point. Now try to solve this one. Then we will solve it together. The figure above shows the complete graph of the function f in the xy plane. So this is the complete graph. The function g that is not shown is defined by g of x is equal to f of x plus 6. What is the maximum value of the function g? Firstly, we need to find the maximum value of function f, and it's at 2. Right here we reach our maximum. This is the maximum value. Now g is f of x plus 6. What did we say about adding a constant to a function? We said that this is vertical shift up, but by how many units? That is by 6 units. That means this function of f is going to go 1 unit up, 2, 3, 4, 5, 6 units up. Now it began from 2 and it went 6 units up. So the maximum value here is going to be 8, because 2 plus 6 is equal to 8. So the answer to this question, the maximum value of function g is actually 6 plus 2, which is equal to 8. This is the correct answer. Now try to solve this problem, then we will solve it together. The question is asking for the value of f of 0, if this is your function f of x. Well, f of 0 is value of function at x is equal to 0. And at x is equal to 0, the value of function is right here. It's equal to 4. Therefore, D is the correct answer. Now, let's solve this one as well. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? Well, this is f of x. And the minimum value of this function is right here, right? It's 1, 2. So it's at negative 2. But what value of x does it correspond to? This point corresponds to 1, 2, 3. 3 units to the left. So x is equal to negative 3. At x is equal to negative 3, y is equal to negative 2, and that is your minimum point. So we're asked for the x value, that is equal to negative 3. So B is your correct answer. Now we are done with all types of graphs. In the next video, we're going to learn how to factor polynomials and how to do polynomial division. Welcome back. In this part of the class, we are going to learn how to factor polynomials. Now, let's think about a polynomial x cubed minus 19x plus 30. How can we factor it? That is, how can we separate it into parentheses of multiples that when we multiplied everything together, we get this polynomial? And most importantly, factoring may tell us about the zeros of that polynomial or the roots of that polynomial. So, factoring is actually extremely useful. Here we have found the roots of the polynomial, for example. From the factors we can see that making x3, negative 5, and even 2 would make this whole thing 0. So how do we factor? How to factorize a third order polynomial? Well, there is a very good shortcut. Now, we look at the last number, the constant number of the polynomial. We must ask ourselves, what are the multiples of that number? So the multiples of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6, and the negative versions of this. So we can say negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10, and negative 5 times negative 6. Well, what we need to understand is any of these values, any of these 16 values may be the zeros of this polynomial. So in order to learn which one of these is the zero, we start from the basic one, we start from the simplest one, and we increase, we go one by one, plugging each one of those in and seeing if that value will make this polynomial 0. So let's start with x is equal to 1. Let's plug it in. We get 1 minus 19 plus 30. Well, that gives us 12, and that does not equal 0. Therefore, x is equal to 1 goes away. This cannot be the factor. This cannot be a 0. Now let's try x is equal to 2. So write x is equal to 2 and plug it in this polynomial. We got 2 cubed, which is 2 times 2 times 2, which is 8, minus 19 times 2, which is 38, so minus 38 plus 30. Well, what does that give us? That gives us 0. So we got 0. That means x is equal to 2 is 1, 0. Therefore, one of the factors would be the parenthesis x minus 2. This is our factor, and it's very important to know this. Now what we want to do is we want to go with the simple terms again. So let's pick 3 this time. X is equal to 3. Now 3 cubed is 27. Minus 19 times 3, this is minus 57. And plus 30, well, all of this gives us 0 in fact. So 3 is also a 0. Therefore, x minus 3 is a factor as well. It's a factor because this parenthesis, when you plug x is equal to 3, will make all of this go to 0. Now, we have already found 2 factors. You can do this in your head because it would lead to a faster solution, or you can do this procedure on your calculator. But usually we start with the smallest numbers because they're the easiest ones, and that takes less time. So we found 2 factors, x minus 2 and x minus 3. Now we already know that x plus 5 is also a factor. So if you have plugged x is equal to negative 5 in here, and if you try to solve this, so let's plug x is equal to negative 5, we get x cubed as 5 times 5 times 5, negative, that gives us negative 125, minus 19x, which is minus 19 times minus 5, which is plus 19 times 5, plus 30. Well, this gives us negative 125. 19 times 5 gives us 95. And when we add 30 here, we get a 0. All of this summation is equal to 0. So, x is equal to negative 5 is another 0. That's why we say x plus 5 is a factor, right? So it's a factor because when you plug in x is equal to negative 5 in this parenthesis, you will get a 0. So when you multiply all of these factors with each other, you will get this polynomial. So this is a basic shortcut. When you need to find one factor or 2 factors of a polynomial of higher order, like 3rd order or 4th order or 5th order, just look at the last constant. Then separate it into its multiples and try to plug each multiple into that polynomial in order to get your factors. Indeed, when we plug in our polynomial into a graphing calculator, we will see that at negative 5, 2, and 3 we get zeros. But what do we need for the SAT? Well, we need only to know how to factor once, and we already know how to do that. We just look at the last term and we just separate it into its multiples. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Usually, the hardest problems on SAT would ask you to find only one factor. But what if the factor is given? What if a polynomial is already factorized like this? There may be some questions that involve polynomials that are already factorized or that already have their roots written out. For example, in the equation above, a, b, c, and d are constants. If the equation has roots negative 1, negative 3, and 5, which of the following is a factor of this equation, this polynomial? Well, we know that these are the roots. That's why the factorized parentheses will look like this: x plus 1, x plus 3, and x minus 5. Because plugging in these values will make each one of those 0. Therefore, we can see here that x plus 1 is one of the factors of this polynomial. So B is the correct choice. Know how to factorize polynomials and remember why it is important. This way, you will be able to solve any factorization problem on the SAT. Now let's come to polynomial division. Just like we divide numbers, for example, 70 divided by 7, and we get 10. So we multiply 10 by 7 and we get 70, then we subtract and the remainder is 0. So 70 divided by 7 is 10. Just like we do this with simple numbers or natural numbers, we can do the same thing with polynomials. We can do the same thing with equations. We can do the same thing with expressions in mathematics. So it turns out that we can actually divide polynomials like this. And this is called polynomial division. Now, what allows us to do this? And when can we do this? Before proceeding to the procedure, before learning how to do this, we need to understand when we can do this. When are we allowed to actually do this? So we can divide a polynomial by some other polynomial of lower order, just like we divide large numbers by numbers of the same order. So what is the order of 70 in that example? Well, 70 is actually 70 multiplied by x to the 0th power. Well, this gives you 1 and you get 70. And you can divide it by 7. Well, 7 is actually 7 times x to the 0th power. This gives you 1 as well. So you here on the numerator and denominator actually have a polynomial of 0th order. 0th order polynomials are numbers. So we have been dividing polynomials all of our life, but we never knew this. Now we can divide polynomials in another way. Let's say 70x divided by 7. Well, this may give you 10x. Now here you have a 0th order polynomial, and here you have a 1st order polynomial, x to the power of 1, but you just do not see that 1. So you are comfortably able to divide this and get 10x. But what if, instead of this, I had 60 divided by 10x? Can you divide this? Well, of course, we cannot. Well, if you want, you can, but this will give you 6 divided by x, which is not really an answer. Or it's a fractional answer, and this is something that we do not want on the SAT. So on the SAT, we will get problems where the order of the numerator, that means the order of this expression right here, so 4th order, will be larger than the order of the denominator. Well, the order of the denominator here is 3rd order. 4th order is larger than 3rd order. That means the largest power of x on the numerator will be much larger than the power of x on the denominator. Alright, and this allows us to divide everything very comfortably. Now, let me give you an example in order to demonstrate how to divide polynomials. Let's say you get a problem like this on the SAT. The first thing you want to do is you want to bring it to the form you're comfortable dividing with. So I am comfortable doing the long division in this form. I write my number or the polynomial that I will divide on the left side. Then I sort of separate it with what I will divide it by. So let's say x plus 1. Now what we want to do in order to be able to divide this is we want to ask ourselves, what do we multiply x by in order to get 5x squared? I will repeat myself again. What do we need to multiply x by to get 5x squared? Well, we need to multiply x by 5x in order to get 5x squared. So we write it down and we multiply. 5x multiplied by x gives you 5x squared. 5x times 1, well, that gives you positive 5x. What we need to do now is we need to write a subtraction. Subtract the terms that are similar. So 5x squared minus 5x squared gives us 0. And negative 2x minus 5x, well, we have a minus here, don't forget, so negative 2x minus 5x gives us negative 7x. And this one, it just comes down as it is. We have a new polynomial, and we need to ask ourselves, what do we need to multiply x by to get negative 7x? Well, we write negative 7. Now we multiply. Negative 7 times x gives us negative 7x, and negative 7 times 1 gives us negative 7. Now we need to subtract everything again. So minus 7x minus 7x, all of that gives us 0. And 1 minus 7 gives us positive 8. Wow, now we have subtracted and we have divided and we have obtained a number. The number is 8. We have obtained 8. Can we divide 8 by a polynomial? Well, we cannot divide or sort of simplify any further. That's why we leave it at this point. We write the answer like this. We first write down what we have found, what we have obtained. so 5x minus 7. Then we sum it up with the remainder, so this is called the remainder because it remains when we divide everything. So we sum our expression with remainder, which is 8, divided by the divider, which is x plus 1, right? This is your answer. This is exactly what all of this is equal to. 5x squared minus 2x plus 1 divided by x plus 1 is equal to 5x minus 7 plus 8 over x plus 1. Why did we write it like this? Well, this is just to say that we cannot divide this by this anymore. We cannot divide 8 by x plus 1 anymore, so we just leave it like that. But this is the simplified version of this expression. And this is how we divide polynomials. Now let me show you another example. Which of the following is equivalent to this expression? Well, you see polynomial division here. That's why you write it down like you learned. So we got 10y squared plus 15y divided by 10y plus 5. We ask ourselves, what multiplies with 10y to give 10y squared? Well, that is y. Then we multiply y times 10y is equal to 10y squared, and y times 5 gives you positive 5y. Then we subtract everything, right? But we subtract in parentheses, so the upper term minus the lower expression. And what we get is 10y squared minus 10y squared, which is 0, and 15y minus 5y, which gives us 10y. Now we continue. We ask ourselves, what multiplies with 10y to give us 10y? Well, that is just 1. So we add it here. We multiply 10y times 1 is equal to 10y. And 1 times 5 gives you positive 5. Now we subtract. So 10y minus 10y gives you 0. And invisible 0. Here we have invisible 0. So invisible 0 minus 5 gives us negative 5. Alright, don't forget about this invisible term. If you don't have anything of a constant, or if you don't have anything that you can subtract from, you just subtract from 0. So 0 minus 5 gives us negative 5. Now, how can we rewrite this? Well, we rewrite it as the answer plus remainder divided by the divider, so 10y plus 5. And since this is negative, well, we can just rewrite it here. So we can write it like this. And this is our answer. This is the most simplified form of this division. Now, which choice contains the answer? Choice A contains the correct answer. So try to do this problem, then we will solve it together. It says, which of the following is equivalent to this division? Well, you already know what to do. Write it in the form you're comfortable dividing with. My method is this. Then ask yourself, what multiplies with 4x to give 4x squared? Well, that is just x. X times 4x gives 4x squared. X times 2 gives 2x. Now we need to subtract everything. So 4x squared minus 4x squared gives 0. 6x minus 2x gives us positive 4x. What multiplies with 4x to give us 4x? Well, that is just 1. 1 times 4x is 4x. 1 times 2, positive 2. Now we subtract everything, and we get negative 2, right? Then we write this in the form that we learned. So we say x plus 1 plus the remainder divided by the divider, so 4x plus 2. And the correct choice is D. Try to go over this procedure, and you must learn it because it will be very useful in the SAT. Now try to solve this example as well, then we will solve it together. So which of the following expressions is equivalent to this division? Again, what we do is we write this division in the long division form that we are comfortable working with. I am comfortable working with this one. Then we ask ourselves, what multiplies with x to give x squared? Well, that is x. X times x is x squared. X times negative 3 is negative 3x. Then we subtract everything in parentheses. So we write this subtraction. X squared minus x squared gives us 0. Negative 2x minus minus 3x gives us x. And negative 5 just comes down as negative 5. Alright, because we didn't subtract it from anything. Then we ask ourselves again, What multiplies with x to give us x minus 5? Well, that is just 1. So we multiply 1 times x is equal to x, 1 times negative 3 gives us negative 3, and we subtract everything in parentheses. X minus x gives us 0. Minus 5 minus minus 3 is actually equal to minus 5 plus 3, which is minus 2. Now we can write this in the correct form. So this is equal to x plus 1 minus 2 over x minus 3. So remainder divided by the divider. And the choice D turns out to be the correct choice. So this is it for the polynomial division. It's quite important to know this, and it's actually quite easy. But now I want to show you something amazing. The reason we learn polynomial division is not only to be able to simplify expressions like this, but to actually find the other factors of polynomials. Let's go back to our question, and let's assume that we only know one factor of this. So let's say you only know one factor, and that is this. Now, what we can do to find the other two factors is we can divide this polynomial by this factor. Well, let's write it in the form that we're used to. X cubed minus 19x plus 30 divided by x minus 2. Well, what we need to multiply x by to give x cubed is x squared, and then we multiply. We get x cubed minus 2x squared. Now we subtract everything in parentheses. X cubed minus x cubed gives us 0. And 0 minus 2x squared, because we do not have x squared terms right here, well, we get 2x squared. And then we put everything down. Minus 19x plus 30. We just brought them down because we didn't have anything to subtract from them. Now we ask ourselves, what do we need to multiply x by in order to get 2x squared? Well, that is 2x. And then we multiply. So 2x squared minus 4x. Then we subtract. When we subtract everything in parentheses, we will get minus 15x plus 30. Then we ask ourselves, what do we need to multiply x by in order to get negative 15x? And that is just negative 15. So we multiply negative 15 times x gives us negative 15x. Negative 15 times negative 2 gives us positive 30. And we subtract this expression from this and we get 0. Okay, so we found the answer to this division. Now, we can write this polynomial right here, as the multiplication of what we found and this. So this polynomial is actually equal to one of its factors times what we found by division. Now, let's factorize this. This is a quadratic equation and we already know how to factorize it. So we bring this down first of all, x minus 2, and we factorize this into two parentheses. What multiplies to give us x squared? Well, we have x and x. Now, what multiplies to give us negative 15 and adds to give us 2? Well, that is negative 3 and positive 5. When you sum them up, you get 2, and when you multiply them, you get negative 15. So you have just found all of the three factors of this polynomial. We found the first one by using this constant right here. Then we divided this polynomial by that factor. We found x squared plus 2x minus 15. Then we factorized it because we know how to factorize quadratic equations already. So this is exactly what we have found before. It is precisely the correct factorization. So you can also use the method of division to find the other factors. It's not very important for the SAT, but it's a good addition to your mathematics knowledge. So we're done with factorization and polynomial division. Now let's talk about a very easy but important concept on the SAT, the absolute value. So the sign x inside two dashes like this makes any number x in it positive. What do I mean by this? Well, when you write absolute value of negative 3, you actually get 3. So these two things right here, those two, when you put a number in them, you get the positive of that number. Now let's give another example. Absolute value of negative 250 is 250. It returns you the positive one. So if x is equal to negative 3, then absolute value of x will actually be absolute value of negative 3, which is 3, positive 3. Absolute value makes any number in it positive. You need to remember this. Now what about the graph of the absolute value? Let's say y is equal to absolute value of x. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2. When x is equal to 3, y is equal to 3. So we can connect these dots and we get something like this on the right side. Now what about the left side? Well, when x is equal to negative 1, y is equal to 1. So we have this. When x is equal to negative 2, well, negative 2 in the absolute value gives you 2. So again, we have positive 2. When x is equal to negative 3, you get y is equal to 3. And now we can surely connect these dots and we will get something like this. So this is the graph of the absolute value. We can apply graph transformations that we have learned. So take this graph and put it to the right or put it to the left or put it up or put it down, but we will still get a V shape. So when you get a V shape or a graph shaped as letter V, then you need to understand that you're dealing with the absolute value. You're dealing with absolute value of x or something related to it, like absolute value of x minus 3. Okay, so this is this orange graph. Now, what type of questions come out on absolute value on the SAT? Well, questions that are related to your ability to use your logic. For example, for what values of n is absolute value n minus 1 plus 1 equal to 0? Well, let's think about it. Absolute value of n minus 1 plus 1 is equal to 0. We can rearrange by throwing this 1 to the other side. Absolute value of n minus 1 is equal to negative 1. We already said that absolute value returns you positive numbers, so you cannot plug anything into an absolute value and get a negative value in return. Therefore, there is no such value of n, right? So here we need to only know the fact that anything in the absolute value returns you the positive version of that number. Therefore, there is no such value of n that can be plugged into an absolute value and return you a negative number. Now let's see another problem. Try to solve this and then we will solve it together. Two different points on a number line are both 3 units from the point with coordinate negative 4. So let's draw a number line. So here we have negative 4, here we have negative 3, here we have negative 2, negative 1, and 0. And here we have negative 5, negative 6, and negative 7. And we're talking about 2 points that are 3 units away. So 1, 2, 3. This is either this point or 1, 2, 3, this point. Now we're talking about negative 7 and negative 1. So the question remains, which of the following equations, when you plug negative 7 and negative 1, satisfy your condition? Well, you're dealing with x is equal to negative 7 and x is equal to negative 1. So, which of these equations is satisfied when you plug in negative 7 and negative 1? Let's find out. Plug in negative 7 into the first equation. You get absolute value of negative 7 plus 4, and that gives you 3, right? That indeed gives you 3 because the inside of the absolute value is negative 3 in absolute value. That gives you 3. Now let's plug in x is equal to negative 1. Negative 1 plus 4. That gives us absolute value of 3, and that is equal to 3 as well. Therefore, the first equation can satisfy both points. It is applicable for both points, because when you plug these values in here, you get 3 for both points. Therefore, choice A is the correct choice. Be careful with such questions, because first you will need to understand what points you're dealing with. In this case, we were dealing with negative 7 and negative 1. Then plug them in and use the definition of the absolute value, operation that makes any negative number positive, to help you determine the correct answer. Thank you for watching this video. I hope everything was clear. You can practice by solving the examples attached to this page and therefore strengthen your knowledge and ability to solve such problems. Take care, and I will see you in the next class. Hello and welcome back. In this class we're going to learn how to solve word problems, and we're going to talk about schematics of word problems. You may have noticed that SAT contains long word problems, and it also contains short word problems that are quite confusing. So the long word problems will be the ones that contain lots of words and lots of sentences but little numbers, like this. And the short word problems will be the ones that contain numbers and probably some mathematical operations, and they require you to build a mathematical relationship, like equations or logical judgment. Most importantly, in short word problems with numbers, you should convert words to mathematics. And in long word problems, you should underline the important words. So this will be your main shortcuts. In this part of this class, we're going to talk about the short word problems, but in the next video, we're going to look at the long word problems. We will see each type and how to handle that type, and we're also going to solve lots of examples along the way. Before we begin looking at short word problems, let's look at some shortcuts. There are some shortcuts that help us to convert words into mathematical relationships and mathematical operations like multiplication, division, addition, and subtraction. Twice, 3 times, 4 times, or n times larger means we need to multiply by n. And they may also present it in this way: n times bigger, n times more expensive. So for example, Kazakhstan is 3 times larger than Turkey. What does that mean? Well, that means k is equal to 3 multiplied by t. Kazakhstan, which is k, is equal to 3 multiplied by Turkey. So for example, if Turkey is like 100 kilometers squared, just to give you a rough example, then Kazakhstan is going to be 3 times that. So Kazakhstan is going to be 300 kilometers squared. Alright, so this is how you convert word problems related to n times larger. Now what about twice, 3, or 4 times smaller? So n times smaller or n times less. Well, this means we need to divide by n. We need to perform division on the right hand side of the equation. Some other examples would include cheaper, shorter, or slower. So for example, Coca-Cola is 3 times cheaper than Pepsi. So on the left hand side we have Coca-Cola, and it is equal to Pepsi divided by 3. We always do the division on the right hand side. Division is related to the last variable or the last word. Now if we say that Pepsi is $3, then we can replace P by 3 and we get Coca-Cola is equal to $1. So this is where division comes in handy in word problems. Now when we talk about n more or n less, we actually talk about summation or subtraction. N more means we need to add n. For example, John has $50 more than Kevin, so J is equal to 50 plus K. Or subtraction, a train ticket, so T, costs $80 less than a plane ticket, so P minus 80. Notice, we do the operation on the right hand side all the time. We do it on the right hand side. This was the case for every single problem. So when you convert words into mathematical relationships, be careful about that relationship. Try to plug in some values to make sure that you are doing the correct thing. For example, if Kevin has $30, then John would have 50 plus 30, which is $80. It makes John have 50 more bucks than Kevin. Now let's talk about strategies for short word problems in SAT mathematics. For short problems, use the RCS technique. Now, what is RCS technique? We have never heard of this before. Well, I came up with this technique to make it easier for my students to solve word problems. And RCS technique works for every single student. When we open this abbreviation, we get read, convert, and solve. So you should first read the question. Read the question carefully and efficiently. Concentrate and take it at one time. So you must understand it by reading only once. Otherwise, you will be wasting time. Convert. Convert the words into mathematics or geometry and equations. So instead of saying John has $50 more than Kevin, we say J is equal to 50 plus K. We convert the words into mathematics or into mathematical equations, or in fact into geometry if it's a geometry problem. Then we solve. So we solve our relationship that we have just created. We solve our equation and we find what we are looking for. So please remember, read, then convert, and after converting, solve. This works on all word problems. Now let's see some problems. Try to solve this one by yourself, then we will solve it together. At a restaurant, n cups of tea are made by adding tea bags to hot water. So n is equal to cups of tea, and t is equal to tea bags. Now these are the abbreviations that we're going to use. If t is equal to n plus 2, so we already have a relationship. T, the tea bags, is equal to cups of tea plus 2. How many additional tea bags are needed to make each additional cup of tea? So how many more tea bags we need to make one more cup of tea? Well, let's see. What if I had to make 1 cup of tea? So n is equal to 1. If n is equal to 1, then I have tea bags is equal to 1 plus 2, which is 3. What if I want to make additional cup of tea? An additional one. So I need to have another cup of tea. That's plus 1. I get n is equal to 2. Alright, so for n is equal to 2, now t, the tea bags, is going to be n, which is 2 plus 2, which is 4. So for 1 additional cup of tea, I need 1 additional tea bag. This is what we have obtained using a converted relationship. We convert this expression, this wordly expression, into a mathematical relationship. So from n is equal to 1, where I had 1 cup of tea, I got 2 cup of teas. That's additional cup of tea. And an additional cup of tea requires an additional tea bag. Therefore, we need 1 tea bag to make each additional cup of tea. The correct answer is B. Now try to solve this problem, then we will solve it together. So Maria plans to rent a boat, and the boat rental costs $60 per hour. Let's say we want to find the relationship for the price, the boat rental price. It is going to be $60 per hour, so $60. And if I want to make this price hourly, that is how much money I need to pay for each additional hour, I need to multiply 60 by hour, right? So how many hours I will be renting this boat for. And she will also have to pay for a water safety course that costs $10. So this is an additional $10 for Maria. Now, if Maria wants to rent the boat for 2 hours, the price will be 60 times 2 plus 10. It will be $130 because she has to pay for that water safety course, and it costs $10, and she has to pay an hourly fee. Each hour she pays $60 per hour. So we have found our main relationship. We have converted second sentence into an equation. Now let's read. Maria wants to spend no more than $280 for the rental and the course. That means her budget is $280, and she does not want to spend more than that. So this should be larger than or equal to 60 times h plus 10. If the boat rental is available only for a whole number of hours, well, that means either 2 hours or 3 hours or 4 hours. What is the maximum number of hours for which Maria can rent a boat? Well, we already know whole number of hours means either 1 or 2 or 3 or 4, 5, 6, 7, whatever. It should be a whole number, not a decimal. Now, Maria only has $280. So we can rearrange this equation by subtracting 10 from both sides. We will get 270 is larger than or equal to 60 multiplied by the amount of hours. We can also divide both sides by 60. So these ones cancel out, and we get 270 divided by 60 is larger than or equal to the amount of hours. Now divide 270 by 60, and you will get 4.5. So the amount of hours may not exceed 4.5 hours. That means the maximum amount of time Maria can rent this boat for, considering her budget, is 4.5 hours. So the whole number of hours she can rent this boat for is 4. This is the maximum whole number of hours that she can rent her boat for. So 4 hours is our correct answer. In some problems, you're in fact responsible from constructing inequalities. If you forgot how to construct inequalities, go to lesson number 2 and repeat the relationships. Now let's see a conversion problem. So try to read it and solve it by yourself, then we will solve it together. So to make a bakery's signature chocolate muffins, a baker needs 2.5 ounces of chocolate for each muffin. So one muffin requires 2.5 ounces of chocolate. Now how many pounds of chocolate are needed to make 48 signature chocolate muffins? We need to make 48 of those. So we multiply both sides by 48. 48 muffins will require 48 multiplied by 2.5 ounces of chocolate. Now multiply 48 by 2.5 with your calculator and you will get 120 ounces. So in order to make 48 muffins we need 120 ounces of chocolate. But we are required to find how many pounds of chocolate we need. But we already know how many ounces we need. And 1 pound is equal to 16 ounces. So let's write this relationship down mathematically. So 1 pound is equal to 16 ounces. And how many pounds is 120 ounces? Well, we can divide 120 by 16. So 120 ounces by 16 ounces and we will get 7.5 pounds. This is the relationship that they have provided us on the SAT. So if you do not know how to convert from pounds to ounces, they told you that 1 pound is equal to 16 ounces. You divide 120 ounces by 16 ounces and you get how many pounds you need to make 48 signature chocolate muffins. So the correct answer is A. Let's see another conversion problem. Try to solve this one by yourself, then we will solve it together. Horsepower and watts are units of measure of power. They are directly proportional, such that 5 horsepower is equal to 3,730 watts. So let's convert this. 5 horsepower is equal to 3,730 watts. Right from here, we can build a relationship. We can divide everything by 5, and we get that 1 horsepower is equal to 746 watts. Now the question is, how much power in watts is equal to 2 horsepower? Well, to be able to find this, we need to multiply both sides of this equation that we have obtained by 2, because 2 horsepowers will be equal to 2 times 746 watts. So let's do that. 2 horsepower is equal to 746 watts multiplied by 2, and that gives you 1492 watts. This is a simple conversion problem, but at the same time you need to write down the equations correctly in order to convert correctly. Now let's see this problem. Try to solve it by yourself, then we will solve it together. So the score on a trivia game is obtained by subtracting the number of incorrect answers from twice the number of correct answers. Well, we need to convert this before we go any further. So the score S is equal to 2 multiplied by the correct answers minus incorrect answers. So score is equal to 2 times correct answers minus incorrect answers. This is exactly what the relationship is in this sentence. Now, if a player answered 40 questions and obtained a score of 50, how many questions did the player answer correctly? So the player here answered 40 questions. Now, incorrect plus correct must be equal to 40 questions, because overall he answered 40 of them, and some of them may be incorrect and some of them may be correct. This player obtained a score of 50, so his score S is 50, right? And we equate it. The question is, how many questions did the player answer correctly? Well, we need to find what is C in this system of equations. Now we've constructed two equations and we have two unknowns, the amount of incorrect answers and the amount of correct answers. What we need to do in some cases with word problems is we need to solve the system of linear equations, and we already know what to do. We can leave C alone by using the substitution method. Bring this C to the other side, so I is equal to 40 minus C. Now we can take this I right here and we can plug it in our first equation instead of I. So 2 multiplied by C minus 40 minus C is equal to 50. This is the relationship that we get. From here, we can solve for C. 50 is equal to 2 times C minus 40 plus C. 50 is equal to 3C minus 40. Bring 40 to the other side, and finally 90 is equal to 3C. By dividing both sides by 3, we get C is equal to 30. So there were 30 correct answers, alright? And this is what we have got using the system of linear equations. Now let's check it again. We already know that score is equal to 2 times C minus I. 2 times correct answers minus incorrect answers. We know that the player answered 40 questions. So incorrect choices plus correct choices of that player would sum up to give us 40. Now we can replace the score by 50 because we know that player scored 50 points. Let's check. Plug in 30 instead of C. I plus 30 is equal to 40. And this leaves us with I is equal to 10. So the amount of incorrect questions answered is 10. Now let's try and satisfy this. If this equation right here is satisfied, then we solved everything correctly. So instead of C, plug in 30. And instead of I, plug 10. Now 50 is equal to 2 times 30 minus 10. 50 is equal to 60 minus 10. 50 is equal to 50. Well, this is correct. The initial equation is satisfied, and that means our answers are correct. So the number of questions that the player answered correctly is 30 questions. As you may already have noticed, all along I have been using the read, convert, solve technique. So when you come across short word problems on the SAT math, make sure you read everything correctly. So read the question carefully and try to read it only once. Convert all of the verbal relationships into mathematical relationships or geometric relationships, and solve the question or solve the equation or solve the relationship that you have obtained. In our case, we have been obtaining equations and systems of linear equations. You may also obtain a quadratic equation, equation of a circle, or a polynomial equation. Make sure that you're solving everything correctly, and you will be good to go. In the next part of this class, we're going to cover a few good strategies to solve long word problems on the SAT. So give yourself a little break, try to go over the problems that we have solved, and then continue watching the next part of this video. Welcome back. In this part of the class, we're going to talk about the long word problems. Now, long text word problems are created to measure your ability to understand a given situation. The idea is this: the answer to such problems is always in the text, but you should just read the text very carefully. And the strategy goes like this. So read the question, that is the last sentence. Now read the text and underline important words and numbers, and then read the answers and see which ones do not make any sense. So let's see the problems. Problem number 1. Now let me show you how to solve such problems, and then you will have time to practice. So a study was done on the weights of different types of fish in a pond. A random sample of fish were caught and marked in order to ensure that none were weighted more than once. The sample contained 150 largemouth bass, of which 30% weighted more than 2 pounds. Now the question starts right here. which of the following conclusions is best supported by the sample data. Now, in such questions, in 99% of the cases, the question is in the last sentence. This portion of the text is usually a research or a study, and you need to judge this. You need to be able to understand exactly what is going on in here and then choose the answer choice that agrees with the idea in the text right here. So there is a study going on the weights of fish in a pond, and a random sample of fish, which are largemouth bass, were caught and weighted. The sample of this fish contained 150 fish, and it turns out that 30% of largemouth bass weighted more than 2 pounds. When we read the answer choices, we will find 3 irrelevant answer choices that somehow contradict the information in the text, and one of the answers will be correct. It will agree with the text. So let's read. A. The majority of all fish in the pond weighed less than 2 pounds. Now when we read this, it talks about all fish in the pond. However, in the pond, we took only 150 largemouth bass, right? So there are all other types of fish, and it's stated right here. There are different types of fish in a pond, but we only took the largemouth bass type of fish, and we only based our experiment on that type of fish. So we cannot base the results from one type of fish on all fish. Therefore, this goes away. Let's read choice B. The average weight of all fish in the pond is approximately 2 pounds. Again, the choice is talking about something irrelevant. The experiment was done on one type of fish. This choice contains all fish. So this goes away as well. Now let's read C. Approximately 30% of all fish in the pond. Again, so you see a pattern here. The information is obviously wrong in choice C because it again talks about all fish, but the study was done on largemouth bass fish. So this goes away as well. And D. Approximately 30% of all largemouth bass, right, in the pond weighted more than 2 pounds. Well, this is exactly what they said here. The sample contained 150 largemouth bass, of which 30% weighted more than 2 pounds. We can base our assumption on 150 of those fish because 150 is a sufficient number. It can give us a percentage. As long as you're dealing with above 100 units of something, then you can base sort of the percentage on that. Approximately 30% of all fish in that pond weighed more than 2 pounds. So choice D contains the correct information that is extracted from this text. Now, the difficulty of these questions actually varies, so it changes. Some of them are easy, the others are hard. So we need to know how to succeed in solving such questions. The first strategy is to eliminate suspicious choices. Just like we did, you should also eliminate the choices that look suspicious or wrong to you. You should always compare the choices to the text. The second strategy is to trust the text. The answer is always in here, and you will see that in majority of problems related to long texts and logical reasoning, the answer lies within the text. The third strategy is to look for the paraphrased answers. Now, what does paraphrased mean? Paraphrased is a sentence that is different from a sentence of the same meaning by the words. So the words are different, but two sentences mean roughly the same thing. So in this example, we had one sentence that stated the sample contained 150 largemouth bass, of which 30% weighted more than 2 pounds. And it turns out that choice D, approximately 30% of all largemouth bass in the pond weighted more than 2 pounds. This choice, this sentence, is the paraphrased version of this sentence in the text. Essentially, they are the same because the idea behind those two is the same, but the style of the text is different. And the fourth idea is that wrong choices are very easy to spot. You should be very doubtful when you're dealing with long word problems. We eliminate choices that are wrong because they have some incorrect statements in them. So you should be very, very careful about those statements. After eliminating 3 wrong choices, you will be sure that you have picked the right answer. Now let's see an example. Try to solve this by yourself, and then we will solve it together. The members of a city council wanted to assess the opinions of all city residents. So let's underline. We're talking about the assessment of the opinion of all city residents about converting an open field into a dog park. So now they want to convert an open field, an area, to a dog park. What they do afterwards is the council surveyed a sample of 500 city residents who own dogs. Now, they survey 500 people who have dogs in their houses. The survey showed that the majority of those sampled were in favor of the dog park. So people that they asked, 500 city residents who owned dogs, were in favor with the dog park. That means they were okay with it. They wanted the city council to build a dog park in that area. The question is, which of the following is true about the city council survey? So what is true about this whole survey? Well, A, it shows that the majority of city residents are in favor of dog park. Now let's think, why could this be wrong? First of all, what is majority in this case? This city may have 2 million citizens, or it may have 100 million citizens, but we are basing our assumption only on 500 city residents. So can we say that majority of city residents are in favor of the dog park in this case? Of course we cannot say that. We can say that 500 city residents who own dogs are in favor of a dog park. So there you go, this is wrong. Let's read B. The survey sample should have included more residents who are dog owners. Wait a second. We tried to make a survey including all city residents. We already include 500 city residents who own dogs, and the answer is telling us to include more people who own dogs. This is nonsense. And as you can see, some answers make no sense. If we include more people who own dogs, this will not go anywhere good. So we go and eliminate that answer. Now let's read C. The survey sample should have consisted entirely of residents who do not own dogs. But let's ask ourselves why. We are trying to build a survey that includes the opinion of all city residents. All city residents. It doesn't matter if they are women or men, if they are children or adults, if they have dogs or if they do not have dogs. We're trying to assess the opinion of everybody. Therefore, saying that we should include people without dogs is quite discriminating, and it's also incorrect because logically it does not make any sense. Therefore C is incorrect as well. It won't lead to a good survey. And let's read D. Well, the survey sample is biased because it is not representative of all city residents. This is exactly what we have been talking about all this time. We want to assess the opinion of all city residents, but for some reason we only go to people with dogs. So there you go. This survey should be done differently if you want to assess the opinion of everybody in that city, and therefore choice D is correct. Sometimes the answer to such questions is not stated directly in the text. The answer may say that everything here is wrong. The answer may say that this survey should be done again. So it is okay. The idea here is to choose the answer that makes the most sense. And it is your responsibility to use your reasoning and English language skills to answer such questions. Now try to read this question. Try to connect it to yourself. Try to give examples when you read this from your own life, and then we will solve it together. A market researcher selected 200 people at random from a group of people who indicated that they liked a certain book. So there are 200 people that like a certain book. Let's say this book is the Harry Potter book. Just for the sake of this example, I want to show you something. When you correlate a certain situation to your own life or to something that you already know, it becomes easier to solve. So let's say this market researcher selected 200 people that liked the Harry Potter book. Now let's continue reading. The 200 people were shown a movie based on the book, and then they were asked whether they liked or disliked the movie of that book. So those 200 people were shown the Harry Potter movie, because Harry Potter movie is based on the book, on the Harry Potter book. Well, of those surveyed, 95% said that they disliked the movie. Well, these people liked the Harry Potter book, but after watching the movie, they just say, we didn't like it. Maybe it wasn't detailed enough, or maybe it didn't really reflect the main idea of the book. Now the question starts here. Which of the following inferences can appropriately be drawn from this survey result? Let's read A. At least 95% of people who go see movies will dislike this movie. Now, does this make sense to you? To me, it doesn't. Because we're talking about all people. We're talking about any person. People that read the book and people that didn't read the book. People that came from a different country where this book may not be even available. In this choice, we're basing our assumption, the results of this research, on all types of people, not specifically people that read this book. So this is why we cannot draw such a conclusion from this survey. Because in this survey, we included people that liked this exact book. That's why A is incorrect. Now let's read B. At least 95% of people who read books will dislike this movie. Again, be doubtful. Ask yourself, which books? They read books, but did they read Harry Potter? And if yes, maybe they didn't like the book, right? We're talking about people that read books here. But in the survey, we talk about people that like the Harry Potter book. Therefore, choice B is irrelevant to our survey. Now let's read C. Most people who dislike this book will like this movie. Well, the opposite is true. Most people who like this book dislike the movie. This is exactly what the survey is about. But the opposite may not be necessarily true. Most people who dislike this book may not even go to watch the movie, right? So make such assumptions in your own head. But we must know that whatever is true in this text should be true in the answers, and whatever is in the answers may not be true in the text. So C is incorrect. Now when it comes to choice D, most people who like this book will dislike this movie. Well, this is exactly what the survey is telling us. 95% of 200 people that liked this book didn't like the movie. And this is exactly what we have been talking about from the beginning of the question. So choice D is 100% correct. It is an appropriate inference that can be drawn from this survey. So D is correct. Practice logical reasoning by yourself by solving the questions attached below, and you will be able to achieve a great success in solving the long word problems on the SAT Math. I hope this explanation was clear. Thank you for watching this, and I will see you in the next video. Welcome back. In this video you are going to learn how to solve all types of equations efficiently on the SAT exam. This is going to be our last mathematics class. Please start practicing on your own and solve as many practice problems as you can in order to reinforce the theoretical knowledge that we have covered with you all along. So this will be the most important skill. Solving all types of equations is actually extremely useful. SAT Math, in essence, is built on measuring the ability of students to solve equations, and all along we have been solving all types of equations. Roughly speaking, at least 40% of the SAT Math is composed of constructing and solving equations. We have already learned with you how to construct equations. Quadratic equations, linear equations, inequalities, polynomials, etc. Now we will look at how to solve given equations. And when we talk about solving equations, we may have 4 objectives. So 4 main objectives or aims. So we either are interested in finding the unknown, like something that we are looking for example x, y, z. We may also be interested in manipulating the unknowns that we found. So multiplying 2 unknowns or dividing them by each other. We may also state a fact about a given equation after solving it or even before solving it. What is this equation? What type of equation is this? Is it a polynomial, or is it a quadratic equation, or is it a linear equation? Or is this equation going to give us a negative or a positive result? And of course, we may be required to simplify equations, make them look more beautiful and more understandable. In this class, we're going to solve lots and lots of examples. So let's start with finding the unknown. Now you are required to simply solve for one unknown and find its value. Let's see an example. Try to solve this. Then I will give you a strategy to solve this efficiently and we will solve it together. So the strategy for this question is this. We first need to plug, then simplify, then solve. So let's plug first. We are given that x is equal to 9. So let's plug x is equal to 9. K plus 2 minus 9 is equal to 0. Now let's simplify. Let's throw this 9 to the other side. We get root k plus 2 is equal to 9. And we can simplify further by squaring both sides. That way we will get rid of the square root on the left side. We get k plus 2 is equal to 9 squared, which is 81. And last but not least, solve. So we throw 2 to the other side and we solve for k. K is equal to 81 minus 2, which is equal to 79. Choice D is correct. Here we use the plug, simplify and solve method. If you have two unknowns like k and x, and if you already have the value of one unknown, you always need to plug first. Try to solve this one by using the plug, simplify and solve method. Then we will solve it together. The system of equations above has solution x comma y. What is the value of x? Now this is a finding an unknown equation problem. So let's plug. Let's first plug. We already know what y is. Y is equal to 2x. So plug it in. We get 1 over 2 times 2x plus 2x is equal to 21 over 2. Let's multiply everything by 2, right? So the left side and the right side. The 1 over 2 and 1 over 2 on both sides will go away. So we have 2x plus 2x is equal to 21. Now let's simplify it further. So 4x is equal to 21, and now let's divide. X is equal to 21 over 4. This is your answer. Again, here we found only one unknown, and here, since we had two unknowns, y and x, we use the plug, simplify and solve method. Try to solve this problem now, then we will solve it together. In this problem, we only have one unknown, which is p. So let's first of all simplify. We do not need to plug anything. We get 2p, right? So I open this parenthesis, plus 2 plus. Now open this parenthesis, 8p minus 8. So plus 8p minus 8 is equal to 5p. Now we need to simplify a little bit more. So add the like terms. 2p, 8p, and 5p on the right side are like terms, so you can add them. We got 10p and send 5p to the other side minus 5p is equal to, now we can also add the like terms that are constant, right? So we add them, 2 minus 8, this is negative 6, and we can throw them both to the other side, so we get a positive 6. 10p minus 5p is equal to positive 6. Now we can simplify a bit further, so 5p is equal to 6, and divide both sides by 5. We get p is equal to 6 over 5, which is also equal to 1.2. So this is the correct answer. Now try to solve this problem. It's a little bit different, but I'm sure you will be able to do it. Then we will solve it together. The expression above is equivalent to this expression, where a is a positive constant and x is not equal to 2. Why does it say this? Well, they mentioned this because when you plug in x is equal to negative 2, this becomes 0, this becomes 0, and this becomes 0. That makes this whole thing 0 is equal to 0. This is why x is not equal to negative 2. Now, the question is, what is the value of a? Since we're not directly given the equation, we need to first equate, then simplify, then solve. So let's equate first. 2x plus 6 over x plus 2 squared minus 2 over x plus 2 is all equal to a divided by x plus 2 squared. Now, after equating, we need to simplify. How do we simplify? Right here, we can simplify by subtracting these fractions from each other, but they have different denominators. In order to have the same denominator on here and here, we need to multiply this expression by x plus 2 divided by x plus 2. When we multiply both of them like that, what we will get here is x plus 2 squared, since we multiplied two same things, and on the top 2 times x plus 2 times 2, which is 2x plus 4. Now we can subtract. We get 2x plus 6 minus 2x minus 4. Notice we have a subtraction of fractions, so that minus is applicable for 4 as well. So minus 4 divided by x plus 2 all in parentheses squared is equal to a over x plus 2 all in parentheses squared. So numerator here should be equal to a. By simplifying, therefore adding the like terms, 2x minus 2x gives us 0, and 6 minus 4 leaves us with 2. So since numerator on the left hand side is equal to the numerator on the right hand side, we can say that a is equal to 2. This is solving, so we solved by equating both of them. Be aware that you may get such a problem. Here you just need to equate, simplify, and solve. Now try to do this one. This one is extremely simple. So if root x plus root 9 is equal to root 64, what is the value of x? Let's simplify everything. Root x plus root 9, which is 3, is equal to root 64, which is 8. Now we throw 3 to the other side and we get root x is equal to 8 minus 3, which is 5. Then we can square both sides and we will get that x is equal to 5 squared, which is 25. So C is the correct answer. Try to solve this problem, then we will solve it together. In the equation above, p and t are constants. Which of the following could be the value of p? Now the strategy here is to simplify, compare, and then solve. So let's first simplify. We have 4x squared minus 9 simplified on the left side, and px times px, which is p squared x squared, plus px times negative t, which is negative pxt, plus t times px, which is positive pxt, minus t times t, which is minus t squared. These terms, when you add them up, they cancel out, so you get 4x squared minus 9 is equal to p squared times x squared minus t squared. Here, as the second step, we need to compare. On the left hand side, the term with the x squared has a multiple of 4. On the right hand side, the term with the x squared has a multiple p squared. Therefore, 4 is equal to p squared. And from here we can deduce that p is equal to 2. So the correct choice is 2. But let's not end this problem here. Let's compare a little bit more. The constant term, negative 9, is alone on the left hand side. On the right hand side we have negative t squared. That means we can compare them both as well. We can say negative 9 is equal to negative t squared, and from here we can say that t is equal to 3, since 3 squared will give us 9 and negative 9 is equal to negative 9. This is comparison of the left hand side and the right hand side of an equation. You should be able to do this because this is a very useful skill. Now try to solve this problem, then we will solve it together. So sometimes in finding the unknown, we get quadratic equations. We need to find x, which is going to be the root or the solution of this quadratic equation. So the first thing we do is we rewrite it on our paper. You can simplify this further by dividing everything by 4. You get x squared minus 2x minus 3 is equal to 0. Now this expression right here, you can just factorize. Right? So let's open two parentheses and let's equate everything to 0. Here we have x and x. We have negative and negative. That's why we must have a positive and a negative inside the factors. Now we need to ask ourselves, what multiplies to give negative 3 and adds to give negative 2? Well, these are negative 3 and positive 1. When you add 1 to negative 3, you get negative 2. When you multiply 1 times negative 3, you get negative 3. Therefore, the solution that will make all of this stuff 0 is either x is equal to negative 1 or x is equal to 3. So these are your solutions to the quadratic equation right here. Therefore, choice B is the correct choice. Now let's solve one last problem on finding one unknown. So try to solve this by yourself, then we will solve it together. The expression right here can be rewritten as this, where k is a positive constant. What is the value of k? Well, first of all, let's compare them. We have 1 over 3 here, and we have 1 over 3 here. So 1 over 3 x squared minus 2 is equal to 1 over 3 times x minus k times x plus k. Now let's open this parenthesis. All of that is equal to 1 over 3 multiplied by x squared plus x times k minus x times k minus k squared. These two terms will add to give us 0, so we can just cross them out and we get all of this is equal to 1 over 3 times x squared in parentheses minus k squared. And we can simplify this further. We can say that all of this is equal to 1 over 3 x squared minus 1 over 3 k squared. Now let's compare both sides. We have 1 over 3x squared here and 1 over 3x squared here. So these are correct. Also, we have negative 2 here and negative 1 over 3k squared here. So we need to compare them. We need to equate them to each other. Negative 2 is equal to negative 1 over 3k squared. In order to solve for x, let's simplify by rearranging. Multiply both sides by 3. These 3's cancel, and you get negative 6 is equal to negative k squared. By the way, multiplication was in a parenthesis, so you multiply both sides. Now, we get negative 6 is equal to negative k squared. Well, negative on both sides can go away, because we can multiply both sides by negative 1. We get 6 is equal to k squared. By taking square root of both sides, square root of 6 is equal to square root of k squared, and square root of k squared is just k. So k is equal to root 6. The correct choice is D. Now let's see another type of problems on the SAT, where we need to solve something. It is called manipulation. So we find one or two values, and after that we do something with them. We found y and k, and we either need to multiply y times k, or we need to divide and get y over k, or add or subtract or whatever. We need to do something with both values. So let's see an example. Try to read this one and try to solve it by yourself. So if xy is a solution of the system of equations here, and if x is larger than 0, what is the value of x multiplied by y? First, let's try to solve for one of the unknowns. Let's plug y is equal to x squared instead of y. So we get 2 times x squared plus 6 is equal to 2 times x plus 3 in parentheses. Let's simplify. 2x squared plus 6 is equal to 2x plus 6. 6's on both sides cancel, and we get 2x squared minus 2x is equal to 0. Notice I just threw 2x to the other side. This is a quadratic equation where c is equal to 0. So if you remember the 4th class, here we can use simplification. So take 2x out of the parentheses and we get x minus 1. That means in order to satisfy all of this equal to 0, we either need x to be equal to 0 or x to be equal to 1. And the question clearly states that x is larger than 0. So this cannot be the solution. Therefore, x is equal to 1. Now we plug it back. We know that y is equal to x squared. So y is equal to 1 squared. And therefore y is equal to 1. So y is also 1. We need to manipulate x times y. We need to multiply these both values. So we get 1 multiplied by 1. The correct answer is A. Here we solved a system of equations. We had one parabola right here and one linear equation. Then we manipulated the solution by multiplying. Be very careful, because sometimes you're not only asked to solve for one unknown, sometimes you're even asked to multiply them or divide them. Therefore, you need to read the question carefully. Try to solve this problem, then we will solve it together. If a squared plus b squared is equal to z and a multiplied by b is equal to y, which of the following is equivalent to this expression? Now let's rewrite this. We need to find what is equal to this. So we can rewrite it. 4 multiplied by, instead of z, we can plug a squared plus b squared, because in the answers we only have a and b. We're not dealing with z or y. So 4 times a squared plus b squared plus 8 multiplied by y, and y is a times b, so 8 multiplied by a times b. Now we can simplify all of this. We get 4a squared plus 4b squared plus 8 times a times b. Let's rewrite it in a more familiar form. We get 4a squared plus 8ab plus 4b squared. We sort of get a quadratic equation. Now, let's try and factorize this into a perfect square, because answers are written in the form of a perfect square. So let's factorize. We are going to have two same factors. What two same things multiply to give 4a squared? That is 2a and 2a. Now we ask ourselves, what two things multiply to give 4b squared? Since this is a perfect square, we only look at this and this, right? So use this strategy. So what two things multiply to give us 4b squared? Those two things must be the same. Well, we get 2b and 2b. If you don't believe me, open this parenthesis and you will see that you get exactly this, all of this stuff. So we have factorized to a perfect square. And we can even rewrite this as 2a plus 2b all squared. Therefore, the correct choice is B. The strategy in such questions is this. If you do not see z or y in the answers, you need to just plug everything that you're given. So use this information for your own benefit. Now try to solve this one, then we will solve it together. So the question is, what is the sum of solutions to this quadratic equation? This is a factorized quadratic equation. The solutions, or the zeros or the roots, are going to be x is equal to 6 right here and x is equal to negative 0.7, because when you plug them in you get 0 in both parentheses. Now when we sum these up, we get x minus 0.7, and that gives us 5.3. So the sum of the solutions to this quadratic equation in a factorized form is 5.3. Therefore, choice C is correct. Try to solve this one. This will be our last manipulation problem. Then we will solve it together. So if a minus b is equal to 12 and b over 2 is equal to 10, what is the value of a plus b? Let's first of all find b, because this is an equation with one unknown. So b over 2 is equal to 10. Multiply both sides by 2, you get b is equal to 20. So we already found b. We can plug it in here, right? We can plug it and we can find that a minus 20 is equal to 12. So a is equal to 20 plus 12, which is 32. We found a as well. Now we're asked about the sum of a and b. So 20 plus 32 gives us 52. Therefore, D is the correct choice. These were the manipulation problems. Please read the questions carefully on the SAT, not to miss those details. Now let's talk about simple equation problems where you just need to state a fact about an equation. We need to find what is true about the given equation in such problems, and this requires using common sense and your abilities to solve equations. Here, you need to understand the question correctly. So let's see an example. For what value of x is the function h above undefined? For example, in this problem, we are asked about some value of x for which this whole function is undefined. You need to remember that undefined means one function divided by 0, right? So when we have a 0 on the denominator, your function becomes undefined. Therefore, we need to find value of x that will make all of this equal to 0 and therefore make our function undefined. It will be a fact, so x at that point will make this thing undefined. Now let's try and find that value of x. So let's first simplify the denominator. We have x minus 5 squared plus 4 in parentheses x minus 5 plus 4. Let's first simplify this, as I said. So we got x squared minus 10x plus 25 plus 4x minus 20 plus 4. Now let's add the like terms. Negative 10x and 4x add up to give us negative 6x, and 25, negative 20 and 4 add up to give us 9. Now all of this stuff we equate to 0 because we want to find x values that will make all of this 0. Now we can use the factorization method here. So let's factorize this quadratic equation here. It is going to be equal to x and x on the other parenthesis minus 3 minus 3, because when we multiply negative 3 by negative 3 we get 9, when we add them we get negative 6. So we need x to be equal to 3 to be able to get a 0 on the denominator. Therefore here x must be equal to 3. So when we plug in x is equal to 3, this function becomes undefined. Therefore h of 3 is undefined. This is a type of problem where you need to know the convention, the method, or a term. Only then you can state a fact or find for which value the fact holds true. Now what about other problems? Well, read this one and try to solve it by yourself. Then we will solve it together. In the equation above, if a is negative, so if a is less than 0 and b is positive, that means b is larger than 0, which of the following must be true? Well, let's first of all give our own numbers here. In order to understand what must be true, we need to try solving this with our own numbers. Plugging any number, as long as it satisfies the condition that a is negative and b is positive, will give us the correct answer. So let's say a is equal to negative 2 and b is equal to 4, just for the sake of this example. So a is less than 0 and b is larger than 0. Now plug them in here. We get negative 2 minus 4 divided by negative 2. That gives us negative 6 divided by negative 2, and that gives us positive 3. So this is equal to c, because c is the result of this expression. Now c is positive, therefore we can say that c is larger than 1. Well, c is not necessarily equal to 1, also c is not negative 1, and as we can see here, c is not less than negative 1. Therefore c is larger than 1. So to solve this equation, all you have to know is that negative number divided by negative number gives you a positive number. And of course we may get c is equal to 1 somehow, but that does not necessarily mean that c can only be 1. C can be any sort of value that is larger than 1 as well. Be careful in such problems, because here you're asked about what must be true. Therefore, find what must be true in any case. You can even plug a is equal to negative 6 and b is equal to 5. What we will get is negative 6 minus 5 divided by negative 6. That gives us 11 divided by 6, and this is equal to c, and again we get c as a positive value, as a positive number. Now let's talk about simplifying equations. Well, simplification is just making equations more beautiful, and this is what we have been doing all along. So work step by step. Open the parentheses of an equation, spread all values in the parentheses, and add like terms. You can practice this method literally in any problem that you get that involves equations. So let's see, which of the following is equivalent to this expression right here? 3 times x plus 5 in parentheses minus 6. We just first open the parentheses and spread all values, right? So we get 3x plus 15 minus 6. Then we add the like terms, so we get 3x plus 9. And this is the simplified version of this expression. Therefore, they are equivalent. They are the same. Now, try to do this one. Then we will solve it together. Here, you are also required to simplify. So let's go step by step. Let's first simplify this expression right here. 1.5x minus 2.4 squared is actually multiplication of the same parentheses. Now let's multiply and therefore simplify this expression. We multiply each term one by one. So let's spread everything here. We get 1.5x times 1.5x, which is 2.25x squared, 1.5x times negative 2.4, which is minus 3.6x, another one of those, again minus 3.6x, and negative 2.4 times negative 2.4, which gives you plus 5.76. Now you need to subtract this here from this expression. So we subtract minus 5.2x squared minus 6.4, which is plus 6.4. When we add the like terms, we get minus 2.95x squared, this is the summation of this and this, minus 3.6x minus 3.6x gives us minus 7.2x, and 5.76 plus 6.4 gives us positive 12.16. So this is the simplified form of this expression right here. Therefore, the correct answer is choice C. And now I have some amazing news for you. We are done, woohoo! But only with the theory of mathematics. Big thanks to you for joining these classes and listening to each and every single video one by one. I really enjoyed teaching you, and I hope that you enjoyed learning as well. Well, I think you did, because this course was quite involved but interesting. Now, I want you to remember something. Theory is useless until you practice and learn how to use it. So please solve as many practice problems as possible. You should really work hard by yourself. You have all the time and all the opportunities in the world. Nothing can stop you, and you can achieve anything that you want in this life. Thank you for watching this video, and make sure to watch the next video in the last section of this mathematics course, which is going to contain lots of useful strategies for your exam day. Take care, work hard, and achieve good scores. Hello and welcome back. I have some good news for you. As opposed to all the other videos on this website, this is not a mathematics topic video. This is a strategic video made for students that are going to write the SAT exam. This video will be useful to anybody that has to go through the SAT and that is going through stress or anxiety. Now, number one, don't feel excited and don't feel anxious. SAT is just an exam, just like any other exam you are going to take in your life. Of course, it is quite serious, but it's not a good enough reason for you to be worried or anxious. So feel comfortable, feel relaxed, and most importantly, trust yourself. You will be able to do it. But at the same time, work hard, because hard work pays off, and it will pay off during the exam. This video will contain advice for my students that will be useful a few weeks before the exam and on the exam day. So let's start. The first thing I want to make clear is, why is my advice important? Well, the reason my advice is important is because I know what the SAT exam is, and I have been through it 3 times. I know how students feel during the exam, because I go through exams every single day. I study aerospace engineering at Middle East Technical University, and it's not easy. So I understand the anxiety that you have, and I understand that you feel somehow uncertain. Believe me, it is completely okay. Everybody feels that way. All you have to do is trust yourself. You will be able to achieve anything so long as you work hard and put in the work. Now, feeling comfortable during the exam is extremely important. The reason being, you're going to be sitting for 3 to 4 hours, and you're going to be focused, and you will be required to answer all of the questions on the SAT. So how do we focus our thoughts and our mindset to comfort? Well, here are a few suggestions. Number 1, realize that you're in the exam and that all of the work that you do at that moment is going to be very useful for you in the future. Number 2, don't stress, and whenever you feel like you're stressing, take a deep breath, let it all go, and relax. And number 3, understand that you're not alone. Everybody is going through the same thing in that room. So feeling stressed or feeling anxious will not help. Understand that an exam is just a 3-hour test that is going to show many schools your potential. So you have to show your best potential during the exam. Now, how do we do the final preparation for the SAT exam? After all, final preparation is the most important preparation. Well, final preparation should be done 1 week prior the test. But if you have a lot of time, start doing this 2 weeks before the test. Well, SAT takes place on Saturdays. Therefore, your whole week before SAT, you should be solving practice tests. Solving practice tests will get you used to the exam atmosphere and help your brain build strength on concentrating. You have to get yourself used to solving exams for at least 3 hours and concentrating on problems. Now, why do we solve practice tests even if you solved them? Why would you solve them again? Well, you need to solve at least one practice test for 4 days before the SAT to get used to test solving atmosphere and stress, because this will allow you to manage your time better, feel more comfortable during the actual exam, and feel familiarized with the situation and the exam atmosphere. Solving tests again will remind you of all possible questions that could come out on the SAT, and reading the verbal section will increase your ability to focus and concentrate. Another very important thing to do before the exam is to memorize all math formulas. They all need to be memorized, because you do not have them on the SAT exam paper, that is your booklet. Therefore, you need to know them by heart. You need to keep them in your mind, and you need to be able to use them without looking at your notes or at your cheat sheets. You will find all formulas in the course videos on this website, so you can go ahead and write them all down and start memorizing if you haven't done so yet. For the English sections, you have to go through all the vocabulary that you have memorized once again. So go through all of the words that you have memorized and repeat all of them again. Also, repeat grammar rules that you have learned and make sure that you're able to spot mistakes. Well, this will be very useful for your SAT writing and language section, and make sure that you're able to use the words that you have learned correctly. This will be useful for both writing and the reading sections. Repeat and practice the strategies that you have learned as well. So if you have learned to apply different strategies to different question types, then you should definitely repeat those and practice as well. Now, when it comes to the day before the exam, well, this is going to be quite a critical day. On that day, as opposed to many students believe, you should actually relax. Many students go and study on that day, but this is actually the worst time to study. So you should relax, sleep all day, and make sure you get your rest. You can also spend time with your family and friends, but don't hang out till the night. You will need the night for sleep. Now, why do I say relax and not study? Well, this is because marathon runners, for example, they don't run the day before the race. They get a rest and gather energy, and on the day of the race, they run their best. The same thing goes for exams. The day before the exam, of course, you should repeat formulas and words and make sure that you remember everything, but at the same time, don't tire your brain and don't waste your energy. You will definitely need that energy during the exam. So instead, take a little break, relax, sleep, and make sure you get your rest. This is quite important. Do whatever you like doing. Eat good food and enjoy your time. Focus your mindset on the fact that on the next day you are going to have an exam and it's going to be quite important for your success. Be very aware that your performance on the exam day will affect your grade immensely. This is why you need to save up energy for a good performance. One very big mistake that many students commit before the exam is drinking coffee and energy drinks all day, every day. Well, look, you should not drink coffee or any other energy drinks the day before the exam. Before the exam, you really need to get a good rest. Drinking these energy drinks or coffee will let your body get more energized. The caffeine in those drinks will add lack of will to sleep. That means you will not want to sleep after drinking such drinks. And of course, other hormones in such drinks may cause adrenaline, which is going to get you more excited. So really, drinking those drinks the day before the exam will make absolutely no sense. You want to stay away from them because you will have to sleep and get your rest. So the day before the exam, don't consume energy drinks or coffee. Of course, you should make sure that you have two working calculators. One of them can be scientific, like shown here, and the other one can be a basic backup calculator in case you break or forget the other one, or if the battery of the other one dies. You already know that you need a scientific calculator for the SAT calculator section, and make sure you have one extra calculator just in case. Some good calculators are attached below this video. So by searching for a good calculator and buying one, you can save a lot of time on the SAT math section. Make sure you have your pencils and erasers ready. Well, you need to prepare your pencils, sharpeners and erasers the day before the exam. Don't forget to put them in your bag and bring two of each one of those. In case one of them is lost or one of them is broken, you can use the other one. That goes for the pencils, the erasers and the pencil sharpeners. Please do not forget your exam ticket and your ID or the passport. The passport will help you get into the exam room by proving that it is actually you who bought the ticket. And the ticket, the SAT ticket, is going to verify that you have actually paid for the SAT and that you are eligible to take that exam. So do not forget those two items. And if you do, well, then you won't be able to get into the exam room. So please put them in your bag the day before the exam. Now we have come to the exam day. Well, this day might seem exciting and it's okay, but I want you not to panic. Please be relaxed and trust yourself. Trust the fact that you are going to get a good score, because you are going to get a good score. Wake up early, so you need to set your alarm so that you would wake up at least 3 hours before the exam. Make sure you know the location of the exam and be there earlier than you should. Do not be late under any circumstances. Go there 2 hours before the exam starts if possible. Try to get used to the location, look around yourself, and get used to the fact that in a few minutes you're going to work your brain really hard. Have a good breakfast. You will be sitting in the exam room for at least 3 to 4 hours, so make sure you eat something before that. Usually a great breakfast consists of proteins like eggs or beans, or meat, some vitamins like vegetables or fruits, and caffeine like coffee or green tea. Also, on the exam day, you should take a few things with you. Take a cup of coffee with you, and it will help you prevent sleepiness during the exam or before the exam. Make sure that you bring at least 3 bottles of water with you, and bring an apple or a chocolate bar to eat during the break if you ever get hungry. Coffee will help you to stay awake, but if you prefer green tea, then it's completely okay, as long as it helps you stay awake and prevents sleepiness. Water will keep you hydrated and it will keep your brain running. It will also give your body and the blood oxygen that you need. And of course the snacks, they will prevent hunger, and chocolate will help you to think. So bring those things with you and you're going to thank me later. During the exam, you should make sure that you use your time right. You should be calm. Don't panic under any circumstances. Now, how is it possible not to panic? Well, remind yourself that this exam is a short exam. It's not going to take all of your life, and all you have to do is just focus for 3 to 4 hours and do your best. After that, you're free. So it is completely worth it to go through this exam, because you are going to show your potential to the universities around the world. Understand that all of your performance is required in this exam. So panicking will not help. But thinking clearly and being focused and concentrated will help a lot. Drink water whenever you feel thirsty or anxious, but do not drink too much because you will want to go to toilet. So manage your water carefully. Also, sit comfortably. Don't bend like a snail or don't wear stuff on the exam day that is going to make it uncomfortable for you to sit for 3 hours. Wear comfortable stuff like pajamas or sports shoes or whatever. Whatever makes you feel comfortable and at home, wear that stuff because it's going to affect your performance in a very good way. Also, you should not look around at other people or at their papers. You should mind your own business because this exam is your exam. The exam of others is their own exam. You should be concentrated on your own work throughout the exam. Feel like nobody else is around you. Feel like you are alone, but at the same time, be mindful that you do not have to make a lot of noise in order for other people to be able to focus during the exam. Now, let me tell you why panicking is a very bad idea. Our brains consist of neurons. Neurons are little particles that help us think. Well, you can think of them like that. So each one of those contains some information, like an equation or maybe a word or a method to solve a problem. And those neurons interact with each other to help you think clearly. All of your memory is loaded in those neurons. Now, when you panic, your body starts producing the adrenaline hormone, and the adrenaline hormone prevents neurons from working properly. What happens then is you lose your focus, you lose your concentration, you start forgetting equations, and you basically forget what you were doing or what you were reading. This is why. Learn to be concentrated and learn to be relaxed. It is extremely important to feel comfortable and to feel relaxed during the exam. That way, you will ensure that your brain functions correctly and therefore you're able to solve all the questions. Be focused on the questions, get immersed in the texts, and feel like exam is a game that you have to win in. This will make it more fun to solve. I wish you good luck, and I am 100% sure that you will be able to do it because it's not hard. You have been preparing for months and months, and maybe you have been memorizing words and equations all along. If you have practiced enough and if you solved enough problems, you should be sure that you will be able to solve the exam as well. After all, it's just another practice test for you. So don't be afraid, be sure that you will be able to succeed, trust yourself, and remember, I believe in you, so you should believe in yourself as well. Good luck in the exam, and I hope you get the highest score possible. Thank you for watching this video, and remember, hard work pays off.